okay, this 65 is in the particular character range or not. If it is in the expected range, then we will accept it, otherwise we will reject it. ASCII means American Standard Code for Information Interchange. As per that, every alphabet or every number is having a particular number. Every digit and alphabet is having a particular number. For example, 65 is for alphabet A, uppercase A. So in the continuous manner, capital B is nothing but 66, capital C is nothing but 67, and so on. And lowercase alphabets are A to Z is equal to 97 to 122, and 0 to 9 digits are 48 to 57. Backspace is 8. Okay, space is 32. These are the important characters. So based on this ASCII value, we can keep the condition and we can prevent entry of unwanted characters. So let us see how to do all these things. So there is a website like ASCIItable.com. Have a look at once, ASCIItable.com. So this is basically the ASCIItable.com website. So check it. What are the alphabets and digits? Identify them. Alphabets and digits. Check for it. Yes, uppercase alphabets are 65 to 90. Check it. Uppercase A is 65, and continuous manner uppercase Z is 90. So 65 to 90 is uppercase characters. 97 to 122 is lowercase characters. 48 to 57 is 0 to 9. And 8 is a backspace, 32 is a space. So these numbers internally will be stored in the memory. First of all, these will be converted into the binary number system, and the binary numbers will be stored in the computer memory. But anyways, so as a developer, we need not worry about the binary number system here. We have to consider using only the ASCII value. So let's have a requirement such that I want to accept alphabets only. By using key press event, I want to accept alphabets only. Let's see how to do it. Key press alphabets only. Even the user is typing other symbols, I don't want to accept it at all. Then what exactly we have to try to do? There is something called event argument. This event argument is giving the browser given information. Some information will be given by the browser automatically, that is called event. I am pressing A. So the event argument that we have is target is a text box, key is A, and char code is 97. Okay, key code is 0. So which means that it is providing some which key is pressed, that information it is providing. Inside that we have a property called which property. Okay, the which property will give you ASCII value of the currently pressed character. This one 97. We have to check that which property. If event dot which is between 97 to and 122, or if it is between 65 to 90, that is uppercase letters, or if it is 32 or 8. In all these cases, what we have to try to do is that just we have to say accept. For accepting, there is no specific code, but for rejecting, there is a code. Event.prevent default will reject the currently pressed character. In order to reject the currently pressed character, we have to use event.prevent default. So whichever currently pressed, whichever the character currently pressed, that will be cancelled, will not be present in the text box. Now check it. So just we have alphabet A, B, uppercase, lowercase, everything we can type. But I am typing digits, I am typing special characters, so it's not placing at all. So if I type alphabets, spaces, backspace, it is accepting. If I type other than that, like digits or symbols, it's not accepting. This is how to prevent entry of invalid characters by using the key press event. Okay, the next one is key up event, right? After the key press, the immediate next event is key up event. So key up event also very similar to key press event. Check it, key up. When the user presses any key on the keyboard, key up event executes. So then what is the difference between key press and key up? What could be the difference? So for both the description is same. The exact difference is key press event executes before accepting the currently pressed character, key up event executes after. So let's write it here. Executes before accepting the currently pressed character in the text box. See, fundamentally it executes only when the user presses any key on the keyboard, that too exactly when before accepting the currently pressed character, key press event executes. And this will executes after accepting the currently pressed character in the text box, the key up event executes. Okay, before accepting key press, after accepting key up. Okay, the flow is like user presses some key. So, for example, user has pressed A. So, the initial value of text box is empty. Okay, text box is empty. Then the key press event executes, and then text box become A, and then key up event executes. So this is the sequence. Have a look at once. First, user presses any key on the keyboard, for example A, alphabet A. Before accepting A, the text box was empty. Actually, on the empty text box, like this. First, on the empty text box, user has pressed the alphabet A, then the key press event executes, then the A will be accepted in the text box, then the key up event executes. Okay, this is the sequence. Okay, right. Now let's understand the difference and after. So before accepting as a key press event executes, there is a possibility of rejecting the currently pressed character. Such a facility is not there in the key up. But if you want to do any calculation processing including the latest character, then we have to use key up event. So let's check it once. Key up event. For example, whenever the user press any key on the keyboard, I just want to capture the value. So I'm just saying key up, then we are displaying the value, that is console.log of the text box value, get element by id of txt1 dot value. So after accepting the currently pressed character, this value will execute. So A, B, C, D, E. So as soon as we type some character, the latest value is being captured and displayed here. So basically, if you have any calculations to perform, we can do the, for example, user is going to enter the amount. So you want to display its interest. Below the text box, you want to display the interest value. For example, interest value is some 10% you want to display. So what will you do? First, get the amount value txt1 dot value, and this must be converted into number because value is by default string data type. That's why we have to convert the same into number data type by using the number function. Then the price is equal to, interest is equal to amount into 10 by 100, and we are going to display the latest value in the third text box, in the second text box. Okay, so we have done some calculation and displaying the same, but when this calculation should occur only when the user types some value in the text box. So I'm just typing some value 5000. Immediately it is going to display some 50%, 10% of that, that is 500. So the corresponding interest value is being displayed. Okay, so this is about the key up event. The next event is change event. The change event executes whenever the user selects an item in the drop down list. Executes when the user selects an item in the drop down list or changes the value of any form element, not only for a drop down list but also for text box, check box, radio button. So for any kind of item, some selection or some value has been changed by the user, automatically the change event executes. For example, we have selected a checkbox, we have selected a radio button, we have typed some value in the text box. Any kind of value changes, the change event executes. Okay, the syntax for that is change function. So let me show an example on this change event. So change event, suppose let's say for example we have an option like we have a drop down list, id equal to drop down list 1. For example, we have country, we have a drop down list called country, and we are going to display the list of countries. Suppose country 1, 2, 3 like this, and as a part of this we are going to display the list of states. 3 countries we have. Okay, now so for the drop down list 1, which event you are going to handle? Change event. There we are going to get the currently selected country. Country is equal to document.get element by id of drop down list 1 dot value, and below we are going to display some UL, unordered list, to display the states. So first document.get element by id of the list 1 should be empty, inner HTML should be empty. So whatever present in the UL, that will be empty, and then we are going to check if the country is equal to the country 1. In the UL we are going to display state 1, state 2, state 3, state 4. Okay, 3 states enough. State 1, 2, 3 is going to appear here. Else, if it is equal to country 2, okay, we are going to write the code like state 4, 5, 6. Okay, just I am showing some dummy data, not the actual names. Next, country 3 means state 7, 8 and 9. So check it now. I am just selecting country 1, so state 1, 2, 3, country 2, state 4, 5, 6, country 3, state 789, and in this case no data is up here. Okay, that's done. So we have successfully created the country drop down. So based on the selection it is showing whatever you wish. That's fine. So this is about the all the list of events. So we have understood click event. When the user clicks on the element, the click event executes. When the user double click event executes. When the user selects some item in the drop down list or selects some checkbox or radio button, or also the change event executes. When the cursor enter into the text box, focus event. When the cursor goes out of the text box, blur event. Basically vertical blinking line is nothing but cursor. And we have events like focus and blur events. When the cursor in focus event, when the cursor goes out, blur events. Also next key press and key up events we have. When the user presses any key on the keyboard, first key press event executes, then the character accepted in the text box, then the next key up event executes. So these are the several events available. So all these events can be handled by using add event listener function only. Add event listener, first event name within the double quotes, then the function name we have to provide. And before doing the add event listener, first we have to get the element either based on ID or class name or tag name. Several ways of getting I told already. So by any way we have to get the appropriate element, then only we have to use the appropriate add event listener function. So this is all about the DOM manipulations topic. In the next class we will meet with the other lesson. Thank you.
Hello students, welcome to the C language training program. Today I want to discuss about sorting algorithms or sorting methods. C programming language, which are the different type of sorting techniques or sorting algorithms that I want to discuss. The last session I discussed about searching techniques. What is meant by search? To find an element, the given array list, that process called as searching. Searching techniques are two types are there: linear search, binary search. What is meant by linear search? The given array list of elements, key element is matching or not, line by line to be traced. First I want to read the array list, after that I want to enter the key element. In that array list, any one element is matching, then only search is success. What is the drawback of linear search? Line by line to search the elements. From the beginning to wherever the element is found, until that line by line to search the process. And what is one more drawback of linear search? It's a time consuming process. If I have heavy list of elements, at that time it's time taking process. The elements also may be sorted, may not be sorted. There is no guarantee all elements should be sorted. What is the advantage of binary search? Whenever heavy list of elements are there, first you want to divide the list two parts based on the mid element. How to find out the mid element? First element index plus last element index divided by 2. If the key element is lesser than mid element, just you can move on the left side list. If the key element is greater than mid element, you have to move on the right side list. Whenever key element is exactly matching of mid element, return the mid index. Compare to linear search, binary search, very easy to search the element and quickly to access the element. One more advantage, the element should be sorted order, then only to follow the binary search. Now today I want to discuss C language data type, C language data structures, sorting techniques. What is meant by sorting? The list of elements arranged in order, either ascending order or descending order. If I want to arrange the list of elements in order, that is called as sorting. If you want to sort the list of elements, you have a different type of algorithms. Under C language data structures, different algorithms will be giving or different methods will be giving. Based on that algorithm, you can sort the elements. What are the types of sorting algorithms? The first type of sorting, bubble sort algorithm. Totally 5 types of sorting techniques we have: bubble sort, selection sort, insertion sort, merge sort, heap sort. Bubble sort, selection sort, insertion sort, merge sort and a quick sort. Heap sort is there, but that is a tree based sorting. It's working based on the tree. What is the first type of sorting technique? Bubble sort. How to arrange the elements in sorted order using bubble sort. What is the logic of bubble sort? The pair elements to be compared, pair wise to be compared. First to be compare first and second element. If the first element is greater than second element, interchange the elements. Similarly, second and third element to be check. If the second element is greater than third element, interchange the elements. Until all elements to be sorted, you have to move on the process. In the first pass, which is the highest element, it is bubbled at last. In the second pass, which is the second highest, that is bubbled at the last second position. In the third pass, which is the third highest element, bubbled at the last third position. Similarly, all passes will be processed. Compared to other sorting algorithms, bubble sort algorithm very easy to process and easy to sort the elements. If I have n number of elements, my n value 10 suppose, how many passes require? 9 passes, n minus 1 passes required. You see the syntax and the program of the bubble sort, the functionality of the bubble sort. You see the bubble sort. What is the algorithm to is? We assume the list is an array of n number of elements. We further assume that which function to be used? Swap function. What is meant by swap function? To arrange the elements, the given array elements, to arrange the elements, the list of elements to be interchange the positions. Swap function logic, if the first element greater than second element, interchange. Third element greater than fourth element, interchange. Similarly, remaining all elements until all elements to be sorted. You see that what is a bubble sort logic? For all elements of the list, if the list of I called as index value, initial I is 0. If the list of I greater than list of I plus 1, what is meant by list of I? List of 0, first element. List of I plus 1 called as second element. If the first element is greater than second element, swap function to be run. Which element to be swap? List of I comma list of I plus 1. List of 0 comma list of 0 plus 1 1. If the first element greater than second element, swap the elements. Similarly, if the second element greater than third element, swap the elements. Until that you want to continue the process. Finally, to return the list. You see the logic of function of bubble sort. Void bubble sort. Int A is an array. Now in this logic, A is an array here. Now int size means array size. Now here, what is the logic of that? First I want to verify I equal to 0, I less than size, I plus plus. Now here I for index. Index is initially 0, 0 less than size, index plus plus. J equal to 0, j less than size minus 1. What is the logic here? A of j greater than A of j plus 1. What is meant by A of j? A of j called as initially 0. A of j called as A of 0. After that 0 plus 1, 1. Initially which element will be compare? First and second elements. 0 for first, 1 for second. If the condition is true, now I want to swap the elements. Temp equal to A of j. Under A of j, which to be move on? J plus 1. under A of j plus 1, which to be moved on? Temp. Whenever A of j greater than A of j plus 1, interchange the positions. First element position second, second element position first. Similarly, the same list of elements to be processed. Whenever the first two elements are compared, move on the j plus plus. Every nested for loop, first j increments. Next j is 1, 1 plus 1, 2. Next j is 2, 2 plus 1, 3, like this. Like this, internally all elements will be sorted. Finally, your elements will be sorted in the bubble sort. You see that how it is processed actually here. If I have some elements, what is my elements I created? Suppose I have 4 elements. Suppose what is my elements? 5, 7, 10, 4, 2. These are my elements. 5 elements I taken here. 5, 7, 10, 4, 2. How to work the bubble sort logic here? When I work with bubble sort, first 2 elements to be compared. 5 greater than 7, condition false. 5 greater than 7, condition false. 7 greater than 10, condition false. 10 greater than 4, condition true. Whenever condition true, interchange the elements. 10 and 4 interchanges. What is the logic now here? 5, 7 after interchange. 5, 7, 4, 10, 2. After that 10 and 2 to be compared. 10 greater than 2, condition true, interchange. 5, 7, 4, 2, 10. At that time, which pass is over? Pass 1. Pass 1 completes. Pass 1 completes. Under pass 1, which elements will be, which element is correctly positioned? 10. Now, in this process, 10 is correctly bubbled. What is meant by bubbled? The 10 element is correctly positioned. The 10 element is correctly positioned in your list. Next, I want to work with the second pass. Second pass, 5, 7, 4, 2. In that now, which to be compared here? 5 and 7. 5 greater than 7, false. 7 greater than 4, yes, true. These two elements to be compared. 7 and 4 to be compared. 7 greater than 4, true. Swap the elements. 5, 4, 7. Comparison. Swap the elements 2. In this pass only 7 and 2. 7 greater than 2. Yes, true. At the time 5, 4, 2, 7. At the time which pass is over? Pass 2. Pass 2 completes. In the pass 1, 10 element is correctly positioned. In the pass 2, which element is correctly positioned? 7. 7 element is correctly positioned. 7 element is processed. 7 element is bubbled. Coming to the next pass, coming to the next elements, 5, 4, 2. In the next 5 greater than 4, condition true. Whenever condition true, swap the elements. 4, 5, 2. 4, 5, 2 and 5 greater than 2, yes, condition true, swap the elements. At the time 4, 2, 5. Now in this pass, now here this pass is completes, pass 3 completes. In this pass, which element is correctly bubble? 5 element is correctly bubble, 5 elements. Coming to the next pass, the last pass, because I have 4 elements, sorry, I have 5 elements. How many passes require now? 4 passes. Last pass. 4, 2. In that 4 and 2, 4 greater than 2. Condition true. Whenever condition true, 2, 4. Now here which pass also completes? Pass 4 also completes. At that time which element is correctly positioned? 4. 4 is correctly positioned. Finally, what are my elements coming here? Last position 10, last second position 7, last third position 5, last fourth position 4, first position 2. Finally, what is my list of elements after sorting? 2, 4, 2, 4, 5, 7, 10. This is correct order. This is sorted order. Now here that sorted order. That is a process of bubble sort technique. If I have n number of elements, what is my n value? 5, n equal to 5, how many passes it will be taking here? 4 passes will be there. Passes equal to n minus 1. I mean number of steps n minus 1, 4 passes. This is the logic of bubble sort. Now I want to move on the next sorting technique. What is my next sorting technique? I have insertion sort. What is the logic of insertion sort here? Listen, what is the logic of insertion sort? Now we have the bigger picture of the how it is sorting the technique. We can derive simple steps of insertion sort. Step number 1, if it is the first element is inserted, it is already sorted. What is the logic of insertion sort? Very beginning element, first insert first element, already that is sorted. After that, second, what is the second step? Pick the next element. In the step number 1, please insert first element, that is already sorted. In the second step, pick the next element. Pick the next element, that is compare to the previous elements, that is compare with the previous elements. If it is lesser, move to the left side. If it is greater, move to the right side. Compare with all elements in the sorted sublist. Remaining all elements to be compared. The next element will be compared to the remaining all elements. Now, what is the step number 4? Shift all the elements in the sorted order. Based on that position only to shift that. Finally, sublist is greater than value to be sorted. Whenever sublist is greater than to the value to be sorted, then stop the process. Insert the value. Now, you see that repeat the same process until list is sorted. Repeat the same process until list is sorted. Again, same steps will be repeated. What is the logic of insertion sort? First insert the first element. First element, after that pick the next element, compare with other elements. Wherever the position is there, that position you want to shift the elements. Similarly, remaining elements also to be shifted wherever correct position. If it is greater, left side list. If it is lesser, right side list. Insert the value and you want to repeat the same process. You see that how it is working of insertion sort algorithm. Now, how it is works for insertion sort. Actually, this is the bubble sort. The previously the logic is bubble. How it is works for insertion sort. Suppose I taken with some list of elements. Similarly, the previous. I am creating with 5, 3, 5, 3, 10, 2, 4. These are my elements, 5 elements. How it is work with insertion sort? First very beginning element, 5 to be insert. What is my next element? 3. Insertion sort logic, pick the first element that should be compared to the next element. Now, this 3 is less than 5, this 3 will be positioned to the left side of 3. Now, this 3 will be move on to the left side of 3. Left side of 3, this is the marker of insertion sort, where to be put. Now, what is my elements? 3, what is my elements? 3, 5. Otherwise, like this also use. First, I want to insert 5, 3. 3 to be compared to the 10. Is the 10 is less than 3? Yes. Next, 3 to be compared to the 2. Now, 3 is greater than 2 or not? Yes. And 3 is compared to the 4. It is less than. I mean, where it will be inserted now? 3 less than 3 is less than 5, that should be insert left position. After that, which pass is over? Pass 1. Now, I want to go for next. What is my next pass? Already 3 will be inserted, 5 will be inserted. Moving on the next element 10. Now, I want to next element to be insert 10. Now, for the 10 compare to the 5, 10 compare to the 3. Now, the 10 is greater than 3, 10 is greater than 5. Where to be positioned? Right side of 5. 3, 5, 10. Now, which pass is over? Pass 2. Pass 2 is complete. Next, I want to insert 3, 5, 10. What is my next element? I want to insert 2. Now, my next element is 2. 2 to be compared. This 2 element to be compared with 3. Is it 2 is less than 3? Yes. There only stopping. 2 will be there inserted here. 2, 3, 5, 10. At that time, which pass is completed here? Pass 3. Pass 3 completes. After that, last pass 2, 3, 5, 10. I want to insert 4. 4 to be compared to the 2, 4 is greater than 2, 4 to be compared to the 3, 4 is greater than 3, 4 to be compared to the 5, 4 is less than 5, greater than 3, less than 5, this position to insert. In between of 2 and 3, what is the final list I have? 2, 3, 4, 5, 10. This is my final list, pass number 4, final list. This is the logic of which sort? Insertion sort. What is the logic of insertion sort? Very beginning element to be insert, that should be compared to the next element. If it is lesser, left side to be move on. If it is greater, right side to be move on. Until all elements to be sorted, it will be done. You see that what is the functionality for insertion sort? Void insertion sort. A is array size, I equal to 1, I for index, I equal to 1, I less than size, I plus plus. Now here int value equal to a of I. What is meant by a of I? A of 1. That is very beginning element, a of 1 I used. This is a of 1. After that I processed with int whole is a variable, whole equal to I. Whole is nothing but which I want to insert, that element to be stored in whole I. After that while loop, whole is greater than 0 and one more condition, a of whole minus 1, whatever whole value you giving, that minus 1 greater than value. Now see that how it is working of this process. Now you check that initial I is 1, is it 1 less than size? Actually what is my list of element size? 5 elements, my list of element 5, 1 less than 5 true. After that value a of 1 called as, here I want to use for second element. What is my second element? 3. A of 1 is nothing but second element. Whenever second element I used here, then I want to go for whole equal to I, index value. Is it 1 greater than 0 or not? Yes. 1 minus 1, 0, that means a of 0, greater than value, this greater than value called as second element. Now here whole minus 1 called as a of 0, value called as a of 1, value called as a of 1, a of 0, a of 1. What is meant by a of 0? Indicates first element. What is meant by a of 1? Indicates second element. If the first element is greater than second element, you want to change the position. Which position I want to change? A of whole equal to whole minus 1. Decrement the whole variable. After that whole minus minus, decrease the value. Here which will be taken? This a of whole greater than a of whole greater than a of I, or this is you can work with value, this is value to be compared. Every whole variable to be decrement. Finally a whole variable what to be assigned? Value to be assigned. Now this complete logic I variable increments, every time I variable increments. Initial I is 1, whole is equal to I, but here whole minus 1, it is called as 0. At that time how it is compared? The second element compared to the 5, the second element compared to the 5, it is lesser left side. Third element compared to the first and second, it is greater right side. And fourth element compared to the 1, 2 and 3, it is lesser means left side. Like this it will be processed. This is the logic of insertion sort logic. What is one more type of sorting algorithm you have? Selection sort. One more type of sorting algorithm, selection sort. What is the logic of selection sort? Set minimum to the location 0. What is the work of selection sorter? First to be find out the minimum element in your list, minimum element that to be located 0 index. Minimum element to be located 0 index. Search the minimum element in the list, swap that value at location minimum. At location minimum, search the minimum element and that value will be located at a min position, I mean 0 position. Increment the minimum. That means next variable to be, next minimum to be find out, pointed to the next element. Repeat until last list is sorted. How it is process of selection sort? First to be find out the first minimum, located 0. Next to be find out the second minimum located at second position. Next to be find out the third minimum located third element. Repeat until list to be sorted. The same logic to be done. Selection sort is minimum. Minimum should be find out. Then only to process. Previous is insertion sort. This is insertion sort to be processed. Now I want to work with the selection sort. You see the selection sort logic. If I have 3, 5, 10, 2, 4, 5 elements I have. I want to arrange these list of elements with selection sort. My request is these list of elements to arrange in selection sort. How it is process of that? First to be taken to the minimum. First I want to taken to the minimum. Which is my minimum? 2 is the minimum. My work is 2 is the minimum. Whenever 2 is the minimum here, this minimum to be positioned at first position. Actually first position 3 will be there, but this position minimum will be shifting. This 3 will be shifting to that position. At that time what is the answer now? 2, 5, 2, 5, 10, 3, 4. What is the mean that? Actually minimum 2 will be there. This minimum 2 will be swapped with the first element, first position element, swapping. After that second minimum to be find out. Minimum equal to 3. Second minimum 3. Now the second minimum 3 positioned with the second position. First minimum element positioned with the first position. Second minimum to be positioned with second position. I mean 5 and 3 should be interchanged. 2, 3, 10, 5, 4. After that third minimum. What is the third minimum? 4 I have. Third minimum 4. Third minimum 4 to be positioned at the third element. That means 10 and 4 to be interchanged. 10 and 4 to be changed. 2, 3, 4, 5, 10. After that the fourth minimum. What is my fourth minimum? 5. Already 5 is at same position. Fourth minimum is 5, that is correct position. Next minimum 10. The minimum 10 also same position. Fifth minimum also same position. Finally, what is my list of elements? 2, 3, 4, 5, 10 sorted. 2, 3, 4, 5, 10 sorted. This type of sorting called as selection sort. What is the selection sort logic? First minimum to be find out, that minimum position to be changed with first position. Second minimum to be find out, that minimum to be positioned with second position. Third minimum to be find out, position with third position. Fourth minimum to be find out, position with fourth position, until so and so all elements to be sorted. That is the logic of selection sort. You see that what is the function of selection sort here? The same logic to implement the function void. To implement the function here, void selection sort function. A is a array size. I equal to 0, index is 0, I less than size minus 1, index size minus 1, I minimum, that is one minimum variable, equal to I. What is I equal to 0 here? Index is 0. Here I min equal to 0 means first position, first minimum. J equal to I plus 1. If I is at 0, J is at 0 plus 1, 1. Second position. Is it 1 less than size? Yes. A of 0 less than A of minimum. A of 0 called as A of 1. Because I is 0, J means 1, A of 1. A of I minimum called as first position, first minimum element. If the second element is less than first element, you want to move the position. J will be moved at the minimum. Similarly, two process will be done. J increments and similarity to find out the minimums. Interchange. Temp equal to I minimum position. I minimum position is I position is temp. Interchange. Whenever minimum is less than to the first element, that should be interchange. Similarly, second minimum less than to the second position, that to be interchange. Swapping, it will be swap. That is the logic of selection sort. What is one more type of sorting algorithm you have? Merge sort algorithm you have. Merge sort. Now for the merge sort algorithm, it's very important algorithm to keep on dividing the list into equal halves. I mean, you want to divide to that list of elements equally to half until it can be no more can be divided, and minimum two elements to be divided. By definition, if it is only one element in the list, it is sorted. Then the merge sort combine smaller sorted list, keeping to the new list sorted. How it is processed? That step number 1. If it is only one element in the list is already sorted, only one element. Divide list recursively into two halves, I mean two elements, until it can be no more can be divided. Now step number 3, merge the smaller list into the new list. Merge means combining to the smaller list of element into the new list. You see the logic of that merge sort? Merge sort divide method. Divide minimum one element. If I have two elements, that to be divided. Now I want to save this logic now. Selection sort this previous one. Now I want to work with which sort technique here? Merge sort. Now suppose I have the merge sort elements. I am creating with 2, 3, 10, 5, 4 and 7, after that 12, after that 6. I have these elements, pairwise elements. I have how many elements? I have 8 elements, 2, 3, 10, 5, 4, 7, 12, 6, 8 elements. Now what is the logic of merge sort? 2 elements I want to divide, half of the values I want to divide. First I divided 2, 3. First I divided the list of elements 2, 3. Next I divided 10, 5 one list. Next divided 4, 7 one list. Next divided 12, 6. It's a 4 list it will be divided. After that these 2 elements to be make into order. 2, 3 already order. 5, 10. Now it is order. 4, 7. It is order. 4, 7. And next element is 6, 12. The 2 elements. Now I want to combine these 2 elements into 4 elements. Now I want to work with these 2 list elements combined to the single list of elements. 2, 3, 5, 10. It is one list. What is another list? 4, 7, 6, 12. This is my second list. Finally, I expected the final merged list, final sorted list. Actually, this is my list 1, this is my list 2. The both list will be combined and maintained to the final list. How it is combined and final to the list? First list first element compared to the second list first element. First list first element compared to the second list first element. 2 less than 4. Yes, true. 2 is less than 4. Which is the smallest? That should be keep first. 2. After that 3 and 4 to be compared. 3 and 4. 2 already processed. Now 3 and 4 to be compared. Which is lesser? 3. 3 will be stored. Next 5 and 4 to be compared. Under 5 and 4, 4 to be smaller. 4 to be stored. After that 5 and 6 to be compared. Which will be smaller? 5. 5 will be smaller. List 1. Next 10 and 6 to be compared. 6 is smaller. 6 is smaller here. Here first 2 and 4 compared, 2 will be displayed. After that 3 and 4 compared, 3 will be displayed. After that 5 and 7, 5 and 4 compared, 4 is displayed. Next 5 and 7 compared, 5 is displayed. Next 10 and 7 compared, 7 lesser, 7 display. But here you see, here actually these list of elements you want to make into order, then only you want to sort the elements. These list of elements separately to make into order, then only you sort. Here there is no order, na? You want to sort of that order wise to sort. Here I used 4, 6, 7, 12. Then only you can sort. Now here 10 and 6, 6 is smaller. 10 and 6, 6 is smaller. After that, after 6, then 10 and 7 to be compared. 7 is smaller. After that 10 and 12 to be compared. 10 and 12. 10 is smaller. Finally 12. How it is compared that first list is less than second list element, first list to be process. If the second list is smaller than first list, second list to be process until that all elements to be sorted. Final list is coming, it is merge list. How it is processed? The logic of merge list, two sublist will be there. You see the function void merge, A is the array, L for one array left list, R for one array right list. Now int L underscore length means left side length, left list length, R underscore length means right side length. A is the final array, L is for left side array, left list, R for right side list, L underscore len called as length of left side, R underscore len called as right side of length. I equal to 0, j equal to 0, k equal to 0 index variables. Now I less than L underscore length. If the 0 less than first length and next 0 less than second length, I want to continue for sortings. How to sort off that? Check it. L of I called as left list. If the left list element is less than right side list element, left element stored into A final array. Whenever left side element is less than right side element, left side element final to the A, after that I plus plus. Whenever it is false, now under A right side element to be processed, which to be increment? J plus plus. After that k plus plus, k is for final list. Here A is for final array, L is for left side elements, R for right side elements, k is the final array index. If I is less than L underscore length, left elements will be stored into the A. At that time I plus plus and k plus plus, k will be increments. Now this k is for main array index. Actually here in this logic observe. Now this list is L, this list is R, this list how to read I index, this list how to read J index. The final list is A. In my program final list is A, which is the index k, k will be increments. Similarly the same logic. While j less than R underscore length, right side element to be stored to the A, final list, j plus plus, k plus plus. Now that is the logic, and you see that here merge sort int A is the final array size. Now I want to divide that. Left length is divided, size divided by 2. Right side length divided, size minus left side length. First to be find out the left length, size divided by 2. Based on the left side length only, right side length will be divided, size minus left side length. Similarly the same here you have to use I equal to 0, I less than length of left side, A array elements to be stored into L. Similarly A of j plus left length will be stored into R right side. That is the process. Now here which function to run? Merge sort, this is left side to be move on, merge sort, this is right side to be move on. L is for left array length, R is for right array length. Final merge function A array, L for left, R for right, this is length of array, this is right length of array. Totally 3 functions you are calling. First function how to arrange the left side left elements. Second function how to arrange the right side length elements. Final function to combine with left side and right side to main array. These are the 3 functions to be processed. Now in this process actually this is left side process one function, right side process one function, finally to stored into final list one function, 3 functions. That is the logic of merge sort. What is one more type of sorting algorithm you have? Quick sort algorithm. Quick sort algorithm you have. This quick sort algorithm is called as pivot algorithm. Quick sort algorithm is also called as pivot algorithm. Based on our understanding, partitioning of the quick sort. First I want to work with quick sorter. Check it. Choose the highest index value as pivots. Take the 2 variable to point left and right, list excluding pivots. Left point moving the low index, right point moving to the high elements. First to be find out with which element? Pivots. pivot is nothing but highest index element. After that, two variables to be find out. What is my first variable? Low index, it is left side points. High index, it is right side points. When the value is less than, pivot will be moved to the right. While the value is right side greater than, pivot move to the left. Whenever value is left side lesser than, pivot will be moved to the right side. When the value is right side greater than, pivot move to the left side. If the both steps are failed, does not match, swap left and right to be swap, left element, right element to be swap. Whenever left and right both are equal or greater, whenever left and right both are equal or greater, insert the pivot. Same function to be process. You see that what is the logic of that actually? How it is processed of quick sort. Previous sort is merge sort. How it is working of quick sort logic. You see that quick sort logic, how it is processed. If I have some elements, what is my elements here? 3, suppose I used 5, 2, 4, 10, 3. These are my elements I have 5, 2, 4 and 10, 3 and one more element is 6 suppose. 6 elements I have 5, 2, 4, 10, 3, 6. Now in this list of element, first you trace as pivot element. Here initially pivot element I consider as 5. In this list quick sort, first I consider as pivot element 5. Is it 5 is correctly positioned in the list? No. In this list 5 is not correctly in the order. I am not checking remaining elements, just I am checking 5. Is it 5 correctly positioned? No. Now I want to work with low. Low is nothing but immediate element of pivot. Which is the immediate element of pivot? 2. This is my low index element. This is my low index element. What is my low index element? 2. Next I want to check with the highest. High is nothing but last element. Your list last highest. What is my high element? 6. Now here pivot is 5, low is 2, low index is 2, high is 6. How it is process of this? What is the condition here? If pivot, what is the logic here? If pivot is greater than low, if the pivot is greater than low, low will be increments. Else if pivot is less than high, if the pivot is less than high, at that time what we want to create with the high minus minus. If this condition true, high minus minus. Else if pivot greater than low, pivot less than high, both are fail, at that time swap. At that time swap. Which to be swap? Low comma high to be swap. Low comma high to be swap. Whenever the pivot, whatever pivot you are already created these, whenever the pivot elements are there, you see that what is the pivot elements actually here, whatever list you created this. Suppose I used this, I used that element, suppose again I gave 5, 2 and 4, 10, what is one more element? 3 and 6. In this elements 5 is the pivot and 2 is the low element, 6 is the highest element. Now whenever this condition pivot is greater than low, low plus plus, else pivot is less than high, high minus minus. Whenever both are fail, pivot not greater than low, pivot not less than high, swap the low and high. Whenever low, if low is equal to high, whenever low is matching to high, at that time return pivot. At that position insert pivot. That position insert the pivot. At that time correctly position insert pivot. Same logic to be continue for all elements. Same logic. You see that now I want to apply pivot. What is my pivot? 5. My pivot is 5. What is my low element? 2. 5 greater than 2. Yes, true. Whenever condition true, low increments. What is my next low? 4. Next low 4. 5 greater than 4. Is it condition true? Yes. Condition true. 5 greater than 4, true. Next low will be move on. 5 greater than 10. Condition false. Initially low is 2. Initially low is 2. 5 greater than 2, true. 5 greater than 4, true. 5 greater than 10, false. Whenever this condition false, stop there, going to the high. High to be checked. What is my high? 6. 5 less than 6. 5 less than 6. Yes, condition true. 5 less than 6, condition true. At that time, I want to go for high minus minus. What is my high now? 3. 5 less than 3, condition, see that, 5 less than 3, condition false. Now here you see 5 greater than 10, condition false. 5 less than 3, condition false. Both location condition will be false. 5 is not greater than 10, 5 is not less than 3, both condition false. At that time 10 and 3 to be interchange. Here 10 and 3 to be interchange or swap. Interchange. Which element to be interchange now? 10 comma 3 to be interchange. After interchange, what is my elements? 5, 2 is same position, 4, 10 position 3 coming, and 10 position 3 coming here, 3 position 10 coming, 3 position 10 coming, then 6. Now I want to process where it is stopped, this 3 position it will be stopped. 5 greater than 3, yes, true. 5 greater than 3, true. Now here 5 greater than 3, true. After that I used with move on the next. Already what is my next high element? 3. Already low also 3. Here low equal to 10, low equal to high equal to 10, both are 10. Whenever low and high both are equal, low is 10, high is 10. Here low is 10, high is 10. Whenever both are equal, stop there, insert the pivot. I mean this 5 element to be insert this location to be insert. Insert pivot. What is my pivot? 5 to be insert. What is the output now? What is my lister? 2, 4, 3, 2, 4, 3, 5, 10, 6. Finally, what is my indication now here? Now here 5 is correct position. My pivot element is 5. 5 is correctly position. 5 is correctly position, and 5 lesser elements are left side, 5 lesser elements, and 5 greater elements are right side. Now 5 is correctly position. Again left side lister, right side list. Again the same process continues. What is my left side lister? Separately to process. What is my left side lister? 2, 4, 3. In the 2, 4, 3, which is my pivot? Pivot is 2. Which is my low? 4. Which is my high? 3. Now see here, is it 2 greater than 4? False. Going to the 2 less than 3? Yes, true. Now here through high minus minus, at that position it is moving. At that position it is moving now. Now 2 will be shifting. What is my elements here? 2, 3, 4. It is coming 2, 3, 4. What is my right side elements? 10 and 6. 10 and 6 already 6 and 10. 2 elements only there, it is interchange. 5, 6, 10. Finally, what is my list of elements here? 2, 3, 4, 5, 6, 10. This is the logic of this. What is the logic of this quick sort algorithm logic here? You see that first will be find out the pivot. First to be pivot the pivot. Take the two variable low and high. Low is nothing but for immediate element of pivot. High is nothing but right side. If the low is greater than pivot is greater than low, moving on the left side. Pivot is less than high, moving on the right side. Wherever pivot low and high are false, swap the elements. Whenever both are equal, stop and insert the pivot. Same logic. Swapping also done, same logic to be processed. Finally, this is the quick sort algorithm logic. It's a quick sort. Now these are the main sorting techniques are there. Finally, what are the sorting types I discussed? Now the today class completely sorting methods or sorting techniques I discussed. Bubble sort and insertion sort, selection sort and a merge sort and a quick sort. Bubble sort, what is the logic? Pairwise comparison. If the first element greater than second element, swap the elements. If the second greater than third element, swap the elements. If the third element greater than fourth element, swap the elements until all elements to be sorted. It is very easy to understand and easy to process. Next, what is one more sorting? Insertion sort. Insertion sort, what is the logic now? First very beginning element to be insert, next element to be compared. If it is lesser, left side to be insert. If it is greater, right side to be insert. Compare to the remaining all elements wherever it is positioned. What is the third one? Selection sort. How it is processed, the selection sort? First find the minimum element that to be positioned at first position. Next find the second minimum, position at second position. Next find the third minimum, position at third position until all elements to be sorted. Next sort, merge sort. You have to divide the two list, 4 elements list. If the first list less than second list element, store the final list. If the second list element is less than first list, store the second list element. Move on to the left side elements, move on to the right side element. What is the logic of quick sort? Pivot element to be find out. Low is nothing but first element index, high is nothing but last element index. If the pivot is greater than low index, low increments. If the pivot is less than high index, high minus decrements. Whenever low and high both are false, interchange. Whenever low and high both are equal, stop there and insert the pivots. Same logic, remaining list of elements also can be continued. These are the complete sorting algorithms I discussed. Okay. In the next class, I started with the stack algorithm, how to store the data structure elements in the stack algorithm that I discussed. Thank you for this video. Hello students, welcome to the C language training program. Today I want to discuss with how to create stack operations using data structures in C language. How to create the stack operations in data structures using C language. What is meant by stack? Stack is nothing but linear list representation. Stack is nothing but like as array. The list of elements will be represented in the process of LIFO manner. What is meant by LIFO manner? Last in first out. Stack is like as similar to arrays or linear list of elements. It is a process of LIFO manner. What is meant by LIFO? Last in first out. Whenever you prepare the elements in the stack data structure, which element is first inserted, that should be removed last. Which element is last inserted, that to be removed first. Stack is one of the data structure storage technique. It is one of the data structure storage technique to store the elements in the process of LIFO manner, last in first out. What is meant by last in first out? Which element is last inserted, that should be removed first. Which element is first inserted, that should be removed last. Now the stack real life examples, many examples we have. Now in the real life everywhere you can use the stacks. One example of stack, pile of plates on the dining table. On the dining table, if you place the plates, pile of plates. On the table, first you place the plate, first plate. On top of each other second plate, on top of each other third plate. If you place the 3 plates on the dining table, which is the last placed plate, that should be removed first. Which is the topmost plate, that should be removed first or delete first. Which plate is first inserted on the table, that should be removed last. This type of operation is called as stack operation. Stack operation, real life example, pile of plates on the dining table. Which plate is first inserted on the table, that should be removed last. Which plate is last inserted, I mean top of the plate, that is first removed. How it is processing of stack actually? Suppose first I place the plate number 1 on the dining table. If I place the plate number 1, which is my top position, top is one of the indicator in the stack. With help of top index only you can push the elements, you can pop the elements. Push is nothing but insertion, pop is nothing but deletion. Suppose if I place the first plate, which is my top position plate, first plate only top push. If I insert the second plate, top of the first plate, second plate is inserted. What does that mean? That top will be increments. Initially first plate I inserted, at that time top is at first. If I insert the second plate, top is increments to 1. Initially top index is 0. Whenever I inserted new plate, top increments, I mean top moving on 1. If I insert another plate, top is moving on 2. Like similarly top increments. Whenever you are inserting the new plates, top indicator increments. Suppose in my dining table I placed the 5 plates, which is the last placed plate, that should be delete first. Insertion type top increments. Suppose already I inserted 5 plates, which is my topmost plate, 5th plate is the topmost plate. First plate is the bottom location, which is the topmost plate, 5th plate is the topmost plate. If I remove the 5th plate, top decrements. When I remove the plate number 5, which is the top plate number 4. When I remove the plate number 4, which is the top plate number 3, I mean top decrements. If I remove the elements, if I remove the plates, top decrements. If I insert the plates, top increments. Now here in the stack operation, insertion, top increments, deletion time, top decrements. Now whenever you are insert the elements in the stack, push function to be run. What is meant by push? Insert an element into the stack. Whenever you create one stack data structure, if you insert an element into the stack, it is called as push. Whenever you remove the element from the stack, that operation called as pop, remove the elements. While insertion of elements into the stack, top increments, while deletion of element into the from the stack, top decrements. Push function, pop function. Push function indicates to insert an element into the stack. Pop function indicates to remove the element from the stack. Suppose initially my stack is empty. How to indicate stack is empty or not? Top equal to -1. Top is a indicator of stack. Top index equal to -1. -1 indicates no elements. It's null. Top equal to -1 indicates null. If I insert the first element, top increments 1, I mean 0. If I insert another element, top increments 1, I mean top is 1. Initially top is -1. If I insert first element, plus top, pre-increment, I mean first insert the plate, then top increments. Next insert the plate, then top increments. Whenever my stack size is full, insertion not possible. Whenever push function not possible in the stack, suppose my stack size is 5 size. My stack size is 5 size. 5 size means 5 elements I can insert. The indexes are 0 to 4. Minimum 0 index started, maximum 4. More than 4, I can't push the elements. What is the logic condition here? If the top is less than or equal to size -1, stack is push function is possible. Whenever top is greater than size -1, push function not possible. It is shown the error stack is full. What is the logic of here? If the top indicates less than or equal to size minus 1, top increments, I mean push function possible. Whenever top is greater than size minus 1, push is not possible. What is the error come? Stack is overflow, stack is full. Now see, if I want to remove the elements, suppose my stack is 5 elements already I inserted. My push function is completed because my stack I have the 5 elements full. Whenever stack is full, I can remove the elements. Whenever I want to remove the element, that function is called as pop function to remove the element from the stack. Already my stack I have 5 elements, which is my topmost element, 5th element. I mean top index 4. 5th element first to be removed, top index is 4. Whenever top is equal to minus 1, pop function not possible. Whenever top equal to minus 1, pop function not possible because there is no element, stack is empty. Whenever top is greater than or equal to 0, whenever top index is greater than or equal to 0, then you can use with deletion possible, pop is possible. Whenever top equal to minus 1, stack is empty or underflow. Whenever I remove the first element, top decrements. If I have the 5 elements, for 5th element to be removed, after that 4th element to be removed, after that 3rd element to be removed, after that 2nd element to be removed, after that 1st element, after that top minus 1. Whenever top equal to minus 1, which is not possible, pop function not possible. Because of stack is empty, stack is underflow. Whenever top is greater than or equal to size minus 1 or top is greater than size minus 1, push function not possible. Whenever top is equal to minus 1, pop function not possible. If the top is less than or equal to size minus 1, push function possible. If the top is greater than or equal to 0, pop function possible. These are the operations of stack, push and pop. One more function also there for the stack. What is one more function for the stack? Display function. I want to display the stack elements. Suppose my stack size is 5, I inserted first, second, third, fourth, 5 elements I inserted. I want to show the elements, which are the elements I inserted in the stack. I want to show that. Top to bottom all elements I want to show. If my stack is 5 elements I inserted, I want to show the elements from first to last, all elements I want to show, display. Whenever display function is possible, if the top is greater than or equal to 0, display function possible. If the top is greater than or equal to 0, display function possible. Whenever top is equal to minus 1, display function not possible because there is no elements. Whenever stack is empty, there is no elements, there is no display. If the top is greater than or equal to 0, display function possible. Initially top equal to 0, after the top increments, whenever top reaches to size minus 1, until that I want to display the elements. Top equal to 0, top less than or equal to size minus 1, top plus plus. Then I want to display the elements. Finally, for the stack function, stack totally 3 functions we have. If you want to implement the stack data structure in C language, 3 functions to be used: push, pop, display. Push is nothing but to insert element into the stack, pop is nothing but to remove the elements from the stack, display is nothing but starting to ending, I mean top equal to 0 to top size minus 1, all elements to be displayed. Whenever push function is possible, if the top is less than or equal to size minus 1, push function possible. Every push function top increments, top indicator increments. Whenever top is greater than size minus 1, push function not possible. Whenever top is equal to minus 1, pop function not possible, deletion not possible. Whenever top is greater than or equal to 0, pop function possible. If the top equal to -1, what is the error message? Stack is empty. If the top is greater than size -1, top equal to size -1 or top greater than size -1, at that time you want to display stack is overflow full. If you want to display the stack elements, initially top index 0 start, whenever top ends with size -1, then I want to stop the display elements. Whenever top is equal to -1, stack is empty, there is no display function to be moved. Finally, what is mean by stack definition in the C language data structure? Stack is nothing but one of the way to store the elements in the data structure format. Stack is one of the process to store the elements in the data structure format. Stack is a what type of process? LIFO manner, last in first out. Stack is like as a array, which element is last inserted, that should be removed first. Which element is first inserted, that to be removed last. Which are the examples of stack? Pile of plates on the dining table. If you have the dining table, I want to place the plates. Plate number 1, plate number 2, plate number 3. First I place the plate number 1, that is my topmost plate. If I insert the second plate, top increments, second plate is the top. If I insert the third plate is the top. If I place the 3 plates, which is easy to remove the plate, third plate which is last inserted, that should be removed first. Top position I want to remove. If I want to insert the 4th plate onto the 3rd plate, that is also top position. If I want to insert the new element, also top. If I want to remove the element from the stack, also top. Top is the very important index to perform the operations. Insertion at the top, deletion at the top also. Real life example for the stack, dining table pile of plates, or cards. When I want to use with wheeled cards, I want to arrange the cards, flow of the cards. If I place the cards one by one, I place the cards, playing cards. If you are arranging the playing cards, first you are taken to the which is the first card, that should be take last. Which is the topmost card, that should be take first. Topmost card to be take first. Which are the drawbacks of the stack? What is the drawback of the stack? Stack is insertion at the top, deletion also at the top. Anywhere insertion not possible, anywhere deletion not possible. At topmost only insert the element, at topmost only remove the element. Suppose in middle I want to insert the element, or I want to delete the element, it is very difficult to process. I mean shifting required. If I have my stack size 5, I want to remove the 3rd element. My stack size is 5, I want to remove the 3rd element. First you remove the 5th, then after that 4, then only remove the 3rd. Stack is like as a vertically to be arranged. Stack is vertically arranges. Queue is horizontally arranges, stack is vertically arranges. 5th plate is top, after that 4th, after that 3, after that 2, after that 1. If I want to remove the 3rd plate, directly I can't remove the 3rd. If I want to remove the 3rd element directly, I can't remove. First remove the 5th, then after that 4th, then after that 3rd. Shifting required. What is the drawback of stack? Insertion at the top only, deletion at top. Anywhere insertion not possible, anywhere deletion not possible. Stack can be implemented with arrays. Arrays also you can implement the stack. Stack can be implemented with the pointers, dynamic memory. Dynamically also you can create the stack. Stack with array possible, stack with pointer can be used. Stack with structure also can be defined. Stack with array, stack with pointer, stack with structure. Which is the easy to process of that? Stack with array, that can easy to process. You see that what I discussed for the stack, you see the operations and description about the stack. You see that. What is meant by stack? Stack is nothing but LIFO manner, last in first out. A stack is nothing but abstract data type. Stack is nothing but abstract data type. It is commonly used in the mostly programming languages. Stack is one of the abstract data type. It is commonly used mostly in the every programming languages. Maybe C language, C++, Java, .NET, every programming use the stack. It is a named stack. It behaves like as real world stack. Order wise. For example, a deck of the cards. If you have the playing cards, deck of the cards, which card is topmost, that should be take first card. Which card is last placed, that should be take last. Or pile of the plates on the dining table, that is also stack. A real world, a stack allow operations at one end only. What is the mean that? Top only to insert the element, top only to remove. For example, we can place or remove the card or plate from the top of the stack only. Already I discussed. Suppose on the dining table I have 3 plates. If I want to place the 4th plate, topmost position only place the plate. Already I have 3 plates. If I want to try to insert 4th plate, that should be placed at topmost, above the 3rd plate. If I want to insert card, new card, that should be placed on above the 3rd card. Top only insert, top only remove. Stack abstract data type, all data operations at one end only to use. Every stack can access based on the which element? Top element. Initially top is -1. If I insert the first element, top is 0. If I insert second element, top is 1. Like this. This feature is called as LIFO manner. Stack is a LIFO manner, last in first out. Last in first out data structure. What is meant by last in first out? Which element last inserted? That should be out first. Which element is last inserted? That should be out first. Which element is first inserted? That should be last. Now here the element which we placed inserted or added last only. If we want to delete also, topmost only. Which is last placed, that is only first removed. Stack terminology, insertion called as push function. Insertion called as push. What is meant by push? To insert an element into the stack. Push is nothing but to add the new element into the stack. If I want to remove the element from the stack, pop operation to use. Pop is nothing but remove the element from the stack, remove. Now which is the stack representation here? A stack can be implemented of array also, implement can structure also, implement can be pointer also or linked list also. Stack can be used with arrays also, pointer also, structure also. Process is same. If I want to work with a dynamic size, you can go for pointers. If I want to create with stack with a fixed size, arrays, it's a fixed size. Static memory means arrays. If I want to create dynamically to resize, pointers. Which are the basic operation for the stack? May involve the initialize the stack. What is meant by initialization? The stack size will be defined, but there is no elements. Using it, you can de-initialize also. Now see what are the basic early operation for the stack? Push. What is meant by push? Pushing an element on the stack, storing an element on the stack. Pop is nothing but remove an element from the stack, deletion element from the stack. When the data pushed on the stack, to use the stack efficiently. To check the status of stack also, whenever I inserted the element, peak will be there. What is mean by peak? I want to get the topmost element. Which is the topmost element? That is called as peak. Peak is nothing but for topmost element, but that is not removing, just return the element. is full. What is meant by is full method, is full function? Check the stack is full or not. Whenever stack is full, if my top reaches to the size minus 1 or top greater than size minus 1, stack is full. Whenever top reaches to the size minus 1. Whenever stack is empty, if my top is minus 1, there is no elements. If my top indicates minus 1, it is null, no elements, it is null, empty. All time when I maintain the pointer last pushed data on the stack, at this pointer always represent top of the stack. Top of the stack will be displayed. Name of the top. Now you see what about for the stack, you have some program also. You see that I want to explain that stack diagrammatically. I want to explain how it is working of the stack diagrammatically to explain. Suppose I am creating one stack. This is my stack. This is my stack suppose. Now for the stack size I created 4 size. I mean 4 elements I can insert this stack. My stack size is 4. What is my name of the stack? My name of the stack, any name can be used. Suppose I use the stack here, stack stack, S for stack. What is my size? 4. My stack size is 4. S is the name of the stack, 4 is the size. Whenever I initialize the stack, top indicator should be used. What is my top indicator here? Here I want to use initialization purpose. What is my top? I used top equal to minus 1. Whenever top equal to minus 1, stack indicates empty, there is no elements. Now I want to work with push function. Push, I want to push the elements. One by one I want to push the elements. When I want to use the push function, now check it. Suppose I want to insert, which is my first, now I want to insert one element. I want to insert which element? 10 element I want to push. In this stack I want to push the 10 elements. Whenever I want to push the 10 element, now you see initially stack is empty. Now I want to insert the element. Now I want to insert the element here. Which position it is inserted? Now it is first position it is inserted. It is first position the element is inserted. Now this is 10. This is 10. But here how it is inserted? Plus top, pre-increment. What is meant by pre-increment? Initially 1 is added plus top, pre-increment. Initially 1 is added, after that store the elements, pre-increment. What is my top position now? I am inserting 10 element. What is my top position now? Top is 0. Here top index is 0. This is top index. What is the index of this? 0. What is my top element? 10. This index is 0, top is 10. This I use S of 0 index. S of 0 index. Now it is inserted this position. This position stack is inserted. Here this position insert the stack. This position insert the element. Now I want to create with another next element I want to insert. Next element I want to insert. That is also similar way. Once I insert that, what is my next element I want to insert here? This is 10. Already I inserted here 10. What is my next element I want to insert? 20. Whenever I inserted the 20 element, whenever I inserted the 20 element here, at that time top is increments, top portion is moving. Now this is my top, top is moving. Top is moving this location, top is moving. At that time this is my top index, S of 1, S of 1. At that time also plus top increments. After that I want to create with another element. I want to insert another element. I want to insert another element here. You see that here I want to insert another element. What is my next element I want to insert now? This position 30 I want to insert. Whenever 30 is inserted now, after that top increments, top position is changes. Previously 20 position, now top position here increments. What is the index of this? S of 2 index. Now here I inserted now 20, here I inserted now 30, in this position insert 30. After that I want to insert that next element now. What is my next element here? Insert 40 element I want to insert 40. Whenever I inserted the 40, now the next will be moving on next. If I inserted this, actually 30 will be there. What is my next element? 40 I inserted. When I inserted the 40 here, now it's a top moving this. This position is there previously, now it is position is moving, this position top. At that time, what is the top index now? This is S of 3. Actual size is S of 4, my index is reaching to the 3. After reaching to the 3, there is no insertion possible because there is no size. You are reaching to the actually top equal to size minus 1. There is no possibility for insertion. Now I want to use for whenever my stack size is full, I can't insert the new element. I can't insert the new element because my size is full. If top equal to, whenever top is equal to size minus 1, when the top is equal to size minus 1, insertion not possible. I want to print the message. What is my message? Whenever top is equal to minus 1, I want to printf. Which message? Stack is full. Whenever top equal to size minus 1, stack is full. There is no insertion. Whenever the top is not equal to size minus 1, stack insertion is possible. Whenever top is not equal to size minus 1, insertion possible. Plus top increments. Top indicator to be increments. Initially top is minus 1, now that is increments. After that I want to insert the element. After that I want to insert the element now. Insert the element position. Element position to be insert. Whenever top is equal to size minus 1, insertion not possible. Plus top. Now I want to insert S of top equal to element. I want to insert the element. S of top equal to element. I want to insert the element. Insertion of element. Now this is the function of push. This is the function of push. Now I want to work with the pop operation. Actually this is for push. Now I want to work with pop operations. How to pop the elements? Now already my stack is, now you see here my stack is already full. Now I have 4 elements. Now I want to go for pop. Pop means remove the element. I want to remove the element. Now here first I want to delete or remove. Delete 40, which is my last position stacker, that is only first deleting. Which is my last position element, that only first deleting. You see that now I want to delete this. I want to delete this, which is my last position element, that only first delete. Suppose if I use with 40, delete 40. Now 40 should be delete. 40 element to be delete. Now here you see. Now this 40 will be delete. Here it will be erases. Whenever 40 is deleted, now top decrements. Whenever topmost element is decremented, now it is top will be decrements. Decrement the top. How it is decrement the process? Now you see that whenever it is deleted, now top should be decrement. Top minus. Now the top minus. When I delete the 40, top minus, top decrements. At that time top is deleting now. Now you see that while moving on that deletion process, now you see the deletion process, how it is use the deletion now. See that if I go for deletion, already I have the stack, already I created the stack. This is my stack with 4 elements. Initially my stack is 4 elements. In that 4 elements I want to delete the 40. Already my stack is full. Whenever stack is full, then only you can delete the element. If stack is empty, you can't delete the element. I have 40, already I inserted that, 30, the next element is 20 and the next element is 10. My stack size is 4. Now I want to delete this element. Which element I want to delete here? 40 should be deleted. When I delete this 40, now delete 40. Whenever deleted 40 now, at the time top indicator moving, top is decrements here, top decrements to 30. At the time it should be used, top minus minus. After that I want to delete my next. After that I want to delete my next. Delete 30. I want to delete the 30. Whenever I deleted the 30, the top will be moving on next. Whenever I delete the 30, top is moving to decrement. At the time where it will be decrement here, decremented to 20. Now I want to delete the 30 now. When I deleted the 30 also deleted. At the time top is moving on to 20. Now this is my top. Here also which will be used, top minus minus. Every time top minus minus. Now I want to delete with 20. 20 I want to delete. Whenever I want to delete the 20, next 20 element is deleted. Previously 40 deleted, after that 30 deleted, after that 10 is deleted. At the time the top is moving on here. Now the 20 also deleted. At the time top is decrements to 10. The 10 position top will be there. Now here top minus minus. Top minus minus. Now I want to delete the 10. 10 I want to delete. Delete 10. Whenever I deleted the 10, at the time complete whole elements will be removed. In my stack, complete whole elements will be removed. All elements will be removed because 10 also deleted. At that time all elements will be removed. Whenever the stack all elements are removed, stack becomes empty. Top equal to minus 1. Now this will be removed and this is also removed. Whenever all elements are removed, at the time top becomes minus 1. Now here to top minus minus, actually top decrements. Whenever all elements are removed, top becomes minus 1. If top equal to minus 1, what is my error message to write? Printf. Printf, stack is empty. There is no elements. Whenever no elements, you can't remove the element. If it is not, if the top is not equal to minus 1, I can remove. I can remove that. Which I can remove that here, element equal to S of top. Top position element to be removed. Top minus minus. Top decrements. Now this is the pop function logic. This is my pop function logic. How to pop the elements. This is pop function logic. Whenever top equal to minus 1, stack is empty. Underflow, there is no deletion. If it is else, element to be delete, top minus minus. Finally, I want to work with the display function. I want to display the function now. When I want to display the stack elements. If I want to display the stack elements, what should be used? Whenever display is not possible, if top equal to minus 1, there is no display. If the top equal to minus 1, it should be error. What is error now? Print no display. Because of there is no elements, no display. If the top is not equal to minus 1, else I want to display. Whenever top is not equal to minus 1, I want to display the elements. How it is display the elements here? Because of for loop I used. For I used top equal to 0. When the top is whenever top is less than or equal to size minus 1. Whenever top is less than or equal to size minus 1, top increments. Then I want to display the elements. Then I want to display the elements. How to display that? How to display printf %d, because my elements are integers, %d, s of top I use that elements to be print. Whenever top is not equal to -1, that I want to display the elements, s of top to be displayed. These are completely operations to be used for the stack. These are the stack operation to be used. You see that here the stack program you observe, same whatever I explained that. Initially maximum size equal to 8, it is called as macro. Maximum size 8 I define, it is a array, maximum size 8, array size, stack of 8. These variables are global variables. Top is initially -1, -1 indicates initialization, there is no elements. Int is empty, this method is integer return. Whenever top equal to -1, return 1. Whenever top equal to -1, return 1. Return 1 indicates it's empty, true. Otherwise 0. Whenever stack is full, if the top is equal to maximum size or maximum size -1, return 1. Stack is full, there is no insertion. Peak, what is mean by peak? In your stack, top element, topmost element, which is the topmost element, that should be peak, return. Pop is nothing but remove the element data. If the stack is not empty, then only pop. Which to be pop? Data to be pop, element to be pop. Here data or element same. Top equal to top -1, decrements, return the data. Which element removed or which data removed, that should be returned. Whenever stack is not empty, then only you remove the element. Whatever element is removed, that should be returned. Top decrements. Otherwise could not be returned. Stack is empty. Push, I want to push the data. Whenever stack is not is full, if it is not full, then only you want to add the elements. Top equal to top +1. Whenever stack is full, there is no insertion. Stack of top indicator equal to data elements. If it is stack is full, could not insert, could not push the elements. You see that under main, int main, push 3, push 5, push 9, push 1, push 12, push 15. These all element will be pushed. My size is 8. My size is 8. These all element can be used. If I want to print topmost element, which is my last I pushed 15, that should be top. Last, because last element is make at first. Which is my first element, that should be make at last. Last element is pushed at first. While stack is not empty, then I want to call the pop. Whenever stack is full, I want to print the message, is it true or false. Whenever stack is empty, I want to print the message, is it true or false. Finally, these are the functionalities we have for the stack. Finally, this is the discussion about stack data structure. What is meant by stack? Stack is a linear data structure in C language. Stack is similar to arrays. Stack is a process of last in first out. Which element is last inserted, that should be removed first. Which element is first inserted, that should be removed last. Which are the real life example for the stack? Pile of plates on the dining table. On the dining table, one by one you can place the plates. Which plate is topmost, that should be removed first. Which plate is first placed, that should be removed last. Or cards, arranging the cards, playing cards arranges, that is also stack. Now for the stack, majorly 3 function you have: push, pop, display. Push is nothing but if I insert element into the stack, is called as push. Whenever push is possible, if the top is less than or equal to size -1, push is possible. Top increments. Whenever top equal to greater than size -1, push become the error. Stack is full. What is meant by pop? Remove the element from the stack. Whenever top is equal to -1, stack is empty, there is no pop. If it is not, you can pop the element top minus minus. Whenever display function is possible, if the top is not equal to -1, you can display the elements. 0 index to size -1 index, you want to display the elements. If the top equal to -1, display function not possible. This is completely stack operations in the C language data structures. Stack can be implemented arrays, pointers, structures, linked list. But the operations are same. Operations are same. Array means fixed size, pointer means dynamic size, linked list also dynamic size. Now today I want to stop this stack data structure, then tomorrow session I can continue with queue data structures. Stack data structure I discussed, then tomorrow session I will continue linear data structure, queue data structure, first in first out. Thank you for this video. Hello students, welcome to the C language training program. Today I want to discuss about queue data structure in C programming language. How to create the queue data structure in C programming language. Now the last session I discussed the stack data structure. What is meant by stack? Stack is nothing but last in first out data structure. What is meant by stack? It's a linear list. Store the elements last in first out manner. What is meant by last in first out manner? Which element is last inserted, that should be removed first. Which element is first inserted, that to be removed last. Which are the real life example for the stack? Pile of plates on the dining table. On the dining table first I place the plates, top of each other second plate, top of each other third plate. If I place the first plate, that should be removed last. Which plate is last inserted, that should be removed first. Which plate is first inserted, that should be removed last. Which is the real life example for the stack? Pile of plates on the dining table. Last in first out manner. Which element is last inserted, that should be removed first. Which element is first inserted, that should be removed last. Which are the stack operations? Push, pop, display. Push is nothing but insert an element into the stack. If you want to insert the new element into the stack, it's called as push. What is meant by pop? If I want to remove the element from the stack, the deletion element from the stack is called as pop. What is meant by display? Whatever stack you are already created, the list of elements to be displayed. Top to bottom, all elements to be displayed. Whenever push function is possible, if the top indicator less than or equal to size minus 1, push is possible. If the top is less than or equal to size minus 1, you can insert the elements. Whenever top is greater than size minus 1, push function not possible. It is shown the error stack is overflow or stack is full. Whenever pop operation is possible, if you delete element from the list, that is pop. If the top equal to minus 1, stack is empty. Top equal to minus 1 called as stack is empty, there is no elements, you can't remove. If the top is greater than or equal to size minus 1 or top is greater than or equal to 0, whenever top is greater than or equal to 0, you can pop the elements. If the top equal to minus 1, there is no element, stack is empty. It is called as underflow. When you display the stack elements, if you have at least one element or more than one element, then only you can display. If the top equal to minus 1, stack is empty, there is no display. Finally, what are the functions can be used? Push, pop, display functions. What is the drawback of the stack? Drawback of the stack, anywhere you can't insert the elements, anywhere you can't delete the elements, top position only to insert the elements, top position only to delete the elements. At topmost only to insert elements, at the topmost only you delete the elements. What is one more kind of data structure in C programming language? Queue data structure you have. Queue. What is meant by queue data structure? FIFO manner, first in, first out. Which element is first inserted, that should be removed first. Order wise, first element will be first remove, second element is second remove, third element is third remove. It is a queue manner. Whenever some persons are standing on the queue, any tickets counter, some persons are standing on the queue, the first person taken the first ticket and quit from the queue. Second person taken the second ticket and quit from the queue. Which person is last stander, that person taken the last ticket and quit from the queue. What is the operation of the queue here? First in, first out manner. Which element is first inserted, that should be removed first. Which element is last inserted, that should be removed last. Suppose my queue size is 5 elements. I can insert 5 elements. Suppose if I want to insert the new element into the queue, wherever insertion possible, back. What is meant by back here? Rear index. Every queue can perform with 2 indexes. One is for front, another one rear. Front is nothing but which is the first position element, that is front. Front index is 0. What is meant by rear? Which is the last element in your queue, that element is called as rear index. Front equal to 0 index, rear equal to size minus 1. If my queue size is 5, 0 to 4. 0 is the front index, 5 minus 1, 4 is the rear index. If you want to insert the new element into the queue, where you can insert the new element? Rear position you can insert the elements. The new element inserted at rear. If I want to delete the element from the queue, front position to delete. Deletion at the front, insertion at the rear. Whenever you are insert the new elements into the queue, which to be increment? Rear plus plus. If you are insert the element into the queue, rear index increments, rear plus plus. If you are delete the elements from the queue, which index to be increment? Front plus plus. If you remove the elements from the queue, front plus plus, front index to be increment. If you insert the elements into the queue, rear plus plus, rear position increments. Finally, what is my conclusion? The queue is a data structure. It is a linear data structure. Queue is also linear data structure, line by line to store the elements. Line by line to store the elements. It is a FIFO manner, first in, first out. Which element is first inserted in your queue, that should be removed first. Which element is last inserted into the queue, that should be removed last. Stack is a LIFO manner, last in, first out. Which element last inserted, that to be removed first. But the queue is a FIFO manner. What is the way you are inserted? Same way to delete. Stack, which is the way you are inserted, reverse way to remove the elements. But the queue is which is the way you are inserted, same way to remove the elements. What are the queue functions you have? Insertion, deletion, display. Stack also function, push, pop, display. Queue is also you have the 3 major operations or 3 major functions: insertion, deletion, display. What is meant by insertion? If I want to add the element into the queue, which queue is already there, if I want to add the new element into the queue, that is called as insertion. Insertion positioned at rear. Which element I want to remove from the queue, it's called as deletion. The deletion at front. Insertion time rear plus plus, deletion time front plus plus. One more function you have, display. How to display the queue elements? Front is equal to 0, rear equal to size minus 1. Front to rear, all elements to be displayed one by one, front to rear. Whenever insertion not possible into the queue, whenever insertion not possible, if rear reach to the rear is equal to size minus 1. Whenever rear is equal to size minus 1, queue is full. Whenever rear is less than or equal to size minus 1, you can insert the elements. Whenever rear reaches to the size minus 1, queue is full. Whenever deletion not possible, if the front equal to rear equal to minus 1. What is meant by front equal to rear equal to minus 1? Initially for the queue there is no elements. Whenever the queue no elements, there is no deletion. Front equal to rear equal to minus 1 called as, it's empty, queue is empty, there is no elements, you can't delete. Whenever deletion is possible, if the front equal to rear equal to greater than or equal to 0, less than or equal to size minus 1, greater than or equal to 0, you can remove the elements. Whenever display function possible for the queue, if the front or rear 0 or above 0 index, at least one element or full elements, then only you can display. If the queue you have the at least one element or full elements, then only display. If the queue there is no elements, there is no chance of display. You can't display the elements because the queue is empty, underflow. Now every queue, what is the problem? Every queue, insertion at rear, deletion at front. Again, what is the drawback of the queue? It's a linear queue. Linear queue drawback, insertion at rear, deletion at front. Anywhere insertion, anywhere deletion not possible. Anywhere you can't insert the elements, anywhere you can't delete the elements. Stack is only one end you have. Top only insert, top only delete. But the queue you have two indicators, two ends, front, rear, front, back. What is a real life example for the queue? Everywhere queue follows. If you want to move the car, within the queue only cars will be there. First car will be moved. After that second car will be moved. Queue on the queue. Whenever the cars are in the queue now, first car will be first quit, second car will be second. Tickets counter also standing the person's queue wise. Which person first standing, that should be take the first ticket and quit from the queue. Which person is last standing, that should be take the last ticket and quit from the queue. What is the drawback of the queue operations? Insertion, deletion not possible anywhere because it's a linear list data structure. Finally, what is the definition of queue? Queue called as linear list. Queue is similar to array, list of elements, FIFO manner. It's a process of FIFO, first in, first out. What are the queue functions we have? Insertion, deletion, display. Queue can be implemented with arrays. Queue can be implemented with pointers. Queue can be implemented with linked list. Queue can be implemented with array. Array means fixed size. Queue can be implemented with pointers, dynamically used. Queue can be applied with linked list, list of elements, link of elements. You see that now while working of queue, what are the definitions will be move on to the queue. Queue is nothing but abstract data structure. Queue is nothing but abstract data structure. It is similar to stack. But unlike stacks, a queue is open at both ends. Stack will be only one end will be there. One end is closed, one end only open. But the queue is open at both ends, front, rear. One end always to insert data, one end to be insert the data. That insertion called as NQ function. In the stack, insertion called as push function. In the stack, insertion called as push, but in the queue, insertion called as NQ. In the stack, deletion called as pop, but in the queue, deletion, removing called as DQ, deleted queue. Now for the queue, one end for insertion, another end for deletion. but in the stack same and insertion, same and deletion, top only insert, top only delete. Q insertion called as NQ, Q deletion called as DQ. Now the queue will be follows which manner? First in, first out. Which element is first inserted, that should be removed first, that will be accessed first. In the real world example, queue can be like anywhere, single line or one way. Whenever you take on the road one way, you have all vehicles are one by one enter the and one by one exits. Whenever you have the one way route, which vehicles are first enter, that should be first exit. Which vehicle is last entered, that will be exit last. It's a FIFO manner. In the real life example, many, you can take the queues, tickets window, ticket counter or ticket window. At bus stops also, it's followed by queue mechanism. Now, if you understand this queue, you have the both ends, two different ends will be there. It is open, two different ends will be there. You see that whenever you are working with a queue, what is the diagram can be understand for the queue, check it. The queue is it's a vertically data structure, you have vertically represent. Stack is horizontally, it will be there, but the queue is it's vertically you can represent. Now suppose this is my queue, this is the diagram can be implemented for queue. Suppose my queue name Q, my queue name is Q, Q of 5, Q of 5 means 5 elements. Every queue two indicators, I mean 2 indexes you have. First index you called as front. The first index is called as front index, front, it's called as front equal to 0. The last index, I mean rear index, back, rear equal to size minus 1, rear is 4. Initially there is no elements on the queue at the time. What is my statement? Initialize front equal to rear equal to minus 1, front equal to rear equal to minus 1, it's called as, whenever I indicate this front equal to rear equal to minus 1, it is called as front equal to rear equal to minus 1, that is called as queue initialization. Front equal to rear equal to minus 1, it is called as empty. Currently the queue is empty, there is no elements. Every queue one by one to insert the elements. Suppose first I am inserting 10, suppose next time inserting 20, suppose next time inserting 30, next time inserting 40, the queue elements one by one insert. When I remove these, first 10 will be removed. In this queue, if I want to remove the elements, which will be removed first? 10 elements. Which element is first inserted, that should be removed. Whenever I remove this, the front will be moving this position, front is moving to next, front plus plus. If I remove that, again moving on that next, front is moving on this. If I remove that, next I want to front is moving on this position. If I remove that, front is moving on the next position. If I remove that all elements, the front and the rear equal to minus 1. Whenever all elements are removed, front and rear equal to again minus 1. Whenever insertion time, if I want to insert elements, this is deletion operation. If I want to insert element, how it is inserting now? First 10 inserted, first 10 inserted. Whenever I inserted the 10, front, rear both are same position. At the time here rear is not available because in my list only one element I inserted. At that time, whenever the queue only one element I inserted, at that time front, rear same position, front, rear 0 only. After insert this element, second element, when I insert the second element, at that time which index will be move on? Rear. Rear index will be move on. Now rear plus plus. After that, if I insert the 30, insertion at 30, at that time again rear index will be increments. It is moving on rear index will be increments. If I insert the next element, again the rear index will be increments. If I insert the next element, again the rear index will be increments. Every time rear will be move on. Insertion time rear will be move on, deletion time front will be move on. Now you see this is also for rear will be increments. Insertion time, if I insertion that, at that time which will be move on? Rear plus plus. If I want to delete the elements, which will be move on? Front plus plus. One is for front plus plus, another one rear plus plus. Whenever front equal to rear equal to -1, Q called as empty. This is the operation first in first out manner to make a Q, front and rear. Now see that while working off the Q here, which are the basic operations I discussed? See, NQ. NQ will be there. What is meant by NQ function now? If I want to insert an element into the Q, is called as NQ. If I want to add the item into the Q, called as NQ. Next one is DQ, you have deletion Q. If I want to remove the element from the Q, is called as DQ, deleted Q. A few more functions required to make above mentioned Q operations, NQ and DQ. Peak function is required. What is meant by peak function? Which is the very beginning element. That is called as front. In your Q, which is the front element, very beginning element, without removing it, that is called as peak. Peak is called as front element in your Q. Is full function. What is meant by is full function? Whenever Q reaches to the size -1, rear reaches to the size -1, Q is full. Actually, my Q size is 5. My Q size is 5. Initially, rear is 0. After insertion, rear is 1. After that, rear is 2. Rear is 3. Rear is 4. Whenever rear is reaching to size -1, there is no insertion. Insertion not possible. At that time, is full. One more is there, is empty. Whenever is empty, if the Q is empty or not. Whenever I delete the 1 by 1 elements, first 10 deleted, next 20 deleted, next 30, next 40, next 50. Whenever all elements are deleted, there is no deletion function. Whenever front and rear equal to -1, there is no deletion. If the Q is empty, there is no deletion. If the Q at least one element or full elements. If the Q at least one element or full elements, we can remove. If the Q is empty, there is no deletion. That is called as is empty function. Now we always DQ pointed by the front pointer. Every deletion is front position, and if you want to insert the elements, every time always NQ. It is called as which pointer? Rear. DQ function working with the front. DQ function working with, if I want to work with a program of this Q operation program, check it. stdio.h, standard input output header file, string.h, strings can be run, string length, string lower upper, stdlib.h, standard library, and std boolean type also use, boolean functions. Hash define max 6, size of your Q. Hash define is macro, size with 6. Int array, Q array, size is 6, Q array. Initially front is 0, rear equal to -1. Initially front I assign with 0, rear equal to -1. Our item count equal to 0. I mean how many items I have. What is my first function? Peak function. Peak. Whenever the Q will be display as peak, in your Q first element called as peak. In your Q front element called as peak. Initial element called as front element called as peak. Return the front. Return the front. Int array called as array. Return the front. Whenever boolean is empty function is empty. Whenever Q is empty, item count is 0. There is no elements. Whenever return boolean is full, item count equal to max or max -1. Whenever the Q position item count is 0, there is no elements. Whenever the item count is maximum size, Q is full. Boolean type. I want to find out size of my queue, return the item count. Suppose my queue have the 5 elements, what is my size? 5. If my queue has the 10 elements, what is my item count? Return 10. What is the logic of insertion? Insertion, how to run of that? Insert, void insert, data, element to be insert. Insert function, insertion, enqueue, data to be insert. Whenever insertion is not possible, whenever insertion is possible, not is full. If the queue is not full, insertion possible. If the queue is not full, insertion possible. Rare reaches to max minus 1. If the queue is full, at the time insertion not possible, not full. Whenever rare equal to max minus 1, rare assigned to the minus 1, empty. Int array plus rare, rare increments, pre-increment. First increment the index rare, then store the element. Data means element. What is the logic here? Rare equal to max minus 1, rare equal to minus 1. Max minus 1 means you are reaching at last element, rare assigned to the minus 1. If it is not pre-increment, rare should be increment index, then store elements. Item count plus. How many elements you can count? Remove data. Whenever remove the element, deletion, front element to be removed first. After that front increments, next element is moving on front. First element remove, then moving on next. Second element removing, then moving on next. Whenever front reach to the max size or max minus 1, front 0. Whenever front reach to the max, all elements removed. Front initialize 0. Item count minus. Totally how many elements are there? Item count minus. If I remove that, count value decrements. If I insert that, item count increments. Return the data, return type. Now you see here, insert 5 items, insert 3, insert 5, 3, 5, 9, 1, 12. Order wise inserted. Now front is 0, rare is 4. Because 5 items. Now this is for 0, 1, 2, 3, 4. This is 3, 5, 9, 1, 12. If I insert 15, where it is inserted now? After 12. Whenever queue is full, what is the message? Queue is full. If I want to remove one item, first element remove. Which element is removed? 3. Front position element is removed now. At that time, 3 will be removed. Now rare is at 5. Now here, this is the front, this is the rare. If I want to insert 16, after 15 it is inserted now 16. After 15, whenever queue is full, element will not be inserted. 17, 18 like that also I can insert. At that time it is shown the error. Because you are already inserted the element. I want to print which is the front peak. Peak is nothing but front element return. Whenever queue is not empty, then I want to remove the data. Queue is not empty, then remove. This is basically queue operation, queue functions we have. You see that now while working of queue now here, insertion, enqueue, deletion, dequeue and display. These are the major function. Suppose you see that if I go for the queue, it's a linear list. The display the elements order wise you can display the elements. Suppose my queue size is 4 size. It's a vertically you can arrange the data. My queue is my array name, queue of 4. Initially front and rare I used with -1. It's called as is empty, initialize. After that I want to go for function. What is my first function I want to use? Enqueue function. Enqueue means insertion. Insert the elements. Suppose I want to insert 10 elements. In my queue I want to insert 10 elements. Now the initially queue is no elements. I want to insert the 10 elements. How to insert of that 10 elements? Now here I want to insert. Now I want to insert these these q elements to be insert one by one. First I want to insert with 10 under q, I want to insert the 10 elements. That is inserted at the front position. Now 10 it is inserted. After insert that front equal to 0, at that time rear position also 0, front is 0, rear is 0. Now I want to insert at 11, I want to insert at 11 I want to insert. When I want to insert the 11, at that time also the next position, I mean rear increments, rear will be increments. Here every insertion time which to be used, plus rear increments, pre-increments. Now here 10 inserted, after that 20 inserted. Now this is front position, now this is front, now which will be moving on, rear will be moving on. Now here rear will be moving, rear will be increments. Now here front, rear, previously this position, now front, rear, this position. Now it is increments, rear will be moving on this location, rear increments. How it is increment of this here, plus rear. After that I want to insert the next element now. What is my next element I want to insert here? Suppose I want to insert 30 element, next is 30 element I want to insert, 30 I want to insert. At that time then you have to use with next element insert 12, I want to insert 12. At that time also rear will be moving. Now here rear will be moving, here rear increments. Which element is inserted here? Here I inserted with 12, here I inserted 12, previously not 20, na? I changed the elements. Now here this element is, now here this element is 11, second element I inserted 11 I inserted, this is 11. After that third element is 12 element I inserted, second element is 11, third element is 12, that position I insert the elements. Order wise it is insert the elements, rear will be moving. Now I want to insert that next element I have, I want to insert the last element, fourth element. I want to insert that fourth element, this is my fourth q position index I want to use. Fourth element I want to insert. Now I want to insert that next element now, here I want to insert this position to insert. Which element I want to insert now? 13 I want to insert 13. Now the rear will be moving on, here 13 will be inserted. Now I want to insert next 14, but that is not possible because 13 is reached to the rear maximum size. Here front rear is 0, here rear is 1, here rear is 2, here rear is 3. Whenever rear is equal to size minus 1, stop there. If what is my condition? Rear equal to size minus 1. Whenever rear equal to size minus 1, which message to be print? Q is full. Q is full, there is no insertion, Q is full. Else if it is not, plus rear increments. Here I want to insert q of index position equal to what to be used, or here I used a q of rear index equal to element or data. Now this is the logic of insertion logic. Whenever q equal to size minus 1, q is full, rear equal to size minus 1, q is full. Else pre-increment, rear pre-increment, rear position index data. This is the logic of insertion, NQ function logic. If I want to go for deletion, if I want to work with the deletion of this, how to delete of that q elements? DQ function. I want to go for deletion now, DQ function to be used. Currently I have the 4 elements in this q. What is my q? Q of 4 size. Already I inserted some elements 10, 11, 12, previously I inserted 12 and 13. What is my front position here? This is front. Front is at 10, rear is at 13. Now I want to go for next function DQ. deletion queue. DQ called as deletion queue. How to delete that? I want to delete 10. I want to delete at 10. That means what? And in your queue 10 element will be deletes. In your queue, which is the first element, that is first deletes. Queue means order wise. Which element first inserted, that will be delete. I want to delete at 10. When I delete the 10, front is moving on this side. Front moving, front increments. Deletion time front plus plus, front only increments. Insertion time rear plus plus, deletion time front plus plus. Now I want to insert that next I want to delete that again. I want to delete that next element 11. 11 I want to delete. Now I want to delete this 11. In this position I want to delete the 11 now here. Delete 11. Second element to be delete. Previously front is at moving at 11. Now 11 also deleted, that is moving at 12. Now this is 10 is deleted, then 11 is deleted. Now the here front is moving. Next I want to delete at next element I want to delete. Next element I want to delete the 12 element I want to delete. I want to delete at 12. Now here I want to delete at 12. 12 element I want to delete. Previously I inserted with 11, but here 12 I want to delete. When I deleted the 12, now here I want to delete this. This I want to delete. This position to delete the element. 12 is deleted. Whenever 12 is deleted and this is moving, front is moving. Every time front only increments. Front plus plus. Every time front only increments. Front plus plus. Front index only increments. Now I want to delete at 13, the last one. I want to delete at 13. Last element I want to delete. Now I want to delete at last element. At the time, all elements I deleted here. Whenever I deleted with all elements, when I deleted with all elements, I want to delete at 13. At that time, all elements are deleted here. At that time, what happened? Front rear equal to -1. All elements deleted. At that time, front rear should be assigned to the -1. Whenever all elements are deleted, what is the function logic here? If front equal to rear equal to -1, front equal to rear equal to -1, printf. What is the message? Queue is empty, there is no deletion because all elements are deleted. Otherwise, you want to delete that data equal to queue of which index to be deleted? Rear, not rear. Front index element to be deleted. Front index element to be deleted. Front plus plus. Front index increment. This is the logic. Whenever front equal to rear equal to -1, queue is empty. Data equal to queue of front increments. If I want to display the elements, front equal to rear equal to -1, there is no display. Whenever front is greater than 0, rear is less than -1, display possible. This is called as DQ function, deletion to be processed. Finally, what are the data structure? Queue data structure I discussed. Now the queue data structure similar to stack. Stack is a LIFO manner, last in first out. Queue is a FIFO manner, first in first out. Which element is first inserted, that should be removed first. Which element is last inserted, that should be removed last. Queue insertion called as NQ function. Queue deletion called as DQ function. Insertion possible at a front, insertion possible at a rear plus plus. Deletion possible at a front. Which element is first inserted, that should be delete first. Front moving, based on front only to delete. Insertion is at rear plus plus, rear increments. Whenever front equal to rear equal to -1, no deletion. Whenever rear is equal to size -1, whenever rear equal to size -1, queue is full, there is no insertion. If the front equal to rear equal to -1, there is no queue elements, no display. What is the drawback of the queue? Anywhere you can't insert the elements, anywhere you can't delete the elements. Front only delete the elements, rear only insert the elements. Stack you have only one end, top will be there. One end is closed, topmost only insert element, topmost only delete. but the queue have the two ends, both directions. One is for front, another one rear. Front is nothing but deletion, rear is nothing but insertion. But anyway, stack also, queue also, both are linear data structures. Linear. Stack is LIFO manner, queue is FIFO manner. What are the stack functions? Push, pop, display. Queue function NQ, DQ, display. What is a stack? Real life example, pile of plates on the dining table. Queue means everywhere. If you have the one way on the road, every vehicle, which vehicle first will be placed, that should be quit from the queue. Which vehicle is last place, that should be quit from the last. Tickets counter also you can example. Okay, this is the discussion about queue data structure in C language. In the next session, I discussed one more data structure concept, linked list. How to store the elements in the linked list manner. In the next session, I can continue. Thank you for this video. Hello students, welcome to the C language training program. Today I want to discuss about linked list in data structures. C language data structure, what is the need of linked list, why you have to use the linked list, what are the advantages of linked list. Now see, the last session I discussed which is the data structure, queue data structure I discussed. Under data structure, you have different type of data structures, stack, queues. Stack is nothing but last in first out. Which element is last inserted, that to be removed first. Which element is first inserted, that to be removed last. Queue is also one type of data structure. It's a FIFO manner, first in first out. Which element is first inserted, that should be removed first. Which element is last inserted, that should be removed last. Stack is a LIFO manner, last in first out. Which element is last inserted, that should be removed first. Which element is first inserted, that should be removed last. Which are the stack operations? Push, pop, display. Push is nothing but to insert an element into the stack. Pop is nothing but to remove the element from the stack. Display is nothing but to travel the elements from the starting element to ending element. How to make the operations of stack based on the top index. Which element is first inserted, that is the top index. If I inserted second element, top index increments. If I insert the third element, top increments. Every insertion time, top increments. Every deletion time, top decrements, decrement the top. If I have 3 plates are there on the dining table, if I want to place the fourth plate, top of the third plate you want to insert. If you want to remove the plate from the dining table, which is the topmost plate, that should be removed first. Top only to insert, top only to delete. What is the drawback of stack? It can be worked with arrays, and one more problem, one end only insertion, same end only deletion. Top only to insert, top only to delete. One more data structure you have, queue data structure. Queue is a FIFO manner, first in first out. Which element is first inserted, that should be removed first. Which element is last inserted, that should be removed last. Which are the queue operations? NQ, DQ, display. NQ called as insertion element into the queue. DQ called as deletion element from the queue. Display called as to traverse the elements front to rear. Every queue 2 indicators we have. One is for front, another one is rear or back. First element index is called as front, last element index is called as rear. Front, put the new element into the queue, rare increments, rare plus plus. Every deletion, dq function front position to delete the elements. Once you remove the element which to be increment front plus plus. Insertion time rare to be increment, deletion time front to be increment. If I want to display the elements from the queue, front to rare. Front index is 0, rare index is size minus 1. Front to rare to display the elements. What is the drawback of the queue? Anywhere insertion not possible, anywhere deletion not possible. And one more drawback of the queue is a array manner. Generally array is nothing but static memory allocation. Once you fix the size of queue, you can't increase the size, you can't decrease the size. What is the drawback of the stack and queue? Stack and queue drawback, anywhere insertion not possible, anywhere deletion not possible. Insertion is at rear, deletion at the front. And one more drawback, stacks and queues are static memory allocations. Static memory allocation means once you fix the size, you can't increase the size, you can't decrease the size. That is the reason one more data structure is introduced in C language. The data structure called as linked list manner. Linked list is one of the data structure to store the data in the form of list. What is the advantage of linked list? Anywhere can insert the elements, anywhere can delete the elements, anywhere you can display the elements. The main advantage of linked list, insertion at anywhere, deletion at anywhere, display the elements from the first to last. One more advantage, linked list dynamic memory allocation. While working of linked list, dynamic memory allocation. What is meant by dynamic memory allocation? Now dynamically you can create the list, dynamically to add the elements. That means dynamically you can increase the size, dynamically you can delete the size, decrease the size. Once your usage of memory, you can delete the memory also. You can create dynamic memory allocation functions you can create. Malloc function, calloc function, free function that you can operate with the help of linked list. Dynamic memory allocation possible with help of pointers. Pointer variable should be created. Finally, what is my conclusion? Why you have to go for the linked list? Advantage of linked list, insertion, deletion, display anywhere. You can insert the element at the front also, rear also, middle also. Deletion also at the beginning also, ending also, middle also. One more advantage, dynamic memory allocation. Once I create the size 2 elements, but later I want to increase my size, possible. You can decrease the size, possible. With the help of dynamic memory allocation functions, malloc function, calloc function, free function. Linked list possible using pointers, with the pointer only to create the linked list. Actually, what is the definition of linked list? List is nothing but store the elements. Linked list is nothing but store the elements and link to the next element address. One list is store the element and it is represent next element address. Link between the two elements. How to link of the in between the two elements? Pointer should be created. How to define the linked list? List of elements linked with the help of pointers. Linked list is a dynamic memory allocation. Linked list insertion, deletion, display anywhere. Linked list how to create with the help of pointers. You can create with a next pointer, previous pointer, element. Linked list types are there. Types of linked list is there. Single linked list, one-way direction to be traveled. Doubly linked list, two-way direction can be traveled the elements. Circular linked list, it's a circular manner. Any node to any node you can travel. Link of the chain, circular linked list. Any node to any node you can travel. Single linked list, doubly linked list, circular linked list. Finally, what is my conclusion? Why you have to go for linked list? Once you create the linked list, the list of elements are stored and that is linked with another list element. That is nothing but one element linked with another element. It's a chaining manner. Pointer will be creates. Linked list anywhere insertion possible, anywhere deletion possible. It's a dynamic memory allocation, memory saving. And one more advantage, easy to travel, either front to back or back to front. Left to right can be travel, right to left can be travel. The types of linked list are single linked list, one-way direction to be travel, doubly linked list, two-way direction to be travel, circular linked list, it is similar to doubly linked list, but the last node pointing to the first node address. Circular linked list, any node to any node to be travel. The last node link connected to the first node pointer. See that how it is works of linked list. Now I want to discuss about linked list. Under C language data structure, linked list to be discussed. Now see the linked list, every list how to represent node. Under linked list, how to represent your data node to be created. Now this is called as node or list, node or list. Every node, if I go for singly linked list, every node two partitions. If you go for singly linked list, you can go for two partitions. It is called as node. I represented it is called as node. Now this is for what? Data to be stored. Now this is for what? Star pointer. Address of the next element. Now every node two partition you have. This is called as element to be represent, and this is called as pointer. It is pointing to the next element address. This is element or data. This is pointing to the next element address. If you go for doubly linked list, the node will be represent three partitions. If it is singly linked list, node will be represent two partitions, element and pointer to the next. If it is doubly linked list, three partitions, data, and this is called as what? Star pointer. It's a left side pointer, and this is also called as another pointer, right side pointer. Now three partition you have. This is also called as node, but doubly linked list three partition. It is called as left pointer, left element address. This is called as right pointer, right side element address. This is called as element. Now this is the representation of singly linked list. Each node represent two partition, data plus next node address, its pointer. And for the doubly linked list, three partition for node. This is called as previous pointer, this is element, and this is next pointer. And for circular also the same way, but the circular, the last node can be connected to the first node, which is the last traveling pointer that will be connected to the first node previous pointer. Now see that how to create the nodes. Linked list, you have three types are there. First I represent singly linked list. How to represent the singly linked list? Singly linked list or single linked list. Singly or single linked list. How to represent that? Suppose I taken with three nodes. If I represented with three nodes, here I have three nodes are there. Three nodes I represented. These are called as nodes. This is called as nodes or list. Now this is my node 1. What is my name of the node? A. Node A. This is my node B. This is my node C. I given the name node A, node B, node C. Now I want to represent with 10 elements or data. I want to connect it to the star NXT, next pointer. It's a pointer. Next 20, and for the star next pointer. That means what? A element is 10, A next pointer connected to the B node. and for the B element is 20, B next pointer connected to the C node, and C you have the element is 30. What is the next pointer? For the C there is no next nodes. C is the last node. C is the last node. There is no any next pointer. Instead of next, which will be there? Null. What is meant by null? Represents which node have the null pointer. That node is the last node. Which node have the null pointer? That node is the last node, end node. Which node is the first node? That node called as head node. It is called as head node. This is called as tail node, I mean last node. This is head node, that is last node. Every singly linked list, this is the way to be traveled. Observe here how to create this node. Suppose I want to create this node. How to create the node? What is the syntax of node creation? Struct node. How to create the node? Struct node. Because I want to create the node, node is our defined, user defined data type. How to create a structure name? Inside of that, int data or element. Under node, what is my first partition? Element. This element is integer type. If you are enter string means string type. If you are enter character means character type. This element is integer. Under this node, I have the element and the next pointer, I mean next node address. I am working on A node, but under A node, what is the A next pointer to the B node? B also structure, B also node. Now I want to call with struct node star next. Struct node star next. I am creating under node structure. Every node two partition, element and star next. Again the star next indicating which node? Again structure node, B node. Again this is calling element and star next. And the B next pointer locating to the C next node. B next node is C, C element is 30, C next is null. That is called as what? Every struct node itself calling the node, itself calling the same node. Because every node itself calling the same structure. It is called as recursive structure. What is meant by recursive structure? One structure inside, same structure calling. You are writing on node structure, under node, again you calling the node star next, again calling. It is called as self structure, or it is called as recursive structure to be called. Now, how to create this node memory? How to create this node memory? How to create this node memory? Malloc function to be created. Struct node. Once I declare the structure, I want to declare the variable. Struct node, structure name node, star A. First I created struct node, element and star next. This is the node syntax, node creation syntax. Once I create the structure node, I want to make a variable of node, star A, variable of node. How to make of this memory allocation now? A equal to dynamic memory allocation functions. Which are the dynamic memory allocation function? Malloc, calloc, free function. Now here A node I want to make a memory. A equal to, A is a which type of pointer? Struct pointer. What type of pointer? Struct node star. It's a structure pointer. MALLOC malloc function. MALLOC malloc function, memory allocate, size of which data type? Node. Size of node. Size of node means size of A. Suppose A node element 10. If it is 10 is integer, how much memory create? 2 bytes. If this element is string, based on the string size. If element is character, 1 byte. Size of node into 1. 1 called as 1 node can be created. This is the syntax of this. Struct node star A. A is a node pointer. How to create memory? A equal to struct node star. Node pointer, MALLOC malloc, memory allocation. Size of node, I mean whatever node I created, size of node. If my node consists with 10 means integer 2 bytes and next node address. Size of node into 1 node memory creates. Once I allocate this memory, After that, how to free the memory. Suppose I want to destroy this node. I want to erase this node. Once I create that node, I used that node, I display that node. After that, I want to remove the node. Free function. Free of A. Free of A. That means A node will be free. Now this A node already created with malloc function. A node created with malloc function. Finally free of A. Delete the node. A node will be destroyed. The memory will be deallocated. These are the major syntaxes for singly linked list creation. Every single linked list, each node represents two partitions, element and star next node address. If I have A element is 10, A next node is B. B element is 20, B next node is C. C element is 30, C next node is null, because there is no any other nodes. Which element have the null? Which node you have the null pointer? It's a last node. Which node you have the null pointer? It's a last node. It is called as style. Which element is the first node? It is called as head. How to create the node? Syntactically, struct node. After that, int element, first partition, struct node star next, because every node consists with another node address. That is the reason I calling of self structure. A structure node inside, again struct node calling, recursively calling. How to create memory allocation now? Struct node. What is my variable? Star A. A is a variable of struct node. A equal to struct node star. A is a node type. MALLOC, malloc function. Size of node. I want to make a memory dynamically for size of node. Into 1 means one node memory. How to free the memory of that? Free of A. Memory will be destroyed. The node will be destroyed. These are the basic syntaxes for to create the node. Create the malloc function, create the free. Every linked list program, this is the basic functionality to use. Single linked list also basic function, doubly also basic, circular also basic. Now, when I create the singly linked list, insertion at anywhere, deletion at anywhere, and display also anywhere. What is the advantage of a linked list? Anywhere can insert the elements, anywhere can delete the node, anywhere can display the node. Suppose I have one linked list. Suppose I created 3 nodes. A, and this is B node, and this is C node. I have 10 and star next pointer, and 20 star next pointer, and 30 null. This is my actually list I created. Totally this list I have 3 nodes, A node, B node, C node. Now what is my request now? Insert. I want to go for insertion. My request is insert. Insert one new node. What is my new node name? Temp node. I want to insert the temp node. Temp node I want to insert. I want to insert the new node, temp node, at beginning. I mean at the head section. Actually, linked list insertion possible at the beginning also, at ending also. I mean head position also insert, tail position also insert, in between also insert. Before A also you can insert temp node, after C also you can insert temp node, in between A, B also insert, in between B and C also insert. What is the advantage of linked list? Anywhere insertion possible. Beginning, I mean head position possible, ending, tail position possible, in middle. But when you go for Q, wherever insertion possible, rear only insert. Wherever deletion possible, front only delete. When you go for stack, wherever insertion possible, top only insert, top only to delete this. But here anywhere you can insert the elements, anywhere you can delete the elements. Now here, if I want to insert temp node at the begin, before insert this node, before insert, what is my operation? Before temp node insertion. I want to insert temp node at beginning. Before insertion, what are the conditions? Before insertion, what is the condition? If A node I created, A of element equal to 10. Now this is my first node, A. A of element equal to 10. A arrow next. What is meant by arrow? Indicates structure pointer. If your variables are normal structure variable, dot operator to use. Dot indicates structure normal elements to be accessed. What is meant by arrow? Indicates structure pointer, structure with pointer. Now A is a structure pointer element of 10. A is a arrow next. A arrow next equal to B. What is the mean that? A next node assigned to the B node. A next pointer is B. Now here which is the head node? Head star head equal to A. What is mean by head? Head is nothing but first node. Which is the first node? A. Initially this A is a head node. A of element is 10. A of next is B. After temp node insertion. After temp node. Where I want to insert that? Before A, I want to insert the temp. Before A, I want to insert the temp node. Before A. When I insert the before A, I want to insert the temp node. When I insert the temp node, now this is my temp node now. Before A inserted. Now this is my before A inserted. What is my element here? 40 and star next. Star next. Now see, before temp node, this is my head node. After temp node insertion, now which is my head node? Now head is moving to here. Now this is my head. Head is moving to this position, head. What is my conditions here? Temp. Temp of element equal to 40. Temp of element. Next, temp of next. Temp is my new node. Temp of next pointer equal to A. And which is the head node? Head equal to temp. Head equal to temp. Before temp node, A is the head. After temp node, temp is the head. That means head is moving at a temp. Previously A is the head. Similarly, I want to insert node at ending. I want to insert node. Similar way, I want to insert temp node at ending. Tile position. Tile position to insert. Suppose I have the 3 nodes. I have the 3 nodes. Here I want to insert the temp. A node, B node, C node. 10 star next. 20 star next. 30. Actually this is null, but I inserted new node. Temp node I inserted. After last node I inserted temp. 40 null. Now this is putting null. Which position I inserted? Tile position. Before insertion of temp, this is my tile. After insertion of temp, which is my tile? Temp is tile. Before insertion of temp, C is the last node, tile. After insertion, temp is the tile. Before insertion of temp, C is the tile. C element equal to 30. Before insertion of temp, C element is 30. C of next is null because there is no any next node. C of next pointer equal to null, no element. Which is the tile? Tile is C. C is the tile. After temp node insertion, after insert that, temp of element equal to 40. C of next pointer connected to the temp. C of next pointer connected to the temp, and temp of next pointer. What is my temp of next pointer? Null. Null will be represented. Finally, which is my tile node? Temp is the tile. Temp is the tile. Previously C is the tile. After temp, now tile is the temp. Now in this logic, temp is inserted before A, I mean head position. In this logic, temp is inserted after tile, I mean after C node. Similarly, you can insert the node at the middle also based on our index. Based on our index position, you can insert the node. Similarly, you can insert the node at the middle index. At the middle index also, you can insert the node. How to insert the node at the middle index? Singly linked list only, anywhere you can insert, head, tile. Now, insert node. I want to insert the node temp at mid position or at 0 index. 1 index. 1 index means second position. 1 index means a second position I want to insert. 1 index means second position how to insert. I have 3 nodes. Here I created with actually A. Now this is B, this is C. Here I inserted temp. What does that mean? That in between A and B I inserted temp. In between A and B. Now here 10 star next, 40 star next. Now this is 20 star next. Now this is for 30 null pointer represents. When I link of these, when I use of these, here temp node I inserted at the middle. Previously temp is inserted at header and one more is temp is inserted at tiler, but this is temp is inserted at which position? First index, I mean second position. Second position I insert. Now the head is A, no changes. Tile is C, no changes. Head is A, tile is C, no changes. Here I want to insert. How to insert that? What are the conditions? A arrow next equal to temp. Actually before temp, what are the logic? Before temp. If there is no temp, what is the logic? Before temp, what is the logic? A of next equal to B. A of next is B. After insertion, after temp, what is the logic? A of next connected to the temp. A of next connected to the temp. And temp of next connected to the B. Before temp node insertion, A of next is connected to the B direct, but here A of next connected to the temp of next connected to the B. That is called as after. Head and tile no changes. This is head, this is tile. Finally, what is my conclusion? Singly linked list 3 operations we have: insertion at the beginning, insertion at a tile, insertion at a middle. Insertion at the beginning, head position, insertion at ending, tile position, insertion at a middle based on the index. Similarly, deletion also possible. If I want to delete the nodes, singly linked list only deletion, beginning and ending and middle. Suppose delete node at begin. I want to delete the node at begin, I mean head position. Head position I want to delete the node. Head position I want to delete the nodes. Suppose A, now this is B, now this is my temp. Suppose this node I want to erase. 10 star next, 20 star next, 30 null. I want to delete this temp, I mean this middle node I want to delete. When I delete this temp node, sorry, this is delete at not begin, it's mid, mid position. Which position now? First index. Whenever I delete this, A of next connected to the B. Before deletion, A of next is temp, temp of next is B. After deletion, A of next is B. You see that? Before deletion of temp, A of next is B. After deletion of temp, before deletion, A of next equal to temp node, and temp of next is B node. After deletion, how to delete the node? Free function, free temp. Free means erase. At that time, A of next moving to the B node, A of next link to the B. Suppose one more operation I want to use. Delete node at begin or head position. I have 3 nodes. I want to delete the node at the begin. This is my temp node A, B. I want to delete 10 star next, 20 star next, 30 null. This is my last node. Now I want to delete this node, head node, I mean beginning node I want to delete. Before deletion, if I don't want to delete this, before deletion, temp is my header, after deletion A is my header. Before this node deletion, head is the temp, after deletion head is moving to A. Temp of element is 10, temp of next equal to A, which is the header, temp is head. After deletion, after deletion of this, how to delete? Free of temp. After deletion, now this A is the header, A of element is 20, which is the header, A is the head after deletion, because temp is deleted. That if I want to delete the node at tile position, delete node at end, I mean tile position. If I have 3 nodes, I want to delete the node at the last position. This is A, B, temp, 10 star next, 20 star next, 30 null. Suppose I want to erase this node, temp node I want to erase, last node, which is my tile position node that I want to erase. Whenever I erase this, before deletion, what are the operations? Before deletion, tile is the temp, after deletion tile is B. Before deletion, suppose if I use with B of element equal to 20, B of next equal to null. Before deletion now, B of element is 20, B of next is temp. B of next is temp, temp of next is null, temp of next pointer null. But after deletion, once I delete the node, free, which to be free? Temp to be free. I want to delete the temp node, free node, temp to be delete. Once I delete that, this B next pointing to the null. Now here B of element 20. What is the B of next pointer? Null. Null will be represented. That is called as what? Totally here 3 deletion operations. Deletion at the middle also delete, deletion at the beginning also you can delete, deletion at ending also you can delete. Whenever I delete the middle node, header tile no changes. Whenever I delete the first node, head is moving on the next node. Whenever I delete the last node, tile is moving the previous node. Those are the changes. Now I want to display the elements, singly linked list only. If I want to display the elements, display the list of elements. Singly linked list only you can display the elements. Which node to which node can be displayed? Header to tile, that all elements can be displayed. Header to tile, that all list of elements can be displayed. How to display that elements? Suppose if I have one linked list, I want to go for display function, display the nodes. My logic is void display, display the nodes. If I have the nodes, how to display the singly linked list nodes? If I want to display the nodes, suppose I have A, this B, this C. Now if I have 10 star next, 20 star next, 30 null, I want to display the node, void display function, I want to display this. Now this is my head node, this is my tile node. How to display that? While loop. Here I used with initially first node I take it as head node. Suppose here I started with head equal to A. Initially A node is pointed to the head. Now here I used with while, otherwise here head I travel to the P. P for head node I consider, while P arrow next, P for pointer, P arrow next not equal to null. P is nothing but initially head. I mean this is my first P. What is the P of next B? Next what is the P of next C? What is the C of next null? Until that it will be travel. Initially this is my P. P is a temporary pointer. P next is B. Next P is moving here. Now this is my P. Next this is my P. Wherever P next is null, stop the process. Initially P indicate the head. Now how to print off that? Printf %d. I want to print the elements. How to print a P arrow elements? Initially what is my P? A is my P. What is the A element? 10. What is the P of next? B. B is not a null. Again P point out to the B. P of element is 20. P of next C. What is the C? P element 30. What is the P next? Null. Stop there. Until that you have to travel. Element to be print P arrow element. How to move the next? P equal to P arrow next. What is mean by P equal to P arrow next? Incremental. Initially P is at a head. It is moving to the next. Next P is moving to the next. Wherever null, there to be stopped. This is the logic of void display function logic. What is a void display function? Initially P indicates the head. Whenever P of next not equal to null, then I want to print the elements. Whenever P equal to null, stop there. P equal to P of next, incrementation process. Finally, these are the functions to be operate for singly linked list. Singly linked list, what are the function you have? Insertion, deletion, display. Insertion at 3 positions you have. Insertion at the beginning, insertion at ending, insertion at a middle position. Similarly, deletion also at the beginning, deletion also at the ending, deletion also at the mid index position. And one more function you have, display function. How to travel the first node to last node to be display the elements. But actually every singly linked list one way direction only to travel. What is the drawback of singly linked list? Suppose A is my first node, A next pointer point out to the B, B next pointer point out to the C, C next pointer null. Every single linked list one way direction only travel. Only one null pointer will be indicates. If I go for doubly linked list, two way direction can be travel. I mean A to C can be travel, C to A can be travel. Single linked list only one way direction, doubly linked list two way direction also travel. That is only major difference. Singly linked list and doubly linked list difference. If you go for doubly linked list, what is a partition you have? Doubly linked list. You see the doubly linked list, each node 3 partitions you have. Each node 3 partitions. You have the previous pointer and next pointer. Doubly linked list. Single linked list advanced is doubly linked list. Whenever you mention the doubly linked list, the node you have the 3 partitions. This is called as element star previous star next. 3 partitions we have. How to create the struct node? This is my node, struct node. First one is previous pointer. It is for self structure. Struct node star previous. Middle is element. Int element. Again struct node star next. How to make a variable of these? Struct node star A. Struct node star A. This node consists with the previous pointer, element and next. This is my variable A. How to create that? A equal to dynamic memory. Struct node star MALLOC malloc size of node into 1. I mean one node. This is for malloc function to make a memory for this node memory. How to free the node? Free function. Once I allocate free of A, destroy the node. Malloc function to create the node, free function to destroy the node. Every this doubly linked list node, 3 partition you have, previous pointer, element and next pointer. Otherwise, this is called as left pointer address, left node address. This pointer indicates right node address and middle. If you go for doubly linked list traveling, you see that traveling of doubly linked list, that is also insertion possible at a header, deletion possible at a tile. Anywhere you can insert, anywhere you can delete. You see that doubly linked list also you have 3 partitions. 3 partitions you have. Suppose this is A node, this is B node, this is C node. For the doubly linked list, 2 null pointers. A, first node left pointer null and last node right pointer null. 2 null pointers. First node left pointer null, last node right pointer null. I mean, this is my star previous, this is my star next. 2 nulls you have. Now here, 2-way direction it will be travel. 2-way direction, A to B, B to C, C to A, C to B, B to A. 2-way direction. This is 10, star next. This is 20, this node you have star previous, star next. Under A node, B node address only available, but under B node, A node address available, C node address, previous and next. Under C node, previous address available, there is no next address. These are for doubly linked list manner to be travel. Now for the doubly linked list, this is my head node, this is my tile last node. Doubly linked list also insertion at before A, I mean before head node, insertion at the beginning, insertion at ending at a tile last position you can insert the new node, and in between A and B you can insert, in between B and C. Insertion at a head position, insertion at tile position, insertion at a mid index. Similarly, deletion at a head position, deletion at a tile position, deletion at a mid. Suppose I want to insert one new node. What is my node I want to insert? Temp node I want to insert. I have 2 nodes. Suppose I have 2 nodes A, B. This is A node, this is B node. In between I want to insert new node. What is my new node I want to insert? Temp node. This is my temp node, insertion of node. This is my A, star next. Now this is my temp, this is my temp. Now here I inserted that. Now this is my temp, this is next pointer null. This is my previous pointer 30 star previous star next. Now here where I inserted this, this is null, where I inserted the new node in between A and B. Before insertion this node, what is the A of next? B. Before this temp node, A of next is B. B of previous is A. After insertion of this, A of next connected to the temp of previous is A, temp of next is B node. What is the B of previous? Temp. Before this temp node, A of next is B. After this temp node, A of next is temp node, temp of previous is A node, temp of next address is B node, B of previous is temp. At the time head and tile no changes, head and tile is same position to use. Finally, what is my conclusion here? Linked list, what is the advantages of linked list in C language data structure? Majorly 2 advantages. One is for anywhere insert element, anywhere delete the elements, anywhere display the elements. One more advantage, dynamic memory data structures. Dynamically you can increase the sizes, dynamically you can delete the sizes or update the sizes or display the elements. What is the major advantage of this? Insertion, deletion, display at anywhere, dynamic memory allocation, malloc and calloc, and free functions. Those are used with pointers. What are the drawbacks of stacks and queue data structures? Both data structures static memory data types. Dynamically you can't increase, those are fixed size. And one more problem, queue means insertion at last, stack means insertion at the top only insert, top only delete. Q means insertion at last, deletion at front. Anywhere insertion, anywhere deletion not possible. That is the reason which data structure introduced a linked list. What is mean by list? List is nothing but to represent the elements. Linked list means in between the two elements to make a pointers. Link will be there. Three types of linked list you have: singly linked list, doubly linked list, circular linked list. Singly linked list means a one-way direction to travel. Doubly linked list means a two-way direction can be travel. Circular linked list, last node can connect to the first node. Last node pointer can connect with first node pointer. Singly linked list, each node two partition, data and the next node address. Doubly linked list, each node three partitions, previous pointer address and next pointer address and elements. Circular linked list also three partitions, but the last node can connect with first node. But the singly linked list, doubly linked list, circular linked list created with dynamic memory allocations, malloc and free functions. Structure to be created, after that malloc and free. Then tomorrow session I can continue the doubly linked list operations and circular linked list operations. Then tomorrow session I will continue. Thank you for this video. Hello students, welcome to the C language training program. Today I want to discuss about doubly linked list in C language data structures. Today I want to discuss about doubly linked list C language data structures. Now the last session I discussed singly linked list data structure. What is meant by linked list? It's a collection of elements with a link of pointers. Linked list is nothing but, list is nothing but collection of elements. Linked list is nothing but collection of elements connected with the pointers. Now every singly linked list one-way direction can be traveled. Every singly linked list one-way direction can be traveled. Now which is one way direction to be traveled now? Left to right you can traverse the elements. Singly linked list, each node contains two partitions. One is for data, another one is called as next element address. Every node consists with two partitions. The first partition consists with data or element. Next partition consider next element address. It is also called as pointer. Singly linked list, one way direction only you can travel. You can travel one way direction, left to right. Singly linked list, which are the basic operations: insertion, deletion, display. What is meant by insertion? Insert a node at beginning, head position. Insert a node at tail, ending position. Insert a node at mid position, based on the location. Insertion at three positions: insertion at beginning, insertion at ending, insertion at mid index, based on the location. Deletion operation function: deletion at beginning, delete the node at beginning, delete the node at ending, delete the node at middle index. What is one more operation for the singly linked list? Display function. How to traverse the singly linked list elements? Display function to be used. Wherever the list contains null pointer, that is an indication of end of the list. Which list you have the null pointer, that is a last node or tail node. Which list you don't have the null pointer, continue to the next element pointer. Wherever null pointer tracing, stop the display, stop for reading. Now today I want to discuss about a doubly linked list data structure. What is the difference of singly linked list, doubly linked list? Major advantage of doubly linked list, it is traveling two-way directions. Singly linked list traveling only one-way direction, I mean left to right only you can traverse the elements, but right to left cannot be traverse the elements. That is possible under doubly linked list. Doubly linked list is equal to singly linked list operation: insertion, deletion, display. Insertion at the beginning, insertion at the middle index, insertion at the ending. Deletion at the begin, deletion at the ending, deletion at the mid index. And for the display, two display function you have. One display for left to right traveling, another display function right to left traveling. Because of doubly linked list two-way direction, one direction display left to right traveling, another direction display right to left traveling. What is a important point of doubly linked list? It is traveling two-way directions. Every node consists three partitions. Each node contains three partitions. The first partition called as previous node address, the middle pointer called as element or data, the next pointer called as next node or next element address. Every node three partitions we have. One is for left node address, another one is for right node address, the middle one is element. Doubly linked list, two null pointers you have. The first node left pointer is null, the last node right pointer is null. Which is the first node? The left node is null, left pointer is null. First node is also called as head node, last node is called as tail node. Head node left pointer should be makes null, tail node right pointer should be makes null. Two null pointers you have. Doubly linked list operations are insertion, deletion, display, and display for two functions we have. One is for left to right direction to be display, right to left direction. Doubly linked list is a pointer method. With pointer only you can create, similar to singly linked list. Doubly linked list you can create with a dynamic memory allocation. How to make a nodes? Malloc function. How to delete the node? Free function. Dynamic memory allocation to use. You see that how to create the doubly linked list. First you want to discuss about the doubly linked list. First to be considered as node. The first to be considered as node. Suppose every doubly linked list, this is called as node. This node consists three partitions. The middle partition called as data, next left side pointer called as LPTR, left pointer left node address, right side pointer called as RPTR, right side pointer address. Every node consists with three partitions. It is called as left node address, it is called as right node address, the middle you have to use the elements. This is called as doubly linked list structure you have. How to create the node struct? How to create the node? Struct node. Doubly linked list, how to create the node? Struct node. First I want to create with struct node star LPTR, that is called as left pointer. It's called as previous node address, int data or element. Again the struct node consists another node pointer, struct node RPTR, it is called as right pointer. Now this is the syntax of node creation. How to create the node? Struct node. Node is a user defined data type. Under this node you consist with LPTR, I mean left node address, struct node star LPTR or previous node. Middle you have to enter the element. Next struct node RPTR, it is called as right pointer, next node address. LPTR consists with previous node address, RPTR consists with next node address, the middle one is element. How to create the dynamic memory. Struct node, actual structure name is node. I want to create with a temp. Temp is my node. Struct node is a structure name. What is my variable? Temp variable. It's a pointer. Temp variable consists with struct node. How to create a memory? This temp, how to create memory? Temp equal to struct node star dynamic memory allocation. Struct node star. Your temp node is struct node star pointer MALLOC. Malloc function to be create. Size of that node. Whatever node you created, that memory size to be create into 1. One node to be create. This is called as how to make a memory for the temp node, memory allocation. This is used for how to make a node, malloc function. How to free the node? Free of temp, memory destroy, node to be destroyed. Now this malloc function used to create the memory dynamically. This free function used to destroy the node, to remove the memory dynamically, free function. Now this is the syntax to be create for doubly linked list node creation syntax. How to create the node for doubly linked list? Struct node star LPTR. It's a self structure. LPTR means previous node address. Int element struct node RPTR. It is consists with next node address. Struct node star temp is called as temporary pointer. Node temporary pointer. How to make a memory? Temp equal to struct node star node pointer, malloc function to be used, size of node, how much memory required for the node into 1. How to destroy the memory? Free function, free of temp, memory to be destroyed. Now I want to work with operations. How to create a doubly linked list operations. Which are the doubly linked list operation? First one, insertion. Doubly linked list first operation, insertion. Now I want to go for insert node. Insert node at begin, I mean head position. How to insert the node at begin? Head position, how to insert? I have, you see, I have two nodes I have. First I created two nodes. These are my two nodes. My first node is A, second node is B. First node is A, second node is B. I have 10 is a element. Now this is for RPTR, I mean right side pointer. Now this is LPTR, that means left side pointer. It's a left side pointer, it is right side pointer. Now here 20 is the element. Here null. Now for the B node right pointer is null because there is no any elements. I want to travel with the two-way directions because doubly linked list. Now for the A left pointer is null. Actually I have two nodes. A is one node, A element is 10, A right pointer is B. Suppose this node address 600, suppose 600 is the address. Now here which information is storing? 600. Now for the B node address is 600, suppose that 600 address will be stored under A right pointer. Now for the B, suppose this A node address 400, suppose. At that time LPTR which information stored 400 and there is no right side node, null pointer. That means what? A node address 400 stored into B previous. Now for the A right pointer stored with the B address 600. Now here I want to create a node at the begin. I mean before A I want to create one node. Before A I want to create the node. Now which node I want to create? That here I want to create the node. What is my node I want to create? Temp node. Temp node I want to create. For this temp node 30. Now here I want to connect with here I want to connect. Which I want to connect here? RPTR, that is called as A node address. Now here temp node left pointer null. Here I inserted, new node is inserted here. Now here this null will be eliminated. Suppose this temp node address is 300, suppose. Now this 300 stored into this location LPTR 300 is stored. Now here under temp right pointer is stored with 400. Finally what is my conclusion here? Temp of element is 30. Temp of previous pointer is null. temp of right pointer calling to the address operation a arrow, element is 10. Arrow indicates structure pointer, your node is structure pointer, ALPTR, that is called as left pointer. ALPTR, before temp node, ALPTR is null. ALPTR is null. Now here, which is the head node? Head node is A. The first node is A. Head node is A. After temp node insertion, whenever I insert a temp node, what are the operations? When I insert the temp node, now here temp of next, otherwise temp of right pointer. Temp of right pointer equal to which node? A. Temp of right pointer keep to the A address. Temp of element is 30. Temp of element is 30. And temp of LPTR, left pointer, equal to null. Null is moving. Now, which is the head node? Temp is the head node. In this statement, temp is the head. Now, you see here, I want to insert, actually A node is there, B node is there, two nodes are there. A node element is 10, A node left pointer null actually, A node right pointer is B address. Now, for the B left pointer is A address, B right pointer is null. Now, for the B element is 20. I want to insert the new node at the beginning. Temp is my new node, I want to insert at begin. Head position I want to insert. Before temp node, what are the operations of A? Before temp node, what are the operations of A? A element is 10, A left pointer is null, there is no node, left pointer null, A, head is A. Whenever I insert a temp node, now head is moving at a temp, now head is moving here. What is the temp of right pointer? Temp of right pointer is A and the temp of left pointer is null. Temp of element is 30, which is head node. Temp is the head. Before adding, head is A. After adding temp, temp is head. This is for insert node at begin. This is the statement. Suppose I want to insert a node at end position. I want to insert a new node at end position, that is called as tile position. I want to insert the node at a tile position. How to insert the node at a tile? What is my operation here at the end position? I have two nodes are there, A, B. Here I have A and B. One more new node I want to insert, temp node. Now this is A, this is B. Temp is my new node. I want to insert temp. 10. Now this is null pointer, this is right pointer. Now this is 20, this is left pointer, this is right pointer. Now for the temp 30, new node. Now here left pointer, here I have left pointer, right pointer is null. Two-way direction. Every doubly linked list two-way direction travel. Now I am inserting new node at temp, at ending. I am inserting new node temp at end position. Now see, before insert temp node, what are the operation? Before insert temp, what are the operation? B of element is 20. B of element is 20. B of right pointer. B of right pointer. B of right pointer is null. Because B is my last node. Before temp B right pointer is null. Now B left pointer, which is the B left pointer A. Which is the tile node? Tile means last node, B is the tile. After insert temp node, I want to change the operations. After insert the temp node, what to be changed? B of right pointer equal to temp, right pointer move to the temp, and the temp of left pointer should be make to B. B of right pointer is temp, temp of left pointer B. Now temp of element equal to 30, temp of right pointer, which is the temp of right pointer here, null. Temp of right pointer null, which is the tile, tile is temp, temp is the tile. Before temp node insertion, B is the tile node. After temp node insertion, tile is moving. Whenever tile is moving, null also moving. Before insertion, B of right pointer is null. After temp node insertion, temp of right pointer is null. Now here I want to go for insert node at mid position. Mid index I want to insert the node. Now I want to insert the node at the mid index position. Mid index to be inserted. Previously beginning position and ending position. Insert node at mid index I want to insert. Mid index I want to insert. I mean based on the position to insert the nodes. I have A and B. A is one node, B is one node. I created temp here. Temp is my node. Temp is my new node. What is my mid position index? Index position, index is 1. I mean second position. This is 10. Now this is null pointer. This is right pointer. Then this is 30, left pointer. And this is right pointer. And 20, this is left pointer, null. I want to insert the node at middle position. Now this position I insert. Previously temp node inserted at last. Now I want to insert temp node at in between A and B. In between. Before temp, which are the operations? Before temp, which are the operations here? A of right pointer is B. B of left pointer is A. A of right pointer equal to B. Before temp node insertion, A of right pointer is B. Now B of left pointer equal to A. Just two statements. Before temp node insertion, A of right pointer is B connected, B of left pointer is A connected. After temp node insertion, A of right pointer equal to temp. After that, temp of left pointer equal to A. After that, temp of right pointer, I mean next temp of right pointer is B. Now for the B of left pointer is temp. This is the statement. What are the statement to be right? When I insert the temp node, A of right pointer is temp. Temp of previous left pointer is A. Temp of right pointer is B. B of left pointer is temp. At that time, head no changes. Head is A and B is tile, no changes. Now in this insertion, temp is mid, head is at A, tile is at B. Head and tile no changes. This is called as insertion at begin, insertion at ending, insertion at middle index. How to delete the node at begin, at end, at middle. How to delete the node? Previous operation insertion, but I want to work with deletion. How to delete the node? Deletion also 3 chances you have. I want to delete the node at begin. First position, how to delete the node at begin. I have some node. Now here I have that 3 nodes in my linked list, 3 nodes. Now this is A, this is B, this is C, 10. Now this is null. Now this is right pointer. Now this is 20, left pointer. This is right pointer and 30. This is left pointer, null. Now two-way direction to be travel. It is doubly linked list, two-way direction. I want to delete node at the begin. That means this node I want to delete. I want to delete the A node. Before deletion, what are the operations? Before A node deletion, which is the head? A is the head. Before A node deletion, A is the head. After deletion, head is moving to B. Now this is head. Before A node deletion, which is the A left pointer, null. After deletion of A, B left pointer, null. Before A node deletion, A left pointer, null. After A node deletion, B left pointer, null. Before A node deletion, right pointer is B, but here B left pointer is null. null to be used. Before A node deletion, this is head. After A node deletion, B is the head. Head is moving to B. What are the operation used? A of LPTR, left pointer is null, and A of RPTR, right pointer equal to B node. Which is the head? Head node is A. Head node is A. After deletion, how to delete that? How to delete the node? Free function to be used, free of A. How to delete the node? Free function, free of A. If you want to create the node, malloc function to be used. If you want to make a new node, malloc. If you want to delete the node, free function, free of A. After deletion, now for the B of LPTR should make to the null. I mean, this is null, this is moving on null. Now B of right pointer equal to C. Now here which is head node? Head node is B. Before deletion, head is at A. After deletion, head is at B. Head is also called as a root node, which is my starting node, that is head or root node. Now this is for delete node at the begin. Now I want to delete the node at ending. How to delete the node at the ending, end position, tile position, how to delete the node. Now I want to delete the node at the tile position. Delete node at end position, tile position to delete. I have 3 nodes. Now here 3 partitions. I have 3 nodes are there. A, B, C. I have 10. This is right pointer. 20 left pointer. This is right pointer, and 30 left pointer. This is null. Now I want to delete the node at the ending. C node I want to delete. Before C node deletion, tile is at C. Before C node deletion, tile is at C. After deletion of C node, B is the tile. Tile is moving. Before C node deletion, C right pointer null. After deletion of C node, B right pointer is null. Now here you make it as null. Before C node deletion, tile is at C. After deletion, tile moving at B. Before C node deletion, C right pointer is null. After deletion, B right pointer is null. You make it as null. Now you see how to make of that before deletion. This is null. Before deletion, how to use of that? C of LPTR, left pointer is B node. C of RPTR, right pointer is null. Tile node. Which is the tile? C is the tile. After deletion, how to delete the node? Free of C. After deletion of C node, B of right pointer should be make null. This is you make should null. Now B of element is 20, and which is the tile? B is the tile. Tile is B. Before deletion of C node, tile is C. After deletion of C, tile is B. This is called as what? Doubly linked list. How to delete the node at end position. Now for the deletion, only one more operation is there. How to delete node at middle index. I want to delete the node at the middle index. How to delete of nodes at the middle index. Now here I used with A node, and what is one more node I created here? B node and a C node. 3 nodes. This is B, this is C. Here I created 20 LPTR. This is right pointer. This is 30 LPTR. This is null. Now I want to delete of this node, middle node to be deleted. Delete node at the mid index. I want to delete the B node. In between A and C, B node to be deleted. Before deletion, what are the operations? Before B node deletion, A of A of RPTR, I mean right pointer, A of right pointer equal to B, and B of right pointer equal to C. A of right pointer, A of next is B, B of next is C. Now after deletion, when I delete that B node, when I delete, A of right pointer connected to the C, A of right pointer connected to the C. Now for the C left pointer moving to A. Whenever I deleted this B node, A of right pointer should connected to the C and the C of left pointer should connected to the A. Now these are the operation to be changes. Before deletion, A of right pointer connected to B left and B of right pointer connected to C, C left. After deletion of this, A right pointer moving to C, C left pointer moving to A. But in this position, head and tail no changes. Head is at A position, tail is at C position. Now for the doubly linked list, insertion at beginning also, insertion at ending also, insertion at mid index also. Similarly, deletion also, deletion at begin, deletion at ending, deletion at mid index. How to display the doubly linked list nodes? Suppose I want to display doubly linked list nodes. How to display? Here two display functions we have. Under doubly linked list, you have two display functions. First, I want to display here left to right. Left to right I want to display. My first functionality left to right. Suppose A, B, C. I have 10, this is null. Now this is RPTR, now this is left pointer, 20 right pointer, this is 30 left pointer, null. First I want to display left to right. What is my first display? Void disp1, display 1. Void disp1, display 1. How to display that? Here I used P. P is my head position. P is my head position. Now I mean which is the head node, that I say as P. While P arrow RPTR called as right pointer not equal to null. Whenever P of next not equal to null, moving on the next nodes, I want to print the elements. %D, I want to print elements. P of element. That means what? What is the first P position? A. Initially this is my P. What is the P of next right pointer? Not null. Not null means moving on the next. What is the P of element? 10. Moving on next. Now the P is moving to here. What is the P of element? 20. What is the P of right pointer? C. Moving on to this. What is the P of element? 30. What is the P of next? Null. Stop there. P will be moving. P equal to P arrow RPTR. P equal to P arrow RPTR. Now this is called as which function now? Void disp1. This is which direction to travel? Left to right. How to travel the doubly linked list? Left to right. Initially P is at a head, I mean this position. P will be moving on. P of next is B. Next P of next is C. C of next is null until that to be travel. If I want to display right to left, one more display function I have, right to left. How to display the doubly linked list elements? Right to left. Right to left, how to travel? Suppose I want to travel this direction. Whenever I travel this direction, suppose this is A, this is B, this is C. Now here this I started with P. Now this last node I started with the P. How to start off that? Here I want to go for a void. What is my function name? Disp2. Disp2. Now this disp function, this display2 function, right to left, how to traverse? Now this disp2 function, how to traverse right to left? Initially my P node started at a tile. I want to start at tile position. How to start off that tile? Tile means last node. At that time, P left pointer should be checking, while left pointer means previous node. P LPTR left pointer not equal to null. Whenever P left pointer not equal to null, what is the P of left pointer here? B. What is the B of left pointer? A. What is the A of left pointer? Null. There, stop. Now here P moving to here, again this is P, P left pointer, again this is P, P left pointer, null. There, stop. How to make of that? Printf percentage D elements. Now reverse to be print. P arrow elements. First P is at tile position, P element is 30, next P element is 20, next P element is 10, next P element there is no. P equal to P arrow LPTR, right to left travel. This is called as which direction to be travel the elements? Right to left. How to display the nodes? Right to left. Doubly linked list two-way direction can be traveled, two display functions. Singly linked list only one display function is there, left to right. But doubly linked list left to right, right to left. How to move on the left to right? P is nothing but one temporary node. P started at a head. If P of next not equal to null, moving on the next nodes. Wherever P is null, stop the process. If I want to travel the right to left, P is at a tile node, last node. P of left pointer is not equal to null, continue the process. Whenever P of left pointer is null, stop the process. That is for two display function operation, doubly linked list. Doubly linked list insertion at begin, end and middle. Deletion also begin at end at middle. And display function, two display functions you have, left to right, right to left. Doubly linked list, I want to work with length, that means how many nodes I have. I want to count of that nodes. How to count the nodes? Suppose in this list how many nodes are there? I want to count the nodes. What is my function? I used int, length, just our define, length function. What is the usage of length function here? Totally this linked list how many nodes? Length I want to return. Length of that. Initially I declared a count variable, count equal to 0. Initially count is 0, P equal to head, initially head I started. While P arrow RPTR, I mean right pointer, not equal to null. Whenever P of right pointer not equal to null, I want to increment with count plus count variable increments. Now here P equal to P arrow RPTR. Finally return. Finally which to be returned? Count value should be returned. Counts. Count means how many elements, how many nodes you have. Initially count is 0. P is at the first node position. Here P is at first node head. If the P of right pointer is null, no, continue. Count value becomes 1. Is it P is right pointer is null? No, continue. Count is 2. P is right pointer is null. I'll stop there. Count is 2. Totally here 0, 1, 2. Totally 3 will be displayed here. Count is initially 0, then reading time 1, then 2, then 3. Return count is 3. This function called as which function you have? Length function to be processed. In your doubly linked list, how many nodes are there? That should be returned. Now these are the doubly linked list operations. What is one more type of linked list? Circular linked list you have. Circular linked list. What is meant by circular linked list? First you have to create the doubly linked list. The doubly linked list can convert it to circular linked list. Doubly linked list first you be developed, that should be convert to the circular linked list. What is meant by circular linked list? Doubly linked list last node address pointing to the first node previous address. Doubly linked list last node right pointer, which is my last node, the last node right pointer should connect with first node left pointer. It is a circular chain. Once I connected to the circular linked list, there is no head node, there is no tail node. Singly linked list, you have one null pointer. Doubly linked list, you have two null pointers. First node left pointer null, last node right pointer null. But when you go for circular linked list, last node right pointer connected to the first node left pointer. At that time, what is the advantage? There is no null pointers. There is no nulls. And from that, any node to any node you can travel. There is no header, there is no tail. Any node to any node you can travel. It's a circular chain. But circular linked list directly cannot be created. First I want to create with a doubly linked list, that only connected to the circular linked list, converted to circular. You see that whenever you create the circular linked list also similar to doubly linked list. Circular linked list is also similar to doubly linked list. It's a circular chain. Here also three partitions, each node three partitions I have. Here also each node three partitions. Suppose I have this is A node, this is B node, this is C node. Now I want to discuss about circular linked list. Circular linked list initially doubly linked list. First I want to construct the doubly linked list. Now this is what 10, this is RPTR, right pointer, this is 20, this is LPTR, now this is RPTR, and for the C30, this is left pointer and right pointer is null. Now this is null, left pointer null. Actually it's a doubly linked list direction, doubly linked list traveling. This is the structure of doubly linked list. If I want to work with circular linked list, in this doubly linked list, which is the last node is C right pointer. What is the C right pointer? Null. Now this right pointer should connect with the first node previous pointer, I mean left pointer. What is the meaning of that? Last node right pointer should connect to the first node left pointer. Now here this link will be created. At that time there is no header, there is no tail. Now null is removed here. Now there is no null. You have all are valid pointers. Previously two null pointers. What is meant by null pointer? There is no value. There is no any address. You can't trace out any address. Valid pointer means something address. Previously there is two nulls, but circular linked list there is no nulls. Now here C node RPTR, that C node RPTR connected to the A node left pointer. At that time it's a circular manner. There is no header, there is no tail, it's a circular manner. What is the advantage of circular linked list? Any node to any node you can travel. Suppose I started at P from A. I started at P at A. P for first I started at A. At that time A can be travel, P of next. B can be travel, P of next. C can be travel. At that time A, B, C can be travel. If I start from the B to be read, suppose my P is at a B position, P is pointer, P point at B position, at that time B will be read, after that C will be read, come back to A also read, because C link will be A. If I start from A, B, C reading. If I start from B, B, C, A also reading, come back. If I start from C, this is P suppose, at that time which can be read, C, come back to A, come back to B. Wherever you started that, from that position to behind of that all nodes will be traveling. That is the advantage of which linked list? Circular linked list. It's a circular manner. Circular linked list, what is the points to be understand? Every circular linked list, initially it's a doubly linked list. Directly you can't create the circular linked list, initially doubly linked list. And the doubly linked list, right pointer connected to the first node, left pointer. doubly linked list last node right pointer should connect with first node left pointer. At that time there is no null pointers. All nodes are valid pointers. That is one advantage. One more advantage, any node to any node you can travel, A to C, B to A and C to A, B. Insertion also possible, deletion also possible, display also possible. These are the basic operations for circular linked list operation, similar to doubly linked list. Insertion, deletion, display. Two-way direction can be traveled. Now that is a complete implementation of linked list programs. Doubly linked list program implementation algorithm and singly linked list implementation algorithms and circular linked list implementation algorithm. Then tomorrow class I can continue for tree structure, data structure can be discussed. How to create the tree data structures. Then tomorrow session I can continue. Thank you for this video.
Hello everyone, welcome to Aptitude Foundation course presented by APSSTC. So in the yesterday's class we were discussing the calendars, am I right? I mean the shortcuts, I mean the codes for days, months and the century. Based on the codes, how to deal with the procedure. I mean let's start with just a recap. Let's see, let's see first thing, if oka particular date ichi manalni day ela find out cheyali ani cheppi check chesinappudu manam em chestam, we follow a particular procedure. What was that procedure? First initially we will check whether that particular year is leap year or not, am I right? First leap year kada anedi check chestam. Okavela leap year kaadu ante we will go with the procedure. Procedure is nothing but given date plus month code plus century code plus last two digits of the given year plus number of 4 multiples in the last two digits of the given year by 7 అనేది చేస్తాం. And then finally whatever the number we get, I mean whatever the fraction we get, we will divide it, we will do the division. Cancellation చేయదని చెప్పాను, we will do the division and finally we will find out the remainder. For example 12 by 7 అనేది మనకు వచ్చిందంటే 5 అనేది అక్కడ రిమైండర్ గా యాక్ట్ అవుతుంది. ఆ 5 అనేది మనం డే కి మనం ఈక్వేట్ చేసి ఏ పర్టికులర్ డే వస్తుందని చెక్ చేస్తాం. అండ్ దెన్ లెట్స్ సే ఇఫ్ ఇట్స్ అ లీప్ ఇయర్, లీప్ ఇయర్ అయితే ఏం చేయాలనేది నేను మీకు 2 కేసెస్ ఇచ్చాను. ఫస్ట్ థింగ్ లెట్స్ సే 2000 అనే ఇయర్ వచ్చింది. ఫర్ ఎగ్జాంపుల్ ఒక పర్టికులర్ డేట్ అనేది ఏంటి అనేది కాసేపు పక్కన పెడితే ఇయర్ అనేది 2000 వచ్చిందంటే సో లీప్ ఇయర్ కాదా, సెంచురీ ఇయర్ ఎండింగ్ అంటే సెంచురీ ఇయర్ అంటే ఎలా చెక్ చేస్తాం మనం, 00 ఎండింగ్ అంటే ఎలా చెక్ చేస్తాం, 400తో డివిజిబుల్ అయిందా లేదా అనేది చెక్ చేస్తాం. ఇదే నార్మల్ ఇయర్ వచ్చింది, లెట్స్ సే 1964 అనే ఇయర్ ఉంది, సెంచురీ ఇయర్ కాకుండా 1964. దీనికి లీప్ ఇయర్ మనం కండిషన్ ఎలా చెక్ చేస్తామంటే లాస్ట్ 2 డిజిట్స్ తీసి జస్ట్ 4తో డివిజిబుల్ లేదా చెక్ చేస్తాం. 64 4తో డివిజిబుల్ అయితే లీప్ ఇయర్, కాకపోతే నాట్ ఎ లీప్ ఇయర్. బట్ సెంచురీ ఎండింగ్ ఇయర్ అయితే we will definitely cross check with 400. For example year 1700 అనేది సెంచురీ ఇయర్, ఎందుకంటే 00తో ఎండ్ అవుతుంది. 1700 అనేది మనం 4తో చెక్ చేయకూడదు, లీప్ ఇయర్ కండిషన్ కోసం మనం 400తో చెక్ చేయాలి. 400తో చెక్ చేస్తే లెట్స్ సే అండ్ దెన్ చెక్ చేసిన తర్వాత లీప్ ఇయర్ అయినప్పుడు వాట్ టు డూ? సో సింపుల్, వీ నీడ్ టు చెక్ ద డేట్ అండ్ మంత్. 1st January నుండి February 29th దాకా మనకు డేట్ ఉంటే వీ హ్యావ్ టు డూ ఫైనల్ రిమైండర్లో వీ నీడ్ టు డూ -1. అండ్ దెన్ March 1st నుండి December 31st ఉండిందంటే నో నీడ్ టు డూ ఎనీథింగ్, జస్ట్ గో హెడ్ యాజ్ ఇట్ ఈస్. సో దిస్ వాస్ ద ప్రొసీజర్ వీ వర్ డిస్కసింగ్ ఎస్టర్డే. నౌ ఐఎమ్ గోయింగ్ టు సాల్వ్ సర్టెన్ ప్రాబ్లమ్స్ అండ్ క్యాలెండర్స్. ఎస్టర్డే బేసిక్స్ మాత్రమే చూసాం, ఈ రోజు ఇన్ డెప్త్గా ప్రాబ్లమ్స్ ఎలా సాల్వ్ చేయాలి క్యాలెండర్స్తో అండ్ డేట్ అండ్ డే కాకుండా ఇంకా ఎటువంటి ప్రాబ్లమ్స్ ఇస్తారు ఎగ్జామినేషన్లో అనేది మనం చెక్ చేద్దాం. లెట్స్ సీ ద ఫస్ట్ క్వశ్చన్. If you see the first question, which among the following year is a leap year? I repeat, which among the following year is a leap year? So దీంట్లో లీప్ ఇయర్ ఏది అనేది మనం చెక్ చేయాలి. సో ఇక్కడ చూసినట్లయితే ఫస్ట్ చూడండి, ఫస్ట్ ఆప్షన్ ఇట్ ఇస్ 2600. సో 2600ని మీరు 400తో డివైడ్ చేయాల్సి ఉంటుంది. లెట్స్ సీ హౌ దిస్ వర్క్స్. హియర్ ఇట్ ఇస్ 2600. సో 2600ని మీరు 400తో డివైడ్ చేయండి. సో ఇట్స్ సెంచురీ ఇయర్స్. అండర్స్టాండ్, ఈ ఆప్షన్స్లో అన్ని సెంచురీ ఇయర్సే. సో సెంచురీ ఇయర్స్ కాబట్టి సెంచురీ ఇయర్స్ అండ్ 00 ఎండింగ్ 2600, 2700, 2800 అండ్ దెన్ ఇఫ్ యూ సీ what is that, 3000 and then 3400 years icharu. So then please don't use 4, use 400. If you use 400, this is obviously 406 into 2400 is probably it's 200. So this is not a leap year. So 400 తో డివైడ్ చేసినప్పుడు మనకు రిమైండర్ 0 వచ్చినప్పుడు మాత్రమే అది లీప్ ఇయర్ అవుతుంది. బట్ హియర్ ఇట్ ఇస్ 200 రిమైండర్, ఇట్ ఇస్ నాట్ అ లీప్ ఇయర్. నౌ లెట్స్ సీ వాట్ ఇస్ సెకండ్ ఆప్షన్ విచ్ ఇస్ 2700. మీరు క్వశ్చన్ ని చూసినట్లయితే నెక్స్ట్ ఆప్షన్ మనకి 2700 ఉంది. 2700 ని 400 తో డివైడ్ చేసినప్పుడు ఆబ్వియస్లీ 4 టేబుల్ సేమ్ హియర్ 6 2400 and probably it's like 300. Once again, this is not a leap year. Here, instead of getting the remainder as 0, we are getting remainder as 300, which is not a leap year. Now, let's see the third option, which is 2800. Am I right? Third option is 2800. So, దీని మనం 400 తో చెక్ చేసినప్పుడు ఏమవుతుంది? Let's see, 4 7s are 4 7s, it is 400 into 7 is like 2800. 0 exactly. This is the leap year. 2800 అనేది leap year అవుతుంది. And then let's see, I mean, థర్డ్ ఆబ్వియస్లీ ఆన్సర్ ఇదే, బట్ స్టిల్ మీరు ఇంకొక 2 ఆప్షన్స్ కూడా చెక్ చేసుకోవాలి అన్నప్పుడైతే నెక్స్ట్ చూసారంటే 3000 ఇయర్ 3000 and 400. సో ప్రాబబ్లీ 4 7s 2800 and the remainder 200. So remainder 200, it is not a leap year. Now let's see the last one, which is 3400. So ఈ 3400 ని మీరు 400 తో డివైడ్ చేసినట్లయితే which is 8 times 3200. So probably 0. Sorry, it is 200. It is not a leap year. So simple. ఇది మీకు అర్థం కావడానికి నేను ఇలాంటి డివిజన్స్ చేస్తున్నాను. 400 మల్టిపుల్స్ అన్ని లీప్ ఇయర్సే, అంటే 4 మల్టిపుల్స్ అన్ని లీప్ ఇయర్సే. ఐ మీన్ సెంచురీ ఇయర్స్ అప్పుడు 400 మల్టిపుల్స్ అవ్వాలి. సో విచ్ ఇస్ నథింగ్ బట్ 400, 800 and then 1200, 1600, 2000, 2400, 2800, 3200, 3600 ఇలా వెళ్తుంటుంది. 400 టేబుల్లో లీప్ ఇయర్స్ అనేది వెళ్తుంటుంది సెంచురీ ఇయర్స్ కాబట్టి. సో హియర్ యాజ్ పర్ దిస్ క్వశ్చన్ ది ఆన్సర్ ఇస్ 2800. ఇయర్ 2800 అనేది లీప్ ఇయర్, రెస్ట్ ఆఫ్ ఆల్ నాట్ అ లీప్ ఇయర్. లెట్స్ సీ ద నెక్స్ట్ క్వశ్చన్ and see on what dates of March 2004 did Thursday fall. I repeat, on what dates of March 2004 did Thursdays fall. అంటే 2004 మార్చ్లో థర్స్డేస్ అన్ని ఏ డేట్స్లో వస్తున్నాయి? I repeat, 2004 మార్చ్లో థర్స్డేస్ అని ఏ డేట్స్లో వస్తున్నాయి? నా ఇఫ్ యూ ఆస్క్ మీ హౌ టు ఫైండ్ అవుట్ దిస్, వెరీ సింపుల్. డైరెక్ట్గా థర్స్డే ఏంటి అనేది మనం చెక్ చేయడం అనేది నాట్ పాసిబుల్. సో బాగా అర్థం చేసుకోండి. మార్చ్ 2004లో థర్స్డేస్ ఏ డేట్స్లో ఉన్నాయి అంటున్నారు. సో ఇది ఒక థర్స్డేనా అంటే నో, వీ నీడ్ టు ఫైండ్ అవుట్ ఆల్ ద థర్స్డేస్. సో మినిమం అని చూసారంటే 4 థర్స్డేస్ ఉండొచ్చు, మాక్సిమం అని చూసారంటే 5 థర్స్డేస్ ఉండొచ్చు. దర్ ఇస్ నో పాసిబిలిటీ దట్ యూ కెన్ గెట్ లెస్ దెన్ 4 థర్స్డేస్ ఆర్ మోర్ దాన్ 5 థర్స్డేస్. సో 4 అనేది మినిమం, 5 అనేది మాక్సిమం. సో ఆ పర్టికులర్ థర్స్డేస్ అన్ని ఏ డేట్లో వస్తున్నాయి అనేది మనం చెక్ చేయాలి. సో ఫస్ట్ థర్స్డే మనకి ఎప్పుడు వస్తుందని తెలిస్తే ఆటోమేటిక్గా మిగతా థర్స్డేస్ అనేది మనం ఫైండ్ అవుట్ చేయొచ్చు. అది ఎలా చేయాలి? సో సింపుల్. ఫస్ట్ లెట్స్ ఫైండ్ అవుట్ ఫస్ట్ మార్చ్ 2004 ఏ పర్టికులర్ డేలో వస్తుందని చెక్ చేద్దాం. ఐ మీన్ వాట్ వాస్ ద డే ఆన్ ఫస్ట్ మార్చ్ 2004. బేస్డ్ ఆన్ దిస్ వి షల్ క్యాల్కులేట్ అకార్డింగ్లీ. ఆల్రైట్. సో ఫస్ట్ మార్చ్ 2004 అనేది ఎలా మీరు చెక్ చేయాల్సిందంటే ఫస్ట్ థింగ్ ద ప్రొసీజర్ విచ్ వీ నీడ్ టు ఫైండ్ అవుట్ గివెన్ డేట్ ఇస్ 01 ప్లస్ మంత్ కోడ్. సి మేము ఆల్రెడీ మీకు మంత్స్కి కోడ్స్ ఇచ్చాను విచ్ ఇస్ 033 614 625. I mean 035. These are the month codes to the corresponding months. అవునా? సో ఇప్పుడు ఇందులో మీరు చూసినట్లయితే మార్చ్ అనేది 3rd month. సో మార్చ్ కోడ్ ఏంటంటే 03. am I right? And then plus century code. సో century code we know clearly 1900 నుండి 1999కి it is 0. And then 2000 నుండి 2099కి కోడ్ ఏంటి అని చూసారు అంటే 0642 if you remember. So obviously it is 6. ప్లస్ లాస్ట్ 2 digits ఆఫ్ ద గివెన్ ఇయర్. లాస్ట్ 2 digits ఆఫ్ ద గివెన్ ఇయర్ ఏంటి ఇక్కడ? 04. అండ్ నెంబర్ ఆఫ్ 4 మల్టిపుల్స్ ఎన్ని ఉన్నాయి అంటే దీంట్లో ఒకటి ఉంది. రైట్? బై 7. అండ్ చెక్. సి రిమెంబర్ దిస్ ఇస్ ఇది సాల్వ్ చేసే ముందు మీరు అండర్స్టాండ్ చేసుకోవాల్సింది ఏంటంటే 2004 లీప్ ఇయరా కాదా అనేది మీరు చెక్ చేయాల్సి ఉంటుంది. 2004 ఇస్ అ లీప్ ఇయర్. ఎందుకంటే సి ఇట్స్ అ 4, ఇట్ ఇస్ యాక్చువల్లీ డివిజిబుల్ బై 4. అవునా? సో 2000 అనేది లీప్ ఇయర్, 2004 కూడా లీప్ ఇయర్. సో ఇట్స్ అ లీప్ ఇయర్ కండిషన్. ఇది సాల్వ్ చేసే ముందు ఫస్ట్ మీరు లీప్ ఇయర్ కండిషన్ ఒకసారి చెక్ చేసుకోండి. సో 2004 ఇస్ అ లీప్ ఇయర్. బట్ దీంట్లో వన్స్ మీరు లీప్ ఇయరా కాదా అనేది కన్ఫర్మ్ చేసిన తర్వాత లీప్ ఇయర్ అయింది కాబట్టి యూ నీడ్ టు చెక్ ఇది Jan 1st నుండి February 29th లోపల ఉన్న డేట్ ఉందా, లేదు March 1st నుండి December 31st లో ఉన్న డేట్ ఉందా అని చెప్పి. సో దిస్ ఇస్ ఇన్ ద సెకండ్ స్లాట్. అంటే March 1st నుండి December 31st లో ఉన్న సెకండ్ స్లాట్లో ఉంది. సెకండ్ స్లాట్లో ఉంది కాబట్టి నో నీడ్ టు డూ -1, యూ కెన్ గో హెడ్ యాజ్ ఇట్ ఈస్. -1 దీనికి చేయాల్సిన అవసరం లేదు. ఇది సెకండ్ స్లాట్లో ఉంది. జస్ట్ యాడ్ ఎవ్రీథింగ్ అండ్ జస్ట్ లైక్ డూ ద డివిజన్ పార్ట్. నా ఇఫ్ యూ సీ ఇట్ ఈస్ 1, 3 which is 1 plus 3 it is 4, 4 plus 6 it is 10, 14, 15. Am I right? 15 by 7. Let's cross check it once again. 1 plus it is 4, 1 plus 3 4, 4 plus 6 10, 10 plus 4 it is 14 and 1 15. 15 by 7 and 15 by 7 if you do the division, so 1 is going to be the remainder. Understand? 1 is going to be the remainder. So 1 remainder ante idi 8 day avutundi. We know that Monday, 1 stands for Monday, 2 is for Tuesday, 3 is for Wednesday, 4 is for Thursday, 5 is for Friday, and then Saturday 6, Sunday it's not 7, it is 0. In such case here remainder anedi 1. So 1 ante manaki 8 day equate avutundi, Monday avutundi. And try to understand, ఇది March 1st నుండి December 31st slot లో ఉంది కాబట్టి no need to do -1, just leave as it is, hence the answer is Monday. Alright, so from this what I can understand is 1st March అనేది చూసినట్టయితే 1st March, first day of the month అంటే day 1 ఏంటి అని వస్తే చెక్ చేసుకోండి. day 1 అనేది మండేగా ఉంది. ఓకే, day 1 మండే అండ్ దెన్ జస్ట్ చెక్ day 2 ట్యూస్డే. మనకేం కావాలి? థర్స్డే. అన్ని థర్స్డేస్ 8 డేట్లో వస్తుందని చెప్పి. సో day 3 అంటే March 3rd అని మీనింగ్. సో March 1st, March 2nd, March 3rd. March 3rd ఎప్పుడు వస్తుంది మీకు? Wednesday వస్తుంది. సో day 4 అంటే March 4th. March 4th ఎప్పుడు మీకు వస్తుంది? Thursday వస్తుంది. ఫ్యాంటాస్టిక్. నా day 4 అనేది థర్స్డే వచ్చింది అంటే, సో ట్రై టు అండర్స్టాండ్, ఐ మీన్ 4th day of that month. ఇన్ ద సెన్స్ 4th March అనేది మీకు థర్స్డే అవుతుంది. I repeat, 4th March and this Thursday. Alright, so from this, I'm going to erase this. I hope you know how to calculate this. This is very easy. Now, try to understand. Ante 4th March మీకు చూసినట్లయితే it is Thursday. So, next Thursday ఎప్పుడు వస్తుంది అనేది మన క్వశ్చన్. It is so simple. So, ఈ రోజు తర్వాత ఈ రోజు నుండి 7 days తర్వాత అదే రిపీట్ అవుతుంది, సేమ్ డే రిపీట్ అవుతుంది. ఫర్ ఎగ్జాంపుల్ day 1 మండే అంటే day 1కి +7 మీరు చేసినట్టయితే ఏమవుతుంది? 8 అవుతుంది. 8 కూడా మళ్ళీ మండేనే వస్తుంది. ద సేమ్ థింగ్ ఇప్పుడు 4 ఫర్ ఎగ్జాంపుల్ day 1 మండే అయినప్పుడు day 8 మళ్ళీ మండే. దానికి +7 చేస్తే day 15 వస్తుంది. day 15 కూడా మండే. +7 చేస్తే day 22 మండే అంటే 22nd March మండే. అండ్ దెన్ +7 29 అంటే 29th కూడా మండే. బట్ మనకి ఇక్కడ కావాల్సిన ఏంటి? థర్స్డేస్ ఎప్పుడు కావాలి? సో ఫస్ట్ థింగ్ 4th March అనేది థర్స్డే. ఫ్యాంటాస్టిక్. సో ఇప్పుడు దీన్ని మీరు ఏం చేస్తారంటే +7 యాడ్ చేశారంటే నెక్స్ట్ చూడండి, ఇట్ ఇస్ సో సింపుల్, 11th March. సో 4 March, సో 11 March కూడా ఏమొస్తుంది? థర్స్డేనే వస్తుంది. సో దీనికి +7 చేసినట్లయితే మీకు ఏమొస్తుంది? 18 March కూడా థర్స్డేనే వస్తుంది. అండ్ దెన్ దీనికి +7 చేసినట్లయితే మీకు ఏమొస్తుంది? 25 March. 25 March కూడా థర్స్డే. ఆల్రైట్, సో ఫ్రమ్ దిస్ వాట్ ఐ కెన్ సే 4, 11, 18, 25. సో 25 ప్లస్ 25 మాది 18, 25. సో 4th, 11th, 18th, 25th. ఈ తర్వాత +7 చేయదు. +7 చేస్తే 32 వెళ్ళిపోతుంది. సో మన మాక్సిమం నెంబర్ ఆఫ్ డేస్ ఇన్ అ మంత్ ఇస్ ఓన్లీ 31 days. మార్చ్లో 31 డేసే ఉంది. డోంట్ యాడ్ 7 దేర్. సో 4, 11, 18th, 25th ఆఫ్ దట్ పర్టికులర్ మంత్ ఇస్ థర్స్డేస్. థర్స్డేస్ ఏ మంత్స్లో వచ్చాయి? 4th, 11th, 18th, 25th. ఈ పర్టికులర్ 4 డేట్స్ అనేది మీకు థర్స్డేస్గా ఉంటుంది మార్చ్లో. ఆల్రైట్, లెట్స్ సీ ద నెక్స్ట్ క్వశ్చన్. నెక్స్ట్ క్వశ్చన్ మీరు చూసినట్టయితే ద లాస్ట్ డే ఆఫ్ ద సెంచురీ కెనాట్ బి అన్నాడు. సో లాస్ట్ డే ఆఫ్ ద సెంచురీ కెనాట్ బి. సి దీనికి ఒక డైరెక్ట్గా నేను మీకు ఆన్సర్ చెప్పొచ్చు, ట్యూస్డే, థర్స్డే, సాటర్డే అని చెప్పి. బట్ ఐ డోంట్ వాంట్ టు టెల్ ఇన్ సచ్ ఏ వే. ఐ నీడ్ టు టెల్ యూ హౌ దిస్ వర్క్స్. అంటే సెంచురీ, ద లాస్ట్ డే ఆఫ్ ద సెంచురీ ఏంటంటే ప్రతి 100 yearsకి లాస్ట్ ఇయర్ ఫర్ ఎగ్జాంపుల్ సెంచురీ అంటే 100 years కదా. ఆ లాస్ట్ డే అనేది 31st December ఆఫ్ దట్ పర్టికులర్ సెంచురీ. లాస్ట్ డే ఆఫ్ ద సెంచురీ కెనాట్ బి. ఒక పర్టికులర్ రూల్ని ఫాలో అవుతుంది. అది ఎలా చెక్ చేయాలి? ఫర్ ఎగ్జాంపుల్ మనం ర్యాండమ్గా ఒక 4 dates తీసుకొని దాన్ని సాల్వ్ చేసినప్పుడు we will get to know what are the dates we get. Let's see how this works. నేను లాస్ట్ డే ఆఫ్ ద సెంచురీ అన్నాడు కాబట్టి నేను మీకు 4 different dates ఎగ్జామ్లో మీరు చేయాల్సిన అవసరం లేదు. దీని యొక్క సొల్యూషన్ నేను మీకు చెప్తాను, మీరు అది డైరెక్ట్గా నోట్ చేసుకుని ఆన్సర్ చేసేయచ్చు. జస్ట్ బికాస్ ఫ్రీక్వెంట్లీ యాస్ క్వశ్చన్ ఇది మీరు అర్థం చేసుకోవడానికి మాత్రమే నేను ప్రూవ్ చేసి చూపెడతాను. ఎగ్జామ్లో ప్లీజ్ డోంట్ డూ ఆల్ దిస్ క్యాల్కులేషన్. యూ కెన్ డైరెక్ట్లీ హిట్ ద ఆన్సర్. ఆల్ రైట్, నౌ లెట్స్ సే సో లాస్ట్ డే ఆఫ్ ద సెంచురీస్ కాబట్టి 31st December. Let's talk about 1999. Alright, 31st December 1999. All right, century అన్నాడు కాబట్టి లెట్స్ టాక్ అబౌట్ సెంచురీ అంటే ఒక 100 yearsకి. సో ఇన్ సచ్ కేస్ మనకేం చేద్దాం, లెట్స్ టాక్ అబౌట్ 2000. Let's talk about 31st December 2000, last day of the century. Am I right? Or then మీరు చూసినట్లయితే last day December, and then let's talk about 2100. All right, and then 31st December 2200, and then here let's talk about December 1900. సో ఇవన్నీ చూసారంటే లాస్ట్ డే ఆఫ్ దట్ సెంచురీ ఇయర్స్ కదా ఇవన్నీ 1900, 2000, 2100, 2200. సో ఇవి మనం సాల్వ్ చేసి ఏ పర్టికులర్ ఇయర్లో ఏ పర్టికులర్ డేస్లో వస్తుందని మనం చెక్ చేసినట్లయితే ఇట్ ఈస్ ఈజీ ఫర్ us టు గెట్ ద ఆన్సర్. లెట్స్ సీ హౌ దిస్ వర్క్స్. ఫస్ట్ డేట్ మనం సాల్వ్ చేద్దాం. సో December 31st, 1900 అనేది మనం చూసినట్లయితే లెట్స్ సాల్వ్. సో సెంచురీ కోర్స్ మనకు క్లియర్గా తెలుసు. ఇట్ ఈస్ 1900 to 1999, answer is 0. We all know this. 1900 to 1999, the code is 0. ఈ పర్టికులర్ కోడ్ యూస్ చేసి మనం సాల్వ్ చేయబోతున్నాం. నా గివెన్ డేట్ ఫస్ట్ ఇది లీప్ ఇయరా కాదా అనేది మీరు చెక్ చేసుకోవాల్సి ఉంటుంది. సో 1900 అనేది సెంచురీ ఇయర్ 400 మల్టిపుల్ కాదు. సో మీరు వరీ అవ్వాల్సిన అవసరం లేదు. 2000 అని ఫస్ట్ 400 మల్టిపుల్ సెంచురీ ఇయర్స్లో మీరు చూసినట్టయితే 400, దెన్ 800, దెన్ 1200, అండ్ దెన్ 1600, అండ్ దెన్ 2000. సో ఆబ్వియస్లీ 1900 అనేది లీప్ ఇయర్ కింద రాదు. ఈవెన్ దో ఇట్ ఇస్ డివిజిబుల్ బై 4, ఇట్ ఇస్ నాట్ డివిజిబుల్ బై 400, హెన్స్ ఇట్స్ నాట్ ఎ లీప్ ఇయర్. సో ఇన్ సచ్ కేస్ వీ కెన్ ప్రొసీడ్ డైరెక్ట్లీ. నా గివెన్ డేట్ మనం తీసుకున్నట్లయితే 31 ప్లస్ మంత్ కోడ్. సో డిసెంబర్ యొక్క కోడ్ మీకు తెలుసు, ఇట్స్ లైక్ 033624625 అంటే లాస్ట్ డిసెంబర్లో మంత్ కోడ్ ఏమొస్తుంది, ఇట్స్ 5 ప్లస్ నెక్స్ట్ చూసినట్టే సెంచురీ కోడ్ ఇక్కడ ఏంటి 0 ప్లస్ లాస్ట్ 2 digits ఆఫ్ ద గివెన్ ఇయర్ 00 ప్లస్ అండ్ దెన్ మనం చూసినట్లయితే నెంబర్ ఆఫ్ 4 మల్టిపుల్స్ 00లో మల్టిపుల్స్ ఉండవు. సో ఇట్ ఇస్ ఆబ్వియస్లీ 00/7. ఫెంటాస్టిక్. నా 0 0 0 3 digits చూసినట్లయితే 3 పారామీటర్స్ అన్ని 0 అయింది. సో 31 + 6 ఆబ్వియస్లీ 36/7. ఆల్రైట్, 36/7 ఏమవుతుంది, 7 5s 35. సో ఇట్ ఈస్ ఆబ్వియస్లీ రిమైండర్ అనేది ఇక్కడ 1 అవుతుంది. am I right? రిమైండర్ అనేది ఇక్కడ 1, విచ్ ఇస్ నథింగ్ బట్ మండే. రిమైండర్ 1 అంటే మండే. సో 7 5s 35, దెన్ ద రిమైండర్ ఇస్ 1 is Monday. సో ఫ్రమ్ దిస్ వాట్ ఐ కెన్ సే 31st నేను మీకు సైడ్లో రాస్తాను. 31st December 1990 అనేది మేము చూసినట్లయితే ఇట్ ఈస్ మండే. జస్ట్ ఏమని రాస్తున్నాను ఫర్ యువర్ రెఫరెన్స్, ఇట్ ఈస్ మండే. ఆల్ రైట్, నా లెట్స్ టాక్ అబౌట్ 31st December 2000 ఏమవుతుంది అనేది ఒకసారి చెక్ చేద్దాం. 31st December 2000. ఓకే, 31st December 2000 ఏమవుతుంది ఒకసారి చెక్ చేసినట్లయితే ఫెంటాస్టిక్. ఆల్ రైట్, నా సో 2000 అనేది మీరు చూసినట్లయితే ఇట్స్ అ లీప్ ఇయర్, 400 డివిజిబుల్. బట్ 31st Decemberలో ఉంది కాబట్టి ఇది సెకండ్ స్లాట్లో ఉంది. March 1st నుండి December 31st వరకు సెకండ్ స్లాట్, అంటే మీరు -1 చేయాల్సిన అవసరం లేదు. యూ కెన్ ప్రొసీడ్. లీప్ ఇయర్ అయినా ఏం చేంజెస్ లేదు, జస్ట్ ప్రొసీడ్ అకార్డింగ్లీ. సో ఫస్ట్ థింగ్ డేట్ ఏంటి, గివెన్ డేట్ ఇట్ ఇస్ 31 ప్లస్ మనం చూసినట్లయితే మంత్ కోడ్, డిసెంబర్ మంత్ కోడ్ ఏమవుతుంది 05, నో చేంజెస్ అట్ ఆల్, ప్లస్ సెంచురీ కోడ్. ఎస్, సెంచురీ కోడ్ ఇక్కడ మీరు చూసినట్లయితే 2000 నుండి 2099 దాకా మనకు సెంచురీ కోడ్ ఏమవుతుంది 06 అవుతుంది. ఆల్రైట్, 6. సో ఇట్స్ గోయింగ్ టు బి 6 ప్లస్ లాస్ట్ 2 digits ఆఫ్ ద గివెన్ ఇయర్ ఇట్ ఇస్ 00 ప్లస్ దీంట్లో 4 మల్టిపుల్స్ ఏంటి 00, నో టెన్షన్, బై 7. నా ఇప్పుడు మీరు చూసినట్లయితే 31 5 ఎంతంటే 36. 36 + 6 ఏమవుతుంది, 36 + 6 మీరు చూసినట్లయితే ఇట్ ఇస్ 42. సో 42/7. సో ఇప్పుడు రిమైండర్ మీకు ఏమవుతుంది 0 అవుతుంది. అవునా, 7 6 42, రిమైండర్ 0. సో 0 అనేది రిమైండర్ అంటే మనకి ఏ పర్టికులర్ డే వస్తుంది, సండే వస్తుంది. సో 31st December 2000 మీరు చూసినట్లయితే ఇట్ ఈస్ గోయింగ్ టు బి సండే. 31st December 2000 ఇస్ గోయింగ్ టు బి సండే. ఆల్ రైట్, నెక్స్ట్ మనం చూసినట్లయితే సో 31st December 2100 అనేది మనం చెక్ చేయాల్సి ఉంటుంది. 31st December 2100 అనేది చెక్ చేయాల్సి ఉంటుంది. సో దాన్ని మనం చెక్ చేస్తే లెట్స్ సి జస్ట్ ఇయర్ చేంజ్ ఇయర్ కోడ్ కూడా చేంజ్ అవుతుంది దాంతోపాటు. సో ఇక్కడ ఏంటంటే 31st December 2100. 31st December 2100. Fantastic. Now year it is 31. Year it is 31. Given date is 31, and then plus, so what is that, month code, which is 5 plus century code. So 20th century code ఏమవుతుంది 04. Am I right? 064 1900 to 1990 2000 2996 and then next చూసారంటే 4 అవుతుంది ప్లస్ లాస్ట్ 2 digits 00. ఈ 00లో 4 మల్టిపుల్స్ ఉంటాయా? ఉండవు. సో నో ప్రాబ్లం. సో ఆబ్వియస్లీ బై 7. ఆల్రైట్, నా నెక్స్ట్ మీరు చెక్ చేసినట్లయితే జస్ట్ దీన్ని యాడ్ చేసి మీరు డివిజన్ చేయండి. సో యాడ్ చేసి డివిజన్ చేస్తే ఏమవుతుంది 31 plus 5 36 40. సో 40 by 7. సో 40 by 7. సో అంతే కదా, 31 plus 5 36 plus 4 40 by 7. Now 40 by 7 మీరు డివిజన్ చేసినట్లయితే ఏమైతుంది, you will get 5. Am I right? So 7 5s are 35 and the remainder is 5. So 5 obviously the remainder. And 5 remainder అయితే 5 ఏం డే అవుతుంది మీరు చెక్ చేసినట్లయితే 5 is obviously Monday 1, Tuesday 2, Wednesday 3, Thursday 4 and 5 is Friday. 5 is Friday. So 31st December 2100 లాస్ట్ డే ఆఫ్ దట్ పర్టికులర్ సెంచురీ, 100 years కి లాస్ట్ డే ఏమవుతుంది, ఫ్రైడే అవుతుంది. 31st December 1990 మండే, 31st December 2000 సండే, 31st December 2100 ఫ్రైడే. సో ఇప్పుడు మనకి ఇంకా ఒక్క డేట్ మాత్రమే మిగిలింది. ఆ డేట్ ఏంటి అంటే 31st December 2200 అనేది మనం చెక్ చేయాలి. 31st December 2200 ఏం డే వస్తుంది చెక్ చేసినట్లయితే విల్ గెట్ అ క్లియర్ పిక్చర్ లాస్ట్ డే. ఆల్రైట్, నౌ లాస్ట్ డే విచ్ ఇస్ నథింగ్ బట్ 31st December 2200 ఏమవుతుంది, గివెన్ డేట్ ఫస్ట్ నోట్ చేసిన 31 ప్లస్ మంత్ కోడ్ ఇస్ 5 ప్లస్ సెంచరీ కోడ్ ఇక్కడ ఏమవుతుంది 2 అవుతుంది ప్లస్ లాస్ట్ 2 digits 00. ఈ 2 digits లో ఉన్న 4 multiples 00 by 7. Am I right? సో డైరెక్ట్ క్యాలిక్యులేషన్ ఇది. సో 31 plus 5 36 38 అవుతుంది. సో 38 by 7 whereas the remainder is 3. అవునా, రిమైండర్ అనేది 3 అవుతుంది. సో 3 అంటే వెన్స్డే. సో 31st December 2200 is Wednesday. 31st December 2200 is Wednesday. Now నెక్స్ట్ చూసినట్లయితే మీరు మండే, సాటర్డే, ఫ్రైడే, వెన్స్డే 4 పర్టికులర్ డేట్స్ చూసాము. ఇంకొక డేట్ మనం చూసినట్లయితే వీ విల్ గెట్ అ క్లియర్ పిక్చర్ ఆన్ వాట్స్ గోయింగ్ ఆన్. ఆల్ రైట్, నెక్స్ట్ మీ అండర్స్టాండింగ్ కోసం ఇంకొక డేట్ నేను మీకు సాల్వ్ చేసి చూపిస్తాను. సేమ్ థింగ్ 31st December పాటు 2200 కంప్లీట్ అయింది కాబట్టి ఐఎమ్ జస్ట్ గోయింగ్ టు టేక్ 2300 నౌ. సో 31st December 2300. సో 2300 ఎలా ఉంటుంది, సేమ్ థింగ్. సో ఫస్ట్ 0642 అవునా, ఇలా వచ్చింది. మళ్ళీ నెక్స్ట్ ఇయర్ కోడ్ ఏమవుతుంది, మళ్ళీ 0తో స్టార్ట్ అవుతుంది. నేను మీకు చెప్పాను ఆ రోజు ఐటరేషన్ 20th సెంచరీకి 0, 21st సెంచరీకి 6, ఆ తర్వాత 4, ఆ తర్వాత 2, మళ్ళీ నెక్స్ట్ 24th సెంచరీ వచ్చేసరికి 0 వచ్చేస్తుంది. ఇన్ సచ్ కేస్ నౌ లెట్స్ సీ ఇయర్ కోడ్ హియర్ ఇట్ ఇస్ ఫస్ట్ గివెన్ డేట్ ప్లస్ month code 05 and the century code, obviously year code కాదు, century code. So century code is 00 plus and then last 2 digits 00 and then దీంట్లో ఈ పర్టికులర్ లాస్ట్ 2 digits లో 4 multiples ఎన్ని చూసారంటే 00 by 7. Now it is once again ఈ క్యాలిక్యులేషన్ మీరు చెక్ చేసినట్టయితే 31 plus 5 36 and all zeros. So 36 by 7 which is nothing but 7 5s are 35 and 1 remainder. So 1 remainder అన్నప్పుడు మీకు ఏమవుతుంది 31st December 2300 అని చేసేసరికి మళ్ళీ మండే వచ్చేస్తుంది. ఐ హోప్ యూ అండర్స్టాండ్ హౌ దిస్ వర్క్స్. సో 31st December 1990 మండే, 31st December 2000 సండే, 31st December 2100 ఫ్రైడే, 31st December 2200 వెన్స్డే, 31st December 2300 వచ్చేసరికి ఎలా ఈ 0642 ఈ పర్టికులర్ 0642 ఎలా మీకు రిపీట్ అవుతూ వస్తున్నాయో ఇక్కడ కూడా అదేలాగే ఈ మండే, సాటర్డే, ఫ్రైడే, వెన్స్డే అనేది కూడా రిపీట్ అవుతూనే వస్తుంటుంది. ఆల్రైట్, సో ఇందులో మీకు లాస్ట్ డే అంటే 31st December ఆఫ్ దట్ పర్టికులర్ సెంచురీ, నాట్ డెకేడ్, 100 years. సో ఇందులో మీరు అండర్స్టాండ్ చేసుకోవాల్సిందంటే మండే, రిమెంబర్ మండే, సండే, ఫ్రైడే, వెన్స్డే అనేది లాస్ట్ డే రిపీట్ అవుతూనే ఉంటుంది ఒక పర్టికులర్ ఆర్డర్లో. ఆల్రైట్, ఇన్ సచ్ కేస్ మీకు రిపీట్ దీంట్లో లాస్ట్ డే ఆఫ్ దట్ సెంచురీ రానివి ఏవి అని చూస్తుంటే మిస్సింగ్ చూడండి. ట్యూస్డే నో వీఆర్ నాట్ గెటింగ్, and then Thursday we are not getting, and then Saturday we are not getting. So from this I can say the last day of the century year cannot be a Tuesday, cannot be a Thursday and cannot be a Saturday. So ఇది మీరు డైరెక్ట్ గా గుర్తుపెట్టుకోవాల్సింది. ఈ పర్టికులర్ క్యాల్కులేషన్ అనేది ఎగ్జామ్లో మీరు చేస్తే మీకు టైం సరిపోదు. ఇది జస్ట్ మీకు అండర్స్టాండింగ్ కోసమే చేసి చూపెట్టాను. మీకు కావాలి అంటే 31st December 2400, 31st December 2500 మీరు చేస్తూ రావచ్చు. ఇదే ఈ లూప్ మీకు మండే, సాటర్డే, ఫ్రైడే, వెన్స్డే అనేది రిపీట్ అవుతూనే ఉంటుంది తప్ప అట్ ఎనీ కాస్ట్ లాస్ట్ డే ఆఫ్ దట్ సెంచురీ కెనాట్ బి Tuesday, Thursday and then Saturday. Remember this. All right, let's see the next question. The next question చూసినట్లయితే, okay, the last day of the century year cannot be is we are done with this. And then the next question, all right, the first day of the century year can be అంటున్నారు. సో ఎలా అయితే ద లాస్ట్ డే ఆఫ్ ద సెంచురీ ఇయర్ కెనాట్ బి అన్నప్పుడు మనం ఏం చెప్తాం? కెనాట్ బి అంటే మనం ఏం చెప్తామంటే ఇట్ ఇస్ లైక్ ట్యూస్డే, థర్స్డే, సాటర్డే రావడానికి కుదరదు. ఇప్పుడు ద లాస్ట్ డే ఆఫ్ ద సెంచురీ ఇయర్ క్యాన్ బి అన్నాను అంటే ఇట్ ఇస్ మండే, సాటర్డే, ఫ్రైడే, వెన్స్డే. బట్ ఈ పర్టికులర్ క్వశ్చన్ మీరు చూసినట్టయితే లాస్ట్ డే కాదు, ఫస్ట్ డే ఆఫ్ ద సెంచురీ ఇయర్ క్యాన్ బి అన్నాడు. సో ఇదేలాగా మీరు 1st January తీసుకున్నారు అంటే సాల్వ్ చేసి వస్తే, సో ఎక్స్ప్లెనేషన్ నేను మీకు చెప్పాను. సో మళ్ళీ కంప్లీట్గా ద లాస్ట్ డేస్ ఆఫ్ ద సెంచురీ ఇయర్ క్యాన్ బి ఫ్రైడే, వెన్స్డే, మండే, సండే. ఇదే మనం డిస్కస్ చేసాం. సో ఇవన్నీ లాస్ట్ డేస్ వచ్చేటప్పుడు సెంచరీలో, సో న్యాచురలీ ద ఫస్ట్ డేస్ ఆఫ్ ద ఫాలోయింగ్ సెంచరీస్, సో ఏ పర్టికులర్ సెంచరీస్కి ఫ్రైడే వచ్చే ప్లేస్లో ఫ్రైడే లాస్ట్ డే ఆఫ్ ద సెంచరీ అయితే, రిమెంబర్ ఫ్రైడే లాస్ట్ డే ఆఫ్ ద సెంచరీ అయితే ఫస్ట్ డే ఆబ్వియస్లీ సాటర్డే ఉంటుంది. వెన్స్డే లాస్ట్ డే ఆఫ్ ద సెంచరీ అయితే థర్స్డే ఉంటుంది. సో మండే లాస్ట్ డే ఆఫ్ ద సెంచరీ అయితే ఆ పర్టికులర్ ఫస్ట్ డే ఆఫ్ ద సెంచరీ మీరు చూసినట్లయితే ట్యూస్డే అవుతుంది. దెన్ సండే లాస్ట్ డే ఆఫ్ ద సెంచరీ అయితే మండే అవుతుంది. సో వాట్ ఎవర్, ఫర్గెట్ అబౌట్ ద ఆర్డర్, ద ఫస్ట్ డే ఆఫ్ ద సెంచరీ క్యాన్ బి సాటర్డే, థర్స్డే, ట్యూస్డే, మండే అవుతుందమ్మా. ఐ రిపీట్, సాటర్డే, థర్స్డే, ట్యూస్డే. మీరు ఇక్కడ చూసినట్లయితే ఇవే ఫస్ట్ డే ఆఫ్ ద సెంచరీస్ రావడానికి ఉన్న ఛాన్సెస్. ఫస్ట్ సాటర్డే రావచ్చు. ఫస్ట్ డే ఆఫ్ ద సెంచరీ అంటే 1st Jan, లెట్స్ సే ఫర్ ఎగ్జాంపుల్ 1st Jan 2001 is the best example. Now if you see the screen, Saturday, Thursday and then Tuesday and then Monday ive raavadaniki chances undi. I hope you understand. Let's see the next question. Which will have the same calendar year as that of 2011? Which will have the same calendar year as of 2011? And for this it is so simple. I'm going to give you a small logic which will help you to sort of this kind of problems. Manaki 3 conditions unnai. Ee 3 conditions ni meer gurtu pettukunte, so you can answer it within fraction of seconds. Alright, ఆ కండిషన్ ఏంటి అని మనం చూద్దాం. సో 2011 యొక్క క్యాలెండర్ ఇయర్ మళ్ళీ ఎప్పుడు రిపీట్ అవుతుంది? మీరు క్యాలెండర్ అల్గరిథం మీరు చూసినట్లయితే మళ్ళీ రిపీట్ అవుతూనే ఉంటుంది. ఇట్స్ నాట్ లైక్ 1000 ఇయర్స్ ఉంటే ఆ 1000 డిఫరెంట్ ఇయర్స్ ఉండదు. మరి క్యాలెండర్ రిపీటేషన్ అంటే ఏంటి అని చూసారంటే, లెట్స్ టేక్ దిస్ 2018 అనే ఇయర్లో డెఫినెట్గా Jan 1st అనేది ఒక పర్టికులర్ డే వచ్చి ఉంటుంది. Jan 2nd అనేది ఒక పర్టికులర్ డే, ఒక పర్టికులర్ డే అండ్ డేట్ అనేది మ్యాచ్ అవుతూ వస్తుంది, అవునా? కొన్ని ఇయర్స్ తర్వాత మళ్ళీ ఇదేలాగా ఫస్ట్ డే ఆ పర్టికులర్ డేలో రావడం, ఆ పర్టికులర్ డేట్లో రావడం, సెకండ్ డే అదే డేట్లో రావడం. అంటే 2 క్యాలెండర్స్ మీరు తీసుకొని పైన హెడ్డింగ్ మీరు రిమూవ్ చేసినట్టయితే, అంటే 2018 ఇంకేదన్నా ఆ హెడ్డింగ్ మీరు తీసేసినట్టయితే 2 క్యాలెండర్స్ డేట్స్ అండ్ డేస్ అనేది మ్యాచ్ అవుతూ వస్తుంది. మీరు ఏ పర్టికులర్ డేట్ తీసుకున్నా ఆ పర్టికులర్ డేట్ ఏ పర్టికులర్ డేలో ఉంది అనేది ఈ క్యాలెండర్లో అలానే ఉంటుంది. బట్ ఇది ఏంటంటే ఒక అల్గరిథంని ఫాలో అవుతూ రిపీట్ అవుతుంటుంది. ఆ అల్గరిథం ఏంటి అనేది మనం ఇప్పుడు తెలుసుకుందాం. లెట్స్ సీ. ఫర్ ఎగ్జాంపుల్ మీరు చూసినట్లయితే ఎక్స్ప్లెనేషన్, ఇఫ్ ద గివెన్ ఇయర్ ఇస్ అ లీప్ ఇయర్ దెన్ యాడ్ 28. గివెన్ ఇయర్ ఇస్ అ లీప్ ఇయర్ దెన్ యాడ్ 28 అంటే ఫర్ ఎగ్జాంపుల్ లీప్ ఇయర్ క్యాలెండర్ మళ్ళీ ఎప్పుడు రిపీట్ అవుతుందంటే ఎవ్రీ 28 ఇయర్స్కి ఒకసారి లీప్ ఇయర్ క్యాలెండర్ రిపీట్ అవుతుంది. ఫర్ ఎగ్జాంపుల్ 2000 అనేది లీప్ ఇయర్, ఆ పర్టికులర్ క్యాలెండర్ మీకు ఎప్పుడు రిపీట్ అవుతుందంటే 2028, జస్ట్ యాడ్ 2028లో రిపీట్ అవుతుంది. ఇఫ్ ద గివెన్ ఇయర్ ఇస్ అ ఇయర్ నెక్స్ట్ టు లీప్ ఇయర్ దెన్ యాడ్ 6. నెక్స్ట్ టు లీప్ ఇయర్ అంటే ఫర్ ఎగ్జాంపుల్ ఇప్పుడు 2000 అనేది లీప్ ఇయర్, లేదు మీరు 2004 తీసుకోవచ్చు లీప్ ఇయర్, 2008 తీసుకోవచ్చు. మీరు ఏ లీప్ ఇయర్ మీరు తీసుకున్నట్టయినా మీరు జస్ట్ 28 యాడ్ చేసినప్పుడు మళ్ళీ రిపిటేషన్. సో అది ఎలా అనేది నేను చెప్తాను. ఇట్ ఇస్ సో సింపుల్. లెట్స్ సీ హౌ దిస్ వర్క్స్. సో 2004 నేను తీసుకున్నాను. 2004 అనేది ఇయర్ ఒక లీప్ ఇయర్. ఈ లీప్ ఇయర్ క్యాలెండర్ నాకు మళ్ళీ ఎప్పుడు రిపీట్ అవుతుందంటే జస్ట్ యాడ్ 28. మీరు 28 యాడ్ చేసినప్పుడు ఏమవుతుంది? 2032. దాట్స్ ఇట్. సో ఫ్రమ్ దిస్ వాట్ ఐ కెన్ సే 2004 క్యాలెండర్ 2032 క్యాలెండర్ అనేది సేమ్గా ఉంటుంది. దిస్ ఇస్ హౌ ద క్యాలెండర్ అల్గరిథం వర్క్స్. దిస్ ఇస్ హౌ దే డిజైన్ ద అల్గరిథం. ఆల్ రైట్. నెక్స్ట్ లెట్స్ సే ఫర్ ఎగ్జాంపుల్ మీరు ఏదైనా తీసుకోవచ్చు 2016 అనేది కూడా ఒక లీప్ ఇయర్. am I right? 2016 లీప్ ఇయర్, దీనికి మీరు ప్లస్ 28 యాడ్ చేసినట్టయితే ఏమవుతుంది? ఇట్స్ సో సింపుల్, 2044. సో 2044. సో 2016 అండ్ 2044 క్యాలెండర్ రెండు సేమ్గా ఉంటుంది. ఓకే, రిపీట్ అవుతుంది. ఇది లీప్ ఇయర్కి. సో ఇఫ్ ద ఇయర్ నెక్స్ట్ టు లీప్ ఇయర్ అంటే ఏంటని చూస్తే ఫర్ ఎగ్జాంపుల్ 2004 అనేది మీకు లీప్ ఇయర్, అవునా? సో ఇయర్ నెక్స్ట్ టు లీప్ ఇయర్ అంటే 2005 అనేది ఇయర్ నెక్స్ట్ టు లీప్ ఇయర్ అవుతుంది. సేమ్ థింగ్ ఇప్పుడు 2016 అనేది లీప్ ఇయర్ అయితే 2017 అనేది ఇయర్ నెక్స్ట్ టు లీప్ ఇయర్. అవునా? తర్వాత ఇమ్మీడియట్గా వచ్చే లీప్ ఇయర్ తర్వాత ఇమ్మీడియట్గా వచ్చే ఇయర్ని నెక్స్ట్ టు లీప్ ఇయర్ అంటాం. సో వాటికి మనం ఏం చేయాలంటే యాడ్ 6. ఇట్ ఇస్ సో సింపుల్. యాడ్ 6 అంటే లెట్స్ సే నేను 2005 తీసుకుంటున్నాను. 2005 ఇస్ అన్ ఇయర్ నెక్స్ట్ టు లీప్ ఇయర్, ఎందుకంటే 2004 లీప్ ఇయర్. సో నేను దానికి 6 యాడ్ చేసుకుంటే ఇట్ ఈస్ సో సింపుల్, ఇట్ ఈస్ గోయింగ్ టు బి 2011. సో 2005లో వచ్చిన 2005లో వచ్చిన ఇయర్ యొక్క క్యాలెండర్ ఇయర్ దాని యొక్క రిపిటేషన్ ఎప్పుడు ఉంటుందంటే మళ్ళీ యాడ్ 6 అంటే 2011లో రిపీట్ అవుతుంది. బట్ మన క్వశ్చన్ ఇది కాదు, మనకి 2011లో వచ్చే క్యాలెండర్ మళ్ళీ ఎప్పుడు రిపీట్ అవుతుంది దానికి మళ్ళీ వస్తాను. అండ్ దెన్ వీ హ్యావ్ వన్ మోర్ థింగ్, ఫర్ అదర్స్ యాడ్ 11 అని చెప్పాను. ఫర్ అదర్స్ యాడ్ 11 అంటే ఫర్ ఎగ్జాంపుల్ ఒక లీప్ ఇయర్ నుండి ఇంకొక లీప్ ఇయర్ రావడానికి మనకి 4 years మధ్యలో గ్యాప్ ఉంటుంది. ఎవ్రీ 4 yearsకి వస్తుంది కాబట్టి మధ్యలో 3 years గ్యాప్ ఉంటుంది. ఇన్ సచ్ కేస్ ఎలా అనేది చూద్దాం. ఒక 4 years ఎగ్జాంపుల్ తీసుకొని నేను చెప్తాను, మీరు ఏ క్వశ్చన్కైనా ఇదే అప్లై చేసుకోవచ్చు. లెట్స్ టేక్ 4 years. నేను 2016, 2017, 2018 అండ్ దెన్ 2019 ఈ 4 years నేను మీకు తీసుకుంటున్నాను. దీంట్లో దిస్ ఇస్ అ లీప్ ఇయర్, సో దిస్ ఇస్ నేను స్టార్ మార్క్ పెట్టినాను. దీనికి జస్ట్ 28 యాడ్ చేస్తే 2044 వచ్చేస్తుంది. సో సిన్స్ దిస్ ఇస్ అ లీప్ ఇయర్ నేను ప్లస్ 28 యాడ్ చేశాను. రిమెంబర్, ప్లస్ 28 యాడ్ చేస్తే నా క్యాలెండర్ ఇయర్ రిపీట్ అవుతుంది. నౌ దిస్ ఇస్ 2017, ఇది ఇయర్ నెక్స్ట్ టు లీప్ ఇయర్. 2017 ఏమవుతుందంటే 2023లో మళ్ళీ రిపీట్ అవుతుంది. సో ఐ విల్ జస్ట్ యాడ్ 6, ఎందుకంటే దిస్ ఇస్ ద అల్గోరిథం. ప్లస్ 6 అనేది యాడ్ చేస్తాను, ఎందుకంటే ఇయర్ నెక్స్ట్ టు లీప్ ఇయర్ కాబట్టి జస్ట్ యాడ్ 6. ఫర్ అదర్స్ అని ఇక్కడ ఏంటంటే 2018, 2019 అనేది అదర్స్, ఎందుకంటే మళ్ళీ మీకు 2020 అనేది లీప్ ఇయర్, మళ్ళీ 2020 లీప్ ఇయర్. సో ఇది వదిలేస్తే ఈ రెండింటికి మనం జస్ట్ ఏమవుతుంది ఎలా చేస్తే సో సింపుల్, వీ హ్యావ్ టు యాడ్ ప్లస్ 11 అంటే 2018కి 11 యాడ్ చేసి మీకు ఏమవుతుంది 2029 అండ్ దెన్ 2019 ఇట్ ఇస్ 2030. ఆల్రైట్, సో ఇది చూశారు అంటే 2018 యొక్క క్యాలెండర్ ఇయర్ 2029లో రిపీట్ అవుతుంది అండ్ దెన్ 2019 యొక్క క్యాలెండర్ ఇయర్ 2030లో రిపీట్ అవుతుంది. సో సింపుల్. ఆల్రైట్, యాడ్ 28 ఇఫ్ ఇట్స్ అ లీప్ ఇయర్, యాడ్ 6 ఇఫ్ ఇట్స్ అ ఇయర్ నెక్స్ట్ టు లీప్ ఇయర్, యాడ్ 11 ఫర్ అదర్స్. ఇప్పుడు మన క్వశ్చన్ మనం చూసినట్లయితే సో జస్ట్ సీ ద క్వశ్చన్ వన్స్. ఇట్ ఇస్ సో సింపుల్, which are will have the same calendar year as that of 2011 అని చెప్పి మీకు ఇచ్చాము. 2011 మీకు ఇచ్చినట్లయితే సి ఇట్ ఇస్ సో సింపుల్. సో 2011 అనేది ఏంటి అని చెక్ చేయాలి. సి 2008 అనేది లీప్ ఇయర్, రైట్? 2008 అనేది లీప్ ఇయర్. 2009 అనేది చూసినట్లయితే మీకు ఇయర్ నెక్స్ట్ టు లీప్ ఇయర్, నెక్స్ట్ 2010 అండ్ దెన్ 2011. దిస్ ఇస్ హౌ ఇట్ వర్క్స్. సో అది నేను మీకు క్లియర్గా రాస్తే, ఐ రిపీట్ దిస్ వన్స్ అగైన్. సో 2008 అనేది మీరు చూసినట్లయితే ఇట్స్ అ లీప్ ఇయర్. ఆల్రైట్, 2009 ఇట్స్ అ ఇయర్ నెక్స్ట్ టు లీప్ ఇయర్, నెక్స్ట్ 2010 అండ్ 2011. సో 2011 అదర్స్ వస్తుంది కాబట్టి జస్ట్ యాడ్ ప్లస్ 11. సో విచ్ యుల్ గెట్ ఇట్ ఇన్ 2023. 2011 it's like 2022. That's it. Just add 11. It's so simple. So whatever it is, just add 11. And if you see the options, it is 2022. That is what we are talking about. My screen is chusinattayite option A 2015, 2016, 2017, 2018 and then 2022. All right, this is how it works. So answer is 2022. All right, now so very important question, how many days are there in X weeks and X days? Most frequently asked question when it comes to calendars. So question మళ్ళీ నోట్ చేసుకోండి, చాలా ఇంపార్టెంట్. హౌ మెనీ డేస్ ఆర్ దేర్ ఇన్ ఎక్స్ వీక్స్ అండ్ ఎక్స్ డేస్? సో ఎక్స్ వీక్స్ ఎక్స్ డేస్లో ఎన్ని డేస్ ఉంటుంది? వాట్ డస్ ఇట్ మీన్ ఎక్స్ వీక్స్ అండ్ ఎక్స్ డేస్ అని మీకు క్వశ్చన్ రావచ్చు. ఫర్ ఎగ్జాంపుల్ ఎక్స్ వీక్స్ ఎక్స్ డేస్ అంటే ఎక్స్ వాల్యూలో ఎక్స్ ప్లేస్లో మీరు ఏదైనా సబ్స్టిట్యూట్ చేయించుకోవచ్చు. 2 weeks 2 days, 3 weeks 3 days, 4 weeks 4 days ఇలా అనమాట. ఎక్స్ కామన్, వీక్స్ అనేది కామన్. సో ఎక్స్ వీక్స్ ఎక్స్ డేస్లో ఎన్ని డేస్ ఉంటుంది టోటల్గా అనేది ఎలా క్యాలిక్యులేట్ చేస్తాం? మనకి ఇక్కడ 4 ఆప్షన్స్ ఇచ్చారు. అదేంటంటే ఫస్ట్ ఇట్ ఇస్ 7x² అండ్ దెన్ 8x, 14x D 7 and E none of this. Answer is so simple. Answer is 8x. 8x ఎలా వస్తుంది అనేది ఒకసారి మనం చెక్ చేద్దాం. See, so simple. Just x place లో ఒకటి సబ్స్టిట్యూట్ చేసి చూసి ఒక వాల్యూ సబ్స్టిట్యూట్ చేస్తే విల్ గెట్ ఇట్. లెట్స్ సీ హౌ దిస్ వర్క్స్. సో x weeks, x days. Am I right? x weeks, x days అనేది మనకి ఇక్కడ క్వశ్చన్. అండ్ దెన్ సో సింపుల్. లెట్ x is equal to 3. లెట్ x is equal to 3. మీరు 3 సబ్స్టిట్యూట్ చేయాలని అవసరం లేదు, మీరు ఏదైనా సబ్స్టిట్యూట్ చేయొచ్చు. నేను ఎగ్జాంపుల్కి తీసుకుంటున్నాను. లెట్ x equal to 3. x equal to 3 అయితే ఏమవుతుంది మీకు 3 weeks 3 days అవుతుంది. Am I right? Just because x is common for weeks and days, 3 weeks 3 days అవుతుంది. 3 weeks 3 days ఎంత మీరు చెక్ చేసినట్టే 3 weeks అంటే we know that weekly 7 days, 3 weeks అంటే 21 days, and then 3 it is going to be 24 days. సో 3 weeks 3 daysలో మొత్తం ఎన్ని డేస్ ఉంటుందంటే 24 days. ఇప్పుడు ఈ 24 అనేది మీకు ఆప్షన్లో ఎక్కడ సాటిస్ఫై అవుతుందో దట్ ఈస్ గోయింగ్ టు బి ద ఆన్సర్. సో మీరు చూసినట్లయితే లెట్స్ టాక్ అబౌట్ ఫస్ట్ ఆప్షన్ 7x స్క్వేర్ ఉంది. 7x స్క్వేర్ మీరు చూసినట్లయితే 7 అండ్ వాట్ ఈస్ ద వాల్యూ ఆఫ్ x? ఇట్ ఇస్ 3. సో 7 into 3 square. 7 into 3 square అంటే 7 into 9. So 7 into 9 is obviously 7 9s are, it is 63. It is not the answer just because we supposed to get 24 days. Avuna. Next option 2 chudandi. Option 2, what is option 2 here? It is 8x. So simple, 8x. So 8 into point is nothing but into x and ekadanta x is 3. So 8 into 3 which is 24 days. Perfect. So this is going to be our answer. 8x is the answer. And 14x annaru. 14 into 3 42, not at all sufficient. And 7 no, and none of this no. So answer is 8x. Alright, so I hope you understand the classes. So ఈ ప్రాబ్లమ్స్ అన్ని మీరు చూసారు కదా. సో నిన్న మనం ఫస్ట్ క్యాలెండర్ క్వశ్చన్, బేసిక్ క్యాలెండర్ క్వశ్చన్ని ఎలా సాల్వ్ చేయాలనేది చెక్ చేసాం. ఒక పర్టికులర్ డేట్ ఇచ్చి ఆ పర్టికులర్ డేట్లో ఏ డే అనేది ఫైండ్ అవుట్ చేయడం అనేది ఇట్స్ అ బేసిక్. అండ్ టుడే we have discussed multiple problems. I hope you understand calendar's concept. If you have any questions or doubts, please post in the comments. I shall reply. I'm just waiting for your comments. Alright, thank you so much for the class. Everyone, good morning. Welcome to Aptitude Foundation course presented by APSSTC. So today we are going to discuss analogy. What is meant by analogy and how it works. So first, in order to get into the problems, we understand what is the methodology under this. All right, let's start. So when it comes to analogy, let's discuss the format first. What is meant by analogy and how it works? See, it is so simple. Analogy in the sense, so there will be a relationship between two terms or words. We need to understand how it works. Alright, let's say for example, A, B, C, D. Can you see this? A, B, C, D. Alright, now I'm going to, apply some relationship to this particular variables, and I'm going to derive an analogy from this and how it works. And చూద్దామంటే see for example A and B, ఇక్కడ నేను మీకు 4 వేరియబుల్స్ రాశాను అవునా. ఈ 4 వేరియబుల్స్ చూసారు అంటే see here A and B ఒక రిలేషన్షిప్ లో ఉంది. hence I'm going to use this colon. I repeat, A and B అనేది ఒక రిలేషన్షిప్ లో ఉంది. ఈ పర్టికులర్ రిలేషన్షిప్, so A and B are in a particular relationship, and try to understand C and D are in a particular relationship. I repeat, analogies lo entante, see, we understand what is the relationship between two terms here, and we need to apply the same relationship to the other variables in order to get the answer. Ante adi ela anedi nenu meeku cheptunanu. For example, we have 4 variables. A variables enti ante A, B, C, D. ఇవే ఆ 4 వేరియబుల్స్. సో ఈ వేరియబుల్స్ని యూజ్ చేసి అనాలజీని ఎలా డిఫైన్ చేస్తాం అనేది ఒకసారి చెక్ చేసుకుందాం. నా A and B ఆర్ ఇన్ అ రిలేషన్షిప్ అనేది ఎలా అంటే, ఫర్ ఎగ్జాంపుల్ A అనేది Bకి బ్రదర్ అనుకుందాం. Try to understand, A is the brother of B, for your understanding purpose, A is the brother of B. Alright, so ఈ రిలేషన్షిప్లో ఉంది అని మెన్షన్ చేయడానికి నేను ఏం చేస్తున్నానంటే జస్ట్ ఒక కోలన్ మెన్షన్ చేస్తాను. అట్ ద సేమ్ టైమ్ నా C and D are in a relationship. Once again C and D are in a relationship. So ఈ C and D ఏ రిలేషన్షిప్లో ఉందంటే once again C is the brother of D. Alright, C is the brother of D. So A, B యొక్క రిలేషన్షిప్ ఏంటి? సిబ్లింగ్స్. A is the brother of B, siblings. And C, D రిలేషన్షిప్ ఏంటి అంటే it is once again siblings. C is the brother of D అంటున్నాను, siblings. Alright, so దీన్ని బట్టి ఏంటంటే A and B ఏ రిలేషన్షిప్లో అయితే ఉన్నాయో C and D కూడా అదే రిలేషన్షిప్లో ఉన్నారు. అంటే A and B సిబ్లింగ్స్ అయితే C and D కూడా సిబ్లింగ్సే. లెట్స్ సే ఫర్ ఎగ్జాంపుల్ సిబ్లింగ్స్ కాదు ఇంకేదైనా తీసుకుంటే లెట్స్ సే A and B, A father, B son అని తీసుకుందాం. I repeat, A father, B son అని తీసుకుంటే once again C is to D కూడా C father, D అనేది son అని తీసుకుంటే ఫర్ ఎగ్జాంపుల్ సో ఇవి రెండు సేమ్ రిలేషన్షిప్లో ఉన్నాయి కాబట్టి ఐఎమ్ గోయింగ్ టు మార్క్ ఇట్ as an ప్రపోర్షన్ సింబల్ ఉంటుంది. ఇట్ ఇస్ నథింగ్ బట్ అనాలజీ. నా ఈ అనాలజీ ఎలా డిరైవ్ అవుతుంది ఏంటి అనేది చెక్ చేస్తాం. సో ట్రై టు అండర్స్టాండ్. మీకు ఎగ్జామ్స్లో మీ క్వశ్చన్స్లో మీరు చూసినట్లయితే దిల్ నాట్ గివ్ యూ ద ఫోర్త్ టర్మ్, దిల్ నాట్ గివ్ యూ దిస్ D. ఎందుకు D ఇవ్వరు అనేది అంటే దిస్ ఇస్ వాట్ యూ నీడ్ టు ఫైండ్ అవుట్. ఈ Dనే మీరు ఫైండ్ అవుట్ చేయాల్సి ఉంటుంది. ఓకే, సో AB ఒక రిలేషన్షిప్లో ఉన్నారు. సో AB ఏ రిలేషన్షిప్లో ఉన్నారు అంటే CD కూడా అదే రిలేషన్షిప్లో ఉన్నారు. ఓకే, ఫర్ ఎగ్జాంపుల్ A ఇస్ ద బ్రదర్ ఆఫ్ B అంటే C ఈజ్ ఆల్సో బ్రదర్ ఆఫ్ దట్ పర్సన్. ఆల్రైట్, నా దీంట్లో మీరు అండర్స్టాండ్ చేసుకోవాల్సింది ఏంటంటే రిమెంబర్ Aకి Cకి ఎటువంటి రిలేషన్షిప్ ఉండదు. Aకి Cకి ఎటువంటి రిలేషన్షిప్ ఉండదు. ఆల్రైట్, అండ్ A at any cost C కి రిలేట్ అవ్వడు. ఆల్రైట్, సో ఏ పర్టికులర్ రిలేషన్షిప్ is given in between A and B అంటే క్వశ్చన్లో మీకు Aకి Bకి ఒక పర్టికులర్ రిలేషన్షిప్ ఇస్తారు. అట్ ద సేమ్ టైమ్ సో A is to B ప్రపోర్షన్ C is to క్వశ్చన్ మార్క్ అనేది మీకు క్వశ్చన్ అయితే A and Bకి ఒక రిలేషన్షిప్ డెఫినెట్గా ఉంటారు అని చెప్పాను కదా ఆల్రెడీ. సో ఇలా కోలన్ మెన్షన్ చేశాను అంటేనే వీళ్ళిద్దరు ఒక రిలేషన్షిప్లో ఉన్నారు అని చెప్పి ఒక రిలేషన్షిప్ వాళ్ళే ఇస్తారు. అండ్ దెన్ C is to క్వశ్చన్ మార్క్ అంటారు. సో ఈ A is to Bలో ఏ రిలేషన్షిప్ అయితే ఈ A is to Bకి ఏ రిలేషన్షిప్ అయితే ఉందో అదే రిలేషన్షిప్ మీకు Cకి అప్లై చేసినప్పుడు మీకు ఆన్సర్ ఏమొస్తుంది అనేది మీరు ఫైండ్ అవుట్ చేయాలి. అంటే ఎలా దీన్ని ఫైండ్ అవుట్ చేసే ముందు దర్ ఆర్ సర్టెన్ పాయింట్స్ విచ్ యూ నీడ్ టు రిమెంబర్. A and Cకి ఎటువంటి A and Cకి ఎటువంటి రిలేషన్షిప్ ఉండదు. A and Bకి మాత్రమే రిలేషన్షిప్ ఉంటుంది. అట్ ద సేమ్ టైం B and Cకి కూడా ఎటువంటి రిలేషన్షిప్ ఉండదు. ఆల్రైట్, ఇది ఎలా అనేది మనం ఎక్స్ప్లెయిన్ చేస్తే సో A, B అనేది ఒక టీమ్. ఆల్రైట్, C, D అనేది ఒక టీమ్. బట్ ఈ D ఎవరు అనేది వాళ్ళు ఎవరు, దట్ ఈస్ వాట్ వీ నీడ్ టు ఫైండ్ అవుట్. బట్ వీళ్ళిద్దరు ఒక టీం, వీళ్ళిద్దరు ఒక టీం అంటే వీళ్ళిద్దరికి ఒక రిలేషన్షిప్ ఉంటుంది. వీళ్ళిద్దరికి ఏ రిలేషన్షిప్ అయితే ఉంటుందో C and D కూడా అదే రిలేషన్షిప్ ఉంటుంది. సో ఒక పర్టికులర్ రిలేషన్షిప్ వాళ్ళే ఇస్తారు. ఆ రిలేషన్షిప్ని యూటిలైజ్ చేసి అప్లై చేసి వీ నీడ్ టు ఫైండ్ అవుట్ ద ఆన్సర్. నా ఎట్ ద సేమ్ టైం రిమెంబర్ ఫర్ ఎగ్జాంపుల్ ఇక్కడ D ఉంది అంటే కూడా ఇక్కడ క్వశ్చన్ ఫార్మాట్ పక్కన పెడితే ఫస్ట్ ఫార్మాట్ చూద్దాం. ఇక్కడ D అనేది కూడా ఉంది అంటే రిమెంబర్ A Dకి కూడా ఎటువంటి రిలేషన్షిప్ ఉండాల్సిన అవసరం లేదు, ఉండదు కూడా. A Dకి ఎటువంటి రిలేషన్షిప్ ఉండదు. అండ్ దెన్ B Dకి కూడా ఎటువంటి రిలేషన్షిప్ ఉండదు. సో అనాలజీలో A B C D సో A అండ్ B ఒక సెట్ C అండ్ D అనేది ఒక సెట్. A అండ్ Bకి ఒక రిలేషన్షిప్ ఉంటుంది. C అండ్ Dకి A అండ్ Bకి ఏ రిలేషన్షిప్ అయితే ఉంటుందో C అండ్ Dకి కూడా అదే రిలేషన్షిప్ ఉంటుంది. బట్ Aకి Cకి ఎటువంటి రిలేషన్షిప్ ఉండదు. అట్ ద సేమ్ టైం A అండ్ Dకి ఎటువంటి రిలేషన్షిప్ ఉండదు. B అండ్ Cకి ఎటువంటి రిలేషన్షిప్ ఉండదు. B అండ్ Dకి కూడా ఎటువంటి రిలేషన్షిప్ ఉండదు. సో ఇది మనం టీమ్గా కన్సిడర్ చేస్తే A అండ్ B ఒక టీమ్ ఇక్కడ, C అండ్ D ఒక టీమ్ ఇక్కడ. ఆల్రైట్, మరి మీరు ఏంటి ఫైండ్ అవుట్ చేయాలి అంటే సో సింపుల్. ఈ పర్టికులర్ క్వశ్చన్ ఎలా ఇస్తారంటే A is to B అనేది ఇస్తారు. సో A is to B అనేది 2 టర్మ్స్ ఇస్తారు. ఆల్రైట్, ఈ 2 టర్మ్స్ చూడగానే మీరు ఫస్ట్ థింగ్ ఆన్సర్ ఫైండ్ అవుట్ చేయాల్సిన అవసరం లేదు. ఫస్ట్ థింగ్ ఇక్కడ D ఏంటి అనేది మీరు ఫైండ్ అవుట్ చేసే ముందు అంటే A is to B ప్రపోర్షన్ C is to D అంటే దీన్ని మీరు అర్థం చేసుకోవాల్సింది అంటే A అండ్ B ఎటువంటి రిలేషన్స్లో ఉన్నారో C అండ్ ద నెక్స్ట్ టర్మ్ కూడా అదే రిలేషన్షిప్లో ఉన్నారు. సో క్వశ్చన్ చూడగానే మీరు ఫైండ్ అవుట్ చేయాల్సింది ఏంటంటే ఈ రిలేషన్షిప్ ఏంటి అనేది మీరు ఫైండ్ అవుట్ చేయాలి. ఇది మీరు ఎలా ఫైండ్ అవుట్ చేస్తారు అంటే సో మీ ఒకాబులరీ మీకు దీంట్లో హెల్ప్ చేస్తున్నాయి. గైస్ ట్రై టు అండర్స్టాండ్ అనాలజీస్లో మీకు నెంబర్ అనాలజీ ఉంది, రిమెంబర్ నెంబర్ అనాలజీ ఉంది, వర్డ్ అనాలజీ ఉంది, కోడింగ్ అండ్ డీకోడింగ్ అనాలజీ ఉంది. సో అనాలజీ అనేది ఓన్లీ ఒకాబులరీకి మాత్రమే యూజ్ చేస్తారని కాదు, అనాలజీ అనేది నంబర్స్కి కూడా యూజ్ చేస్తారు. సో ఇట్ డిపెండ్స్. Alright, so we have 3 types of analogies. First type questions based on vocabulary, English terminology, words and words probably, and then questions based on numbers and questions based on coding and decoding. Alright, నా సో ఏ అండ్ బికి ఒక రిలేషన్షిప్, ఈ రిలేషన్షిప్ని ఏంటి అనేది మనమే ఫైండ్ అవుట్ చేయాల్సి ఉంటుంది, వాళ్ళు ఇవ్వరు. ఆల్రైట్, ఈ రిలేషన్షిప్ ఫైండ్ అవుట్ చేసిన తర్వాత ఇదే రిలేషన్షిప్ని మనం ఇక్కడ సీక్ అప్లై చేస్తాం. సో సీక్ అప్లై చేసినప్పుడు అప్లికేషన్, రిలేషన్షిప్ అప్లికేషన్. సో ఇది అప్లై చేసినప్పుడు ఏమవుతుందిరా అంటే మనకి ఈ ఫైనల్ ఆన్సర్ ఆటోమేటిక్గా డిరైవ్ అవుతుంది. బట్ ఛాలెంజెస్ ఏంటి ఎనాలజీలో అనేది మీరు చూసుకోవాలి గైస్. నేను మీకు ఫస్ట్ నుండే చెప్తున్నాను, వెన్ ఇట్ కమ్స్ టు యాప్టిట్యూడ్ క్వశ్చన్స్ ఎప్పుడు హార్డ్గా ఉండదు. ఆల్రైట్, క్వశ్చన్స్ అనేది ఒక స్టాండర్డ్ ఒక స్టాండర్డ్స్ని ఫాలో అవుతూ ఉంటుంది. ఓకే, ఒక స్టాండర్డ్ ఫార్మాట్, ఒక స్టాండర్డ్స్ని ఫాలో అవుతూ ఉంటుంది. సో క్వశ్చన్ ఈజీ లేదు క్వశ్చన్ హార్డ్ అనేది ఎప్పుడు డిఫరెన్షియేట్ చేస్తారు అంటే ఇట్స్ ఆల్ అబౌట్ యువర్ ఆన్సర్స్. ఓకే, ఆప్షన్స్, మీ ఆప్షన్సే మీ క్వశ్చన్ ఈజీగాను టఫ్గాను చేస్తుంది. ఆల్రైట్, సో ఫర్ ఎగ్జాంపుల్ ఎలా అనేది మీరు చూసినట్లయితే, సో దీనికి మీకు ఒక ఎగ్జాంపుల్ చెప్తాను, క్వశ్చన్స్ ఎలా టఫ్ చేస్తుంది అనేది. మీరు ఒక క్వశ్చన్ హార్డా ఈజీనా అనేది ఎలా డిఫరెన్షియేట్ చేస్తారు అంటే ఆప్షన్స్ని బేస్ చేసుకొని. లెట్స్ సే ఫర్ ఎగ్జాంపుల్ వీ హ్యావ్ అ క్యాల్కులేషన్. ఆ క్యాల్కులేషన్ ఎలా ఉంది అంటే 4905. ఇది మీకు ఆల్రెడీ ఫస్ట్ క్లాస్లో ఎక్స్ప్లెయిన్ చేస్తున్నాను యాప్టిట్యూడ్ ఇంట్రడక్షన్లో, బట్ ఐమ్ జస్ట్ రిపీటింగ్ ఫర్ యువర్ అండర్స్టాండింగ్ థింగ్. 4905 అనే నెంబర్ ఉంది అండ్ దీన్ని 698 అనే నెంబర్ డివైడ్ చేయాలి. ఐ రిపీట్, 4905 అనే ఒక నెంబర్ని 698 డివైడ్ చేస్తే, సో ఇదే మీ క్యాల్కులేషన్ యొక్క ఫైనల్ సొల్యూషన్ పార్ట్. దీన్ని డివైడ్ చేసినట్లయితే విల్ గెట్ ద ఆన్సర్. నా ఈ సేమ్ క్యాల్కులేషన్ని ఎలా ఈజీగా చేయాలి, ఎలా హార్డ్గా చేయాలి అనేది ఆప్షన్స్ డిఫైన్ చేస్తుంది. లెట్స్ సీ హౌ ఇట్ వర్క్స్. ఫర్ ఎగ్జాంపుల్ ఫస్ట్ ఈ ఆప్షన్ ఎలా ఉంది అంటే లెట్స్ సే 6 పాయింట్ సమ్ 2 digit 2, 7.2 digits 3, 8.2 digits and then 4, 9.2 digits. So empty space is just 2 digit numbers and 6.46 6.01 something. Okay, just an example. Now ఇంకొక ఆప్షన్ మీరు చూసినట్లయితే ఇదొక సెట్ ఆఫ్ ఆప్షన్స్. ఇంకొక సెట్ ఆఫ్ ఆప్షన్స్ మీరు చూసినట్లయితే 7 పాయింట్, సెకండ్ ఆప్షన్ కూడా 7 పాయింట్, థర్డ్ ఆప్షన్ కూడా 7 పాయింట్, ఫోర్త్ ఆప్షన్ 7 పాయింట్. అన్ని 7 పాయింట్స్ ఉంది. బట్ నెక్స్ట్ వచ్చే డిజిట్స్ ఇక్కడ డిఫరెంట్. డిజిట్స్ ఇక్కడ డిఫరెంట్ అంటే ఏంటి, ఎలా అని చెప్పి. సో ఈ క్వశ్చన్ ఒక్కసారి మీరు అబ్జర్వ్ చేయండి. సో 4905/698. సో ఈ పర్టికులర్ ఆప్షన్స్ చూసినట్లయితే 6 పాయింట్స్, 7 పాయింట్, 8 పాయింట్, 9 పాయింట్ అన్నిటికీ చాలా డిఫరెన్సెస్ ఉన్నాయి. ఐ రైట్? సో ఇది మీరు క్యాల్కులేషన్ పార్ట్లో మీరు చూసినట్లయితే దీన్ని మనం కంప్లీట్గా 7ని కాసేపు అజ్యూమ్ చేసుకోవచ్చు. 698 or 700 or 7 వాట్ ఎవర్ ఇట్ మే. అండ్ దీన్ని నేను 4900గా అజ్యూమ్ చేసుకోవచ్చు. ఐ రైట్? 4900 గాను, దీన్ని 700 గాను అప్రాక్సిమేషన్. నా this two zeros gets cancelled. So 7 ones, it is 7. So 7 points. Exactగా ఇది 7 points మనకు రావచ్చు. 7 points. I mean ఇది 6 point లో కాకపోయినా 7sలో రావచ్చు. సో డెఫినెట్గా ఇది 700 కంటే ఈ వాల్యూ తక్కువే ఉంది అండ్ ఇది 4900 కంటే ఎక్కువే ఉంది. సో డెఫినెట్గా ఇక్కడ 6 పాయింట్ రావడానికి ఛాన్స్ లేదు, 7.0 లేదు, 7 పాయింట్ రావడానికి ఛాన్సెస్ ఉంది. ఆల్రైట్, నా ఇదొక బేసిక్ క్యాల్కులేషన్. నా ఈ ఆప్షన్స్ మీరు చూసినట్లయితే ఇట్ ఈస్ ఈజీ ఫర్ అస్. ఫస్ట్ ఆప్షన్ 6 పాయింట్ and second option 7 point, third option is 8 point, fourth option is 9 point. So obviously ఈ పర్టికులర్ ఆప్షన్స్ మనకి క్యాల్కులేషన్ ఈజీ చేసింది. జస్ట్ బికాస్ బై సీయింగ్ దిస్ ఇట్ సెల్ఫ్ వీ కెన్ సే దిస్ ఇస్ 7 point. ఆల్రైట్, సో 6ని 8ని 9ని ఆటోమేటిక్గా ఎలిమినేట్ చేయొచ్చు, ఎందుకంటే 49/7 వీ నో దట్ ఇట్ ఇస్ 7/7. ఆల్రైట్, నా ఇదే మీరు సెకండ్ సెట్ ఆఫ్ ఆప్షన్స్ మీరు చూసుకున్నట్లయితే అన్ని 7 పాయింట్స్లోనే ఉంది. సో అన్ని 7 పాయింట్స్లోనే ఉండేటప్పుడు ఫర్ ఎగ్జాంపుల్ ఇక్కడ మనం అప్రాక్సిమేషన్ వాల్యూ మనం చేయలేం. Alright, in such case we need to do the division. In the sense 4905 divided by 698 మీరు ఎగ్జాక్ట్గా డివిజన్ చేసి ఫైనల్గా వచ్చే కోషియంట్ని మాత్రమే మీరు చూస్ చేసుకోగలుగుతారు. ఐ మీన్ అది 7.0709 1 ఉండొచ్చు, లేదు 7.02 ఉండొచ్చు, 7.03 ఉండొచ్చు, 7.04 ఉండొచ్చు. ఐ హోప్ యూ అండర్స్టాండ్ దిస్. సో ఈ మీ క్యాల్కులేషన్స్ని మీ ఆప్షన్స్ మాత్రమే హార్డ్ చేయగలుగుతుంది. సో యాప్టిట్యూడ్లో ఎటువంటి క్వశ్చన్ అయినా మీ ఆప్షన్స్ని బేస్ చేసుకునే మీ యొక్క టైమింగ్ అనేది ఆధారపడి ఉంటుంది. సో I suggest you to go to the options first. Understand what is option A, options B, option C and option D. Please don't ignore. ఎంతసేపు మీరు క్వశ్చన్తో స్ట్రగుల్ అవుతుంటే మీ ఆప్షన్స్ 90% ఆఫ్ ద క్వశ్చన్స్ మీరు ఆప్షన్ని చూసే ఎలిమినేషన్ మెథడ్లో మీరు ఆన్సర్ చేయొచ్చు. am I right? సో ఇన్ సచ్ కేస్ ఇది మీరు చూసారు కదా, ఇది ఎందుకు ఎగ్జాంపుల్ చెప్పానంటే ద సేమ్ అప్లైస్ టు అనాలజీ హియర్. సో అనాలజీలో ఏ ఇస్ టు A and B డెఫినెట్గా ఒక రిలేషన్షిప్లో ఉంటుంది అన్నాను. అట్ ద సేమ్ టైం C and D అదే రిలేషన్షిప్లో ఉంటుంది. బట్ ఈ A and Bకి ఫస్ట్ మీరు రిలేషన్షిప్ ఫైండ్ అవుట్ చేసిన వెంటనే సికి అప్లై చేసి డి ఏంటి అనేది చెక్ చేసే ముందు కింద ఉన్న ఆప్షన్స్ ఏంటి అని చూడండి. సో ఆప్షన్స్ ఈజీ అంటే క్వశ్చన్ ఈజీ చేయాలంటే అన్ని మల్టిపుల్ ఆప్షన్స్ ఇస్తాడు, అంటే సంబంధమే లేకుండా ఆప్షన్స్ ఇస్తాడు. ఎలిమినేషన్ రూల్లో మీరు ఎగ్జాక్ట్గా అది ఏంటి అనేది ఫైండ్ అవుట్ చేయొచ్చు. ఒకవేళ క్వశ్చన్ని హార్డ్గా అడగాలి అనుకుంటే 4 ఆప్షన్స్ ఆల్మోస్ట్ సిమిలర్గా ఉంటుంది. అంటే ఒక ఆన్సర్ 100% కరెక్ట్, ఇంకొక ఆన్సర్ 90% సిమిలర్గా ఉంటుంది, ఇంకొక ఆప్షన్ 80% సిమిలర్గాను, ఇంకొక ఆప్షన్ సిమిలర్ 50 or 60% సిమిలర్గాను ఉంటుంది. సో దట్ టైమ్ you take at that particular time you'll be confused అంటే నేను ఆప్షన్ ఏది షూట్ చేసుకోవాలి. సో ఇన్ సచ్ కేస్ సో దీంట్లో మీరు వర్డ్స్ అనేది ఒకాబులరీ ఆన్ డైలీ బేసిస్ మీకు ఇంగ్లీష్ కమ్యూనికేషన్ మీ యాప్టిట్యూడ్ ఎంత ముఖ్యమో మీ కమ్యూనికేషన్ స్కిల్స్ ఇంప్రూవ్మెంట్ కూడా అంతే ముఖ్యం. సో ఇన్ సచ్ కేస్ ఇలాంటి టాపిక్స్ మీరు రీజనింగ్లో వర్బల్ రీజనింగ్ సాల్వ్ చేసేటప్పుడు యూ హ్యావ్ టు బీ మోర్ కాషియస్. Okay, more cautious and try to learn as much as vocabulary you can. It really helps you to crack the examination. And ee vocabulary anedi meek in fact so question edanna let's say for example edanna complicated terminology వచ్చేటప్పుడు కూడా మీకు వచ్చినప్పుడు కూడా మీకు ఈజీగా ఉంటుంది సాల్వ్ చేయడానికి. ఆల్రైట్, నా సో ఇది అర్థమైంది కదా. A is to B, C is to D, A is to A and B కి ఏ రిలేషన్షిప్ ఉందో అది ఫైండ్ అవుట్ చేసి అది మనం Cకి అప్లై చేసి అండ్ దెన్ C నుండి ఆ D అనేది ఏంటి అనేది మనం ఫైండ్ అవుట్ చేసాం. సో బిఫోర్ వి గెట్ ఇన్ టు ద ప్రాక్టీస్ క్వశ్చన్స్ లెట్ మీ ట్రైన్ యూ పీపుల్ ఆన్ సర్టెన్ vocabulary. కొన్ని మీకు నేను హెల్ప్ చేస్తాను, కొన్ని రిలేషన్షిప్స్ నేను మీకు ఎక్స్ప్లెయిన్ చేస్తాను. ఆల్రైట్, జస్ట్ నోట్ డౌన్ ఫస్ట్ వన్. Alright, it's going to be study and relationship. Let's say for example, study and the topic relationship అనేది చూసుకుందాం. Study and topic relationship ఏంటి ఎలా ఉంటుంది. Alright, so let's see. దీంట్లో సో నేను మీకు చెప్పినట్లు ఈ A, B, C, ఈ D అనే టర్మ్ ఫోర్త్ టర్మ్ని మీరు ఫైండ్ అవుట్ చేయాలి. ఆల్రైట్, ఈ స్టడీ అండ్ టాపిక్ అనే ఈ స్టడీ అండ్ టాపిక్ రిలేషన్షిప్ సాల్వ్ చేయాలంటే ఫస్ట్ థింగ్ ఒక బేసిక్ ఎగ్జాంపుల్ నేను మీకు చెప్తాను. వెరీ వెరీ బేసిక్ ఎగ్జాంపుల్. లెట్స్ సే ఐఎమ్ గోయింగ్ టు స్టార్ట్ విత్ ఎర్త్. ఇట్స్ ప్లానెట్. ఎర్త్, ప్లానెట్ and moon question mark. So it's a very basic example. I repeat this: earth, planet, moon question mark. ఇదే మీ అనాలజీ క్వశ్చన్. సో దీంట్లో నేను ఆప్షన్స్ మీకు ఇవ్వట్లేదు, ఫస్ట్ క్వశ్చన్ కాబట్టి. సో ఐ వాంట్ యూ పీపుల్ టు గెస్. ఇట్ ఈస్ సో సింపుల్. సో ఎర్త్, మూన్ ఎర్త్, ప్లానెట్, మూన్ క్వశ్చన్ మార్క్ కదా. దీన్ని మీరు సాల్వ్ చేసే ముందు ఫస్ట్ ట్రై టు అండర్స్టాండ్ వాట్ ఈస్ ద రిలేషన్షిప్ బిట్వీన్ దిస్ ఎర్త్ అండ్ ప్లానెట్. సో మన సోలార్ సిస్టంలో ట్రై టు అండర్స్టాండ్ మన సోలార్ సిస్టంలో ఎర్త్ ఏంటి? ఎర్త్ ఇస్ అ ప్లానెట్. ఐ రైట్? సో వీనస్, మార్చ్, ఎర్త్, జూపిటర్, యురేనస్ ఆల్ ఇవన్నీ ఏంటంటే ఇట్స్ అ ప్లానెట్. సో ఇక్కడ ఒక సోలార్ సిస్టంలో ఎర్త్ యొక్క నేమ్ ఏంటి, దాని యొక్క పర్టికులర్ స్పెసిఫికేషన్ ఏంటి అంటే ఇట్స్ అ ప్లానెట్. మరి సన్ అనేది ఏంటి అంటే ఇట్స్ అ స్టార్. రిమెంబర్, సన్ ఇస్ నాట్ అ ప్లానెట్, సన్ ఇస్ అ స్టార్. సో ఇట్స్ అ వెరీ బేసిక్ థింగ్. అండ్ మరి మూన్ ఏమవుతుంది అంటే మూన్ ఇస్, సో ఎర్త్ అనేది మన సోలార్ సిస్టంలో ప్లానెట్ అయితే మూన్ అనేది ఏమవుతుంది? శాటిలైట్. Alright, so moon is it's a satellite. It's a natural satellite. It's not an artificial satellite. It's satellite. So sun, earth అనేది planet అయితే moon అనేది satellite అవుతుంది. So this is the example of analogy. Okay, so ఇలాంటి అనాలజీ క్వశ్చన్స్ని మీరు సాల్వ్ చేయాలంటే మీరు చాలా బుక్స్ చదవాల్సి ఉంటుంది, చాలా vocabulary నేర్చుకోవాల్సి ఉంటుంది. వాటిల్లో కొన్ని రిలేషన్షిప్స్ మాత్రం నేను మీకు ఇప్పుడు ఎక్స్ప్లెయిన్ చేస్తాను. ఆ కొన్ని రిలేషన్షిప్స్ ఏంటి అనేది చూద్దాం. ఇన్ ద సెన్స్ ఐఎమ్ గోయింగ్ టు ఎక్స్ప్లెయిన్ ఏ అండ్ బి మాత్రం నేను మీకు చెప్తాను. సి అండ్ డికి నేను వెళ్ళట్లేదు. సి అండ్ డి అంటే క్వశ్చన్స్లోకి వచ్చేస్తుంది. ఏ అండ్ బి అంటే లెట్స్ సే 2 టర్మ్స్ ఇస్తే వాటి మధ్యలో రిలేషన్షిప్స్ ఎలా ఉంటుంది, ఆ రిలేషన్షిప్స్ని ఎలా ఫైండ్ అవుట్ చేయాలి అనేది నేను ముందే మీకు ఇస్తున్నాను. అంటే ఇవి ఏంటి అంటే ప్రీవియస్ ఇయర్ క్వశ్చన్ పేపర్స్ నుంచి కామన్గా అడిగే రిలేషన్షిప్స్ని నేను మీకు ఎక్స్ట్రాక్ట్ చేసి అది వరకు ఈరోజు నేను చెప్తున్నాను. ఆల్రైట్, లెట్స్ స్టార్ట్ విత్ స్టడీ అండ్ టాపిక్ రిలేషన్షిప్. సో స్టడీ అండ్ టాపిక్ రిలేషన్షిప్ ఏమొస్తుంది? ఆల్రైట్, ద ఫస్ట్ వన్, లెట్స్ స్టార్ట్ విత్ సర్టెన్ ఎగ్జాంపుల్. స్టడీ అండ్ టాపిక్ రిలేషన్షిప్ మీరు చూసినట్లయితే ఫస్ట్ థింగ్ లెట్స్ సే బాటనీ. సో మీ సబ్జెక్ట్స్ నుంచి చూద్దాం. ఇట్స్ లైక్ స్టడీ అండ్ టాపిక్ రిలేషన్షిప్. స్టడీ అండ్ టాపిక్ రిలేషన్షిప్ వీటిలో కామన్గా అడిగే క్వశ్చన్స్ కొన్ని ఇంపార్టెన్స్ మీకు చెప్తాను. సో వాట్ ఇస్ బాటనీ? సో బాటనీ అంటే ఏంటి? సో బాటనీ ఇస్ నథింగ్ బట్ ద స్టడీ ఆఫ్ ప్లాంట్స్. రిమెంబర్ బాటనీ ఇస్ నథింగ్ బట్ ద స్టడీ ఆఫ్ ప్లాంట్స్. సో ఈ బాటనీ ప్లాంట్స్ అని చెప్పి మీరు ఈ రెండు కీవర్డ్స్ చూసినట్లయితే ఈ సి అండ్ డి ఏదన్నా ఉన్నాయి ఇక్కడ, ఈ సి అండ్ డి అనేది మీకు అనవసరం. ఎందుకంటే ఈ రెండు వర్డ్స్ ఫస్ట్ మీరు రిలేషన్షిప్ ఫైండ్ అవుట్ చేసినట్లయితే ఈ సి అండ్ డి మీరు ఆటోమేటిక్గా ఆన్సర్ తీసుకొచ్చేస్తారు. సో స్టడీ అండ్ టాపిక్ రిలేషన్షిప్లో ఫస్ట్ థింగ్ నేను మీకు ఎగ్జాంపుల్ ఏమి ఇస్తాను అంటే బాటనీ అండ్ ప్లాంట్స్ అనేది మీకు ఇచ్చారు అంటే యూ నీడ్ టు అండర్స్టాండ్ ఇట్స్ నథింగ్ బట్ సో దిస్ ఇస్ ద టాపిక్ అండ్ దిస్ ఇస్ ఆల్ అబౌట్. సో స్టడీ ఆఫ్ ప్లాంట్స్ ఇస్ నథింగ్ బట్ బాటనీ. ఈ పర్టికులర్ ప్లాంట్స్ గురించి మీరు చదివేదాన్ని మనం ఏమంటాం, బాటనీ అంటాం. ద సేమ్ థింగ్ ఎథ్నాలజీ, దర్ ఇస్ సంథింగ్ కాల్డ్ ఎథ్నాలజీ, రైట్. సో ఎథ్నాలజీ అనేది ఏంటి అని చూసినట్టయితే మీరు హ్యూమన్ రేసెస్, రైట్, హ్యూమన్ రేసెస్. సో ఫర్ ఎగ్జాంపుల్ ఈ రెండు వర్డ్స్ ఇచ్చాయి. సో ఎథ్నాలజీ, హ్యూమన్ రిసోర్సెస్ అని ఇస్తే సో ట్రై టు అండర్స్టాండ్ ఈ హ్యూమన్ రేసెస్ గురించి మీరు చదవడాన్ని, ఐ మీన్ దట్ పర్టికులర్ టాపిక్ ఇస్ నథింగ్ బట్ ఎథ్నాలజీ. సో మీకు క్వశ్చన్ ఎలా ప్లాన్ చేయొచ్చు, మీరు బాటనీ ప్లాంట్స్, రైట్, రిపీట్, బాటనీ ప్లాంట్స్ ఎథ్నాలజీ అని ఇస్తారు. సో బాటనీ ప్లాంట్స్ ఎథ్నాలజీ ఇస్ టు క్వశ్చన్ మార్క్. దెన్ యూ నీడ్ టు అండర్స్టాండ్ బాటనీ ప్లాంట్స్ అంటే ఈ ప్లాంట్స్ గురించి చదవడం ఎథ్నాలజీ. సో ఎథ్నాలజీ అంటే సో ఎథ్నాలజీ అనేటప్పుడు దేని గురించి చదువుతున్నారు, హ్యూమన్ రేసెస్ గురించి. అండ్ దీంట్లో ప్లాంట్స్, బాటనీ అండ్ బాటనీ ప్లాంట్స్ ఏ ఆర్డర్లోనో ఇవ్వచ్చు, ఆల్ రైట్. ఇన్ ద సెన్స్ బాటనీ ప్లాంట్స్ అన్నప్పుడు సో ఏమవుతుంది, ఇది టాపిక్ అవుతుంది, ఇది ఐ మీన్ దేని గురించి చదువుతున్నారు అవుతుంది, ఇది దాని పర్టికులర్ టాపిక్ అవుతుంది, అవునా. ఇప్పుడు దీంట్లో ప్లాంట్స్ బాటనీ అని ఇచ్చినప్పుడు మీకు ఏమవుతుంది, ఇక్కడ హ్యూమన్ రేసెస్ అని ఇస్తారు. ప్లాంట్స్ గురించి చదవడం బాటనీ అయితే ఐ మీన్ హ్యూమన్ రేసెస్ గురించి చదవడం ఏంటి, ఎథ్నాలజీ. సో ఇలా అడగచ్చు, రివర్స్లో కూడా అడుగుతారు. ఆల్ రైట్, నెక్స్ట్ చూడండి otology. O-T-O-L-O-G-Y. What does it mean by otology? So otology is nothing but the study of eggs. Otology is nothing but the study of eggs. And then mycology. So it's like study of fungi. So ilantivi మీరు కొన్ని బేసిక్ వాటివి తెలుసుకుంటే it would be so easy for you to understand, you know, the concept. సో ఇవే ఈ 4 ఎగ్జాంపుల్స్తో పాటు క్లోజ్ చేయమని చెప్పి నేను చెప్పట్లేదు. సో ఇలాంటివి మీరు ఇంకొన్ని వర్డ్స్, బేసిక్ వర్డ్స్ అన్నీ నేర్చుకోవాల్సి ఉంటుంది. ఫర్ ఎగ్జాంపుల్ ఆస్ట్రాలజీ. సో astrology, for example, astrology is like study of what, your future, your prediction. Am I right? Astrology is nothing but study of prediction. The same thing, like let's say if I say aeronautics, so aerospace engineering. So aerospace engineering is study of what? So aeroplanes and the engineering, exactly. So this is how it works. So if I say computer science engineering, so మీరు ఏం చేయాలంటే ఈ స్టడీ అండ్ టాపిక్ రిలేషన్షిప్ హెడ్డింగ్ కింద ఇలాంటి కొన్ని రాసి నోట్ చేసి పెట్టుకుంటే ఇట్ వుడ్ బి ఈజీ ఫర్ యూ టు రెఫర్ ఇన్ ద ఫ్యూచర్. ఆల్ రైట్, నెక్స్ట్ మనం చూసినట్లయితే వర్కర్ అండ్ టూల్ రిలేషన్షిప్ అనేది చూద్దాం. సో వర్కర్ అండ్ టూల్ రిలేషన్షిప్ మీద కూడా మీకు ఎక్కువ క్వశ్చన్స్ వస్తాయి. ఫర్ ఎగ్జాంపుల్ వర్కర్ అండ్ టూల్ రిలేషన్షిప్, worker and tool relationship. సో దీంట్లో క్వశ్చన్స్ ప్రాక్టీస్ చేయడం అనేది ఇంపార్టెంట్ కాదు. రిమెంబర్, ఈ రిలేషన్షిప్స్ని నేర్చుకోవడం మాత్రమే మీకు ఇంపార్టెంట్. సో ఇలాంటి పర్టికులర్ థింగ్ అనేది మీరు నేర్చుకోవాలి. సో వాట్ ఇస్ దిస్ వర్కర్ అండ్ టూల్? ఆల్ రైట్, సో ఫర్ ఎగ్జాంపుల్ గార్డనర్ అని నేను మీకు చెప్తున్నాను. ఆల్ రైట్, గార్డనర్. సో గార్డనర్ అంటే ఎవరు? So gardener, we all know that it's like, you know, the person who takes care of the garden. Am I right? So the person who takes care of the garden. So in such case, what we call, so gardener అనేది worker. Gardener అనేది ఒక మనిషి, అవునా? So this particular person works with which kind of tool అనేది మీకు తెలియాలి. So gardener works with a harrow. హ్యారో అనేది మీరు చూసినట్లయితే సో ఇట్స్ లైక్ యూనో ఒక స్పైక్స్ ఉన్న ఒక మెషిన్ లా ఉంటుంది. మొత్తం యూనో ఆ సర్ఫేస్ మొత్తం క్లీన్ చేయడానికి, నీట్ చేయడానికి, ఓకే, ఒక గార్డెనింగ్ చేయడానికి యూజ్ చేసే ఒక టూల్ అది. ఆల్రైట్, ఇట్ హ్యాస్ సమ్ స్పైక్స్ కైండ్ ఆఫ్ మీకు ఇలా ఉంటుంది. ట్రాక్టర్స్ వెనుక మీరు చూస్తారు దున్నడానికి అని చెప్పి అంటాం. ఇట్స్ అ కైండ్ ఆఫ్ స్పైక్స్ లాగా ఉంటుంది. అది హ్యాండ్ టూల్ వస్తుంది, పెద్ద మెషిన్స్ కూడా వస్తున్నాయి. సో గార్డనర్ అనేది తన యూజ్ చేసే టూల్ ఏంటి అంటే మెయిన్గా ఇట్స్ లైక్ హ్యారో. అండ్ లెట్స్ సే ఫర్ ఎగ్జాంపుల్ టైలర్. సో టైలర్ అనే అతను, సో టైలర్ ఏం చేస్తాడు, ఏ పర్టికులర్ యూనో టూల్తో యూజ్ చేస్తాడు అనేది మనకు తెలియదు. సో టైలర్ ఇస్ ఆబ్వియస్లీ నీడిల్. టైలరింగ్ మిషన్ అంటారు, బట్ నీడిల్. ఆల్ రైట్, అండర్స్టాండ్? సో ఇట్స్ నీడిల్. అండ్ దెన్ ఇఫ్ యూ అబ్జర్వ్ యూనో సోల్జర్. సో సోల్జర్, సో ఒకసారి మీరు చూసినట్లయితే సోల్జర్ అనే అతను దేంట్లో మీరు ఐ మీన్ ఏం యూజ్ చేస్తాడు, టూల్ ఏంటి? సో సోల్జర్ అనే అతను వర్కర్ అయినప్పుడు సో టూల్ ఏమవుతుంది అనేది మీరు చెక్ చేయాలి. సో టూల్ ఏమవుతుంది ఇక్కడ? ఆబ్వియస్లీ అయితే సోల్జర్ అనే అతను టూల్ ఏంటి, ఇక్కడ గన్ అని మీరు గుర్తుపెట్టుకున్నా ఓకే, లేదు అంటే ఫర్ ఎగ్జాంపుల్ వెపన్ అని నోట్ చేసుకున్నా మీకు ఓకే. రిమెంబర్, గన్ అని మీరు నోట్ చేసుకున్నా ఓకే, లేదంటే వెపన్ అని మీరు నోట్ చేసుకున్నా ఓకే. సో నో నీడ్ టు వరీ అబౌట్. ఆల్రైట్, నెక్స్ట్ మీరు చూసినట్లయితే టూల్, నెక్స్ట్ థింగ్, అండ్ దెన్ tailor, needle, gardener, and it's like harrow, and then soldier, gun, doctor. Let's say for example doctor. So doctor అనే అతను ఒక పర్సన్ అయితే, ఐ మీన్ ఒక వర్కర్ అయితే, తన టూల్ యూస్ చేసే టూల్ ఏముంటుంది, ఇట్ ఇస్ స్టెథోస్కోప్. సో ఇలాంటి రిలేషన్షిప్ ఉన్న వర్డ్స్ అన్ని మీరు తీసి పెట్టుకోవాలి, ఐ మీన్ నోట్ చేసి పెట్టుకుంటే వర్కర్ అండ్ టూల్ అనే రిలేషన్షిప్ మీకు యూజ్ అవుతుంది. నెక్స్ట్ మీరు చూసినట్లంటే వర్కర్ అండ్ ప్రోడక్ట్ రిలేషన్షిప్. వర్కర్ అండ్ ప్రోడక్ట్ అంటే ఫర్ ఎగ్జాంపుల్ ఒక పర్సన్ వర్క్ చేసిన తర్వాత దాని యొక్క అవుట్పుట్ ఎలా కనెక్ట్ చేయాల్సి ఉంటుంది. ఓకే, సో వర్కర్ అండ్ ప్రోడక్ట్ రిలేషన్షిప్, వర్కర్ అండ్ ప్రోడక్ట్ రిలేషన్షిప్, వీటి మీద కూడా క్వశ్చన్స్ రావడానికి ఛాన్స్ ఉంటుంది. వర్కర్ అండ్ ప్రోడక్ట్ రిలేషన్షిప్, worker and product relationship. For example, so worker and product ante, let's say I'll start with poet. Okay, poet. So poet, kavi, avuna. So poet yokka product em untundi, it is poem. Poet yokka product em untundi, so tana yokka product, tana work chesin tarvata vache output ఏ product ante it's poem. Now if you start with hunter అని తీసుకుందాం. హంటర్, వేటగాడు. సో వేటగాడు యొక్క ప్రోడక్ట్, ఫైనల్ ప్రోడక్ట్. సో హంటర్ హీ యూజువలీ హంట్స్ ఆబ్వియస్లీ. సో హంటర్కి ఏది కనెక్ట్ అవుతుంది, ప్రోడక్ట్ ఏంటి అని చెప్తే, హంటర్ అనేవాడు ఫుడ్ కాదు. సో దర్ ఇస్ అ లాట్స్ ఆఫ్ డిఫరెన్స్ బిట్వీన్ ఫుడ్ అండ్ దెన్ ప్రే. ఓకే, హంటర్ ఇస్ కనెక్టెడ్ టు ప్రే. ఓకే, హంటర్ ఫుడ్, ఐ మీన్ హంటర్ అనేది ఫుడ్కి కనెక్ట్ చేయాలా, ప్రేకి కనెక్ట్ చేయాలంటే ప్రేకి మాత్రమే కనెక్ట్ చేయాలి. ఫుడ్ ఇస్ కంప్లీట్లీ డిఫరెంట్. ఫుడ్ అనేది మనం ఏమని చెప్తామంటే ఇట్స్ లైక్ విచ్ ఇస్ రెడీ టు ఈట్. అవునా, సో హంటర్, వేటగాడు అనేది ఆ పర్టికులర్ ఏదో ఒక వేటాడి ఒక పర్టికులర్ ఒక జంతువుని చంపి తీసుకొచ్చేది ఏమవుతుందంటే ఫుడ్ అవ్వదు, అది ప్రే మాత్రమే అవుతుంది. ఓకే, ఆ ప్రే అనేదాన్ని కుక్ చేస్తే మాత్రమే అది ఫుడ్ రూపంలో కన్వర్ట్ అవుతుంది. సో ఇన్ సచ్ కేస్ హంటర్ అనేది ప్రేకి కనెక్ట్ అవుతుంది. ఆల్రైట్, నెక్స్ట్ వన్ లెట్స్ సే టైలర్. సో ఇందులో ఇందాక మనం చూసినట్లయితే వర్కర్ అండ్ టూల్ రిలేషన్షిప్లో టైలర్ చూసాం. దీంట్లో చూడండి వర్కర్ అండ్ ప్రోడక్ట్లో చూసాం. టైలర్ యొక్క అవుట్పుట్ ఏముంటుంది, క్లోత్స్. టైలర్ యొక్క అవుట్పుట్ మీరు చూసినట్లయితే ఇట్ ఇస్ క్లోత్స్. ఆల్ రైట్, నెక్స్ట్ ఫార్మర్, ఇట్స్ అ కైండ్ ఆఫ్ ఇట్లా వెళ్తూనే ఉంటుంది వర్డ్స్ చూసినట్లయితే. సో ఇవన్నీ మీరు నోట్ చేసుకోవాల్సి ఉంటుంది, ఐ మీన్ జస్ట్ జనరల్ నాలెడ్జ్. సో చాలా బుక్స్ చదవండి అండ్ దెన్ అనాలజీకి సెపరేట్ బుక్స్ ఉన్నాయి. ఆల్రైట్, ఈ ప్రాక్టీస్ కంటే ఫస్ట్ ఈ రిలేషన్షిప్ ఉన్న వర్డ్స్ అనేది ఎక్కువ మీరు నేర్చుకోవాలి. సో వర్కర్ అండ్ ప్రోడక్ట్ పైన ఏమేమి ఉంటాయి అనేది మీరు ఒకసారి చెక్ చేసుకోవాల్సి ఉంటుంది. ఆల్రైట్, నౌ లెట్స్ సే యానిమల్ అండ్ యంగర్ వన్స్ అనేవి రిలేషన్షిప్ మీద ఎలా ఉంటాయి అనేది చూద్దాం. యానిమల్ అండ్ యంగర్ వన్స్. సో యానిమల్ అండ్ యంగర్ వన్స్. సో ఇవన్నీ మీరు స్కూల్ డేస్లో చదివిన ఒక టాపిక్స్. యానిమల్ అండ్ యంగర్ వన్స్ అంటే యానిమల్స్ అడల్ట్ ఏజ్లో వాటికి ఒక నేమ్స్. రిమెంబర్, యానిమల్స్ అడల్ట్ ఏజ్లో వాళ్ళకి ఒక నేమ్స్ అండ్ అది యంగ్ అంటే చిన్నప్పుడు ఉన్నప్పుడు వాళ్ళకి కొన్ని నేమ్స్ ఉంటాయి. చాలా యానిమల్స్కి ఉంటుంది. ఆల్రైట్, ఫర్ ఎగ్జాంపుల్ హ్యూమన్ బీయింగ్సే మీరు తీసుకోండి. ఆల్రైట్, హ్యూమన్ బీయింగ్స్కి ఏజ్ తగ్గట్టు మనం దాన్ని నేమ్ మార్చుకుంటూ వెళ్తాం. ఫర్ ఎగ్జాంపుల్ ఇన్ఫాంట్ అంటాం. ఇన్ఫాంట్ ఇస్ నథింగ్ బట్ ఇన్ఫాంట్స్ లైక్ 3 years బిలో కిడ్స్ని, చాలా చిన్న ఏజ్లో 0 to 3 years అనేది ఇన్ఫాంట్స్ అంటాం. అండ్ దెన్ ఒక సర్టన్ ఏజ్ వరకు till 16 we call them as child, and after that after 16 years 16 to 25 adult, 16, 25 or 30 adult అని చెప్పి ఇలా ఐ మీన్ బాయ్. ఫర్ ఎగ్జాంపుల్ చిన్న పిల్లాడు అయితే బాయ్ అండ్ చిన్న అమ్మాయి అయితే విల్ కాల్స్ గర్ల్. అండ్ దెన్ ఫర్ ఎగ్జాంపుల్ ఆఫ్టర్ సమ్ టైమ్ మెన్, విమెన్, ఇలా మల్టిపుల్ థింగ్స్ ఉంటుంది. సో ఇప్పుడు యానిమల్స్కి ఎలా ఉంటుంది అనేది మనం చెక్ చేసుకోవాలి. సో యానిమల్స్ చూసినట్లయితే లెట్స్ స్టార్ట్ విత్ స్పైడర్. సో ఈ వర్డ్స్ అని మీకు కొత్తగా ఉండొచ్చు. ఆల్రైట్, బట్ ఐ రిక్వెస్ట్ యూ పీపుల్ టు లెర్న్ ఆల్ దిస్ యానిమల్స్ థింగ్. సో స్పైడర్. సో స్పైడర్ అంటే ఇట్స్ అడల్ట్ ఇస్ కాల్డ్ అ స్పైడర్, అంటే బాగా గ్రోన్ అప్ వన్ ఇస్ కాల్డ్ అ స్పైడర్. సో వాట్ ఇస్ అడల్ట్ ఇస్ కాల్డ్ అస్ అ స్పైడర్. దాని యొక్క చిన్నతనంలో దాన్ని ఏమని చెప్పి పిలుస్తారు? ఇట్ ఇస్ సో సింపుల్, స్పైడర్లింగ్. సో ఇట్ ఇస్ స్పైడర్లింగ్. ద సేమ్ థింగ్, లెట్స్ స్టార్ట్ విత్ పిగ్. సో పిగ్ యొక్క యంగ్ స్టేజ్లో దాన్ని ఏమని పిలుస్తారు, దానికి ఒక నేమ్ ఉంది విచ్ వీ టు కాల్ ఇట్ అస్ పిగ్లెట్. ఆల్రైట్, నా లెట్స్ గో విత్ కవ్. కవ్ ఇస్ కాఫ్. Cow is calf. And see, we still have some, ఈ కాఫ్ అనేటప్పుడు చాలా స్టూడెంట్స్ కన్ఫ్యూజ్ అయ్యేది ఏంటి అంటే, సో ఈ పర్టికులర్ ప్రొనౌన్సియేషన్కి కన్ఫ్యూజ్ అవుతారు. ఇది కాఫ్ అండ్ COUGH, దీన్ని కాఫ్ అని పిలుస్తాం. ప్లీజ్ ట్రై టు అండర్స్టాండ్, కాఫ్ ఇస్ whenever you say calf, it is CALF is calf. అంటే కవ్కి మాత్రమే కాదు, చాలా అనిమల్స్కి కూడా కాఫ్ అనేది వాటి యంగర్ వన్స్ మనం పిలుస్తాం. దెన్ COUGH, it's not calf, it is cuff. Alright, the syrup what we drink when we get the cough is nothing but cough syrup, it's not cough syrup. So same thing here, if మీరు cough అంటే CALF అనేది వస్తుంది అంటే cough. Okay, and cough కాదు, it's completely different. Cough is CALF, cough means COUGH. So here it is cough. Alright, next మనం చూసినట్లయితే let's say let's start with tiger. So the younger one. So tiger is adult one. Am I right? So how we call small before we get into tiger, let's think about horse. So horse అనేది చాలా ఇంపార్టెంట్. ఇది ఫ్రీక్వెంట్ గా ఆస్క్ క్వశ్చన్స్ లో ఉంటుంది. సో horse is nothing but pony. Horse is nothing but pony. All right. So horse అనేది ఒక అడల్ట్, ఒక అడల్ట్ ఫుల్లీ గ్రోన్ అప్ వన్ ని మనం వి కాల్ ఇట్ అస్ హార్స్. బట్ స్మాల్ యంగ్ చిన్న హార్సెస్ మీరు చూసినట్లయితే ఇట్ ఇస్ యాక్చువల్లీ పోనీ. అండ్ దెన్ నౌ టైగర్. సో టైగర్ యొక్క యంగర్ వన్స్ మీరు చూసినట్లయితే ఇట్ ఇస్ టైగర్ ఇస్ ద గ్రోన్ అప్ వన్ అండ్ cub is the smaller one. Alright, tiger is the younger one and cub is the smaller one. So you need to understand the relationship between these words and also animal and younger ones ni practice cheyandi. And then we need to understand male and female. So male and female we know it for మేల్ అండ్ ఫీమేల్ హ్యూమన్ బీయింగ్స్కి మాత్రమే మనం చెప్తాము, యానిమల్స్కి కూడా మేల్ అండ్ ఫీమేల్. సో మోస్ట్ ప్రాబబ్లీ ఇవన్నీ ఎగ్జామ్స్లో రిపీట్ అయ్యే క్వశ్చన్స్ మీరు చూసినట్టయితే మేల్ అండ్ ఫీమేల్. ఆల్రైట్, మేల్ అండ్ ఫీమేల్ రిలేషన్షిప్. మేల్ అండ్ ఫీమేల్. సో మేల్ అండ్ ఫీమేల్ రిలేషన్షిప్. సో మేల్ అండ్ ఫీమేల్ రిలేషన్షిప్లో మీరు చూసినట్లయితే ఫ్రీక్వెంట్లీ ఎలాంటి క్వశ్చన్స్ అడుగుతూ ఎలాంటి వాటి మీద ఉంటుందంటే, ఫర్ ఎగ్జాంపుల్ లెట్స్ స్టార్ట్ విత్ టైగర్. సో టైగర్ మనం ఇందాక చూసాం కదా. సో టైగర్ యొక్క ఫీమేల్ వర్షన్ ఏంటి? సో మనం యూజువల్గా డే టు డే బేసిస్లో ఇవన్నీ మనం యూజ్ చేయట్లేదు, బట్ వీ నీడ్ టు. సో కామన్గా మేల్ అయినా ఫీమేల్ అయినా వీ కాల్ దమ్ బై ద సేమ్ నేమ్ టైగర్, బట్ వీ హ్యావ్ అ సెపరేట్ నేమ్ ఫర్ దస్ విచ్ ఇస్ నథింగ్ బట్ tigress. So male and female. Tiger is male one and tigress is a female one. Let's go with lion. Lion is once again male. Male is nothing but a lion. Let's say what if you see a female one? So female one is a lioness. Now I'm going to same thing here, horse. Alright, horse once again it's a male one. Alright, what do you call a female horse? Most of us we don't know what is a female horse, which is nothing but mare. M-A-R-E, which is a female. Alright, horse is actually a male, mare is nothing but a female. Alright, let's go with stag. And stag, see this is a male one. And then what is a female one? First, what does mean by a stag? See, ఇది మీరు చాలా ప్లేసెస్లో చూడొచ్చు. కొన్ని పబ్స్ ఇలాంటి వాటి క్లబ్స్కి పబ్స్కి బయట వేసింటారు ఓన్లీ స్టాగ్ ఎంట్రీ నాట్ అలౌడ్, స్టాగ్స్ నాట్ అలౌడ్ ఇలాంటి బోర్డ్స్ మీరు చూడొచ్చు. అండ్ స్టాగ్స్ అనేది చాలా మీనింగ్స్ ఉన్నాయి, మల్టిపుల్ మీనింగ్స్ ఉన్నాయి. సో ఎగ్జాక్ట్గా వాట్ ఇస్ మీన్ బై స్టాగ్ అంటే ఇట్స్ యాక్చువల్లీ అ మేల్ డియర్. ఓకే, మగ జింక్ అని ఇట్స్ లైక్ కాల్డ్ యాజ్ అ స్టాగ్. బట్ వేర్ యాజ్ అండ్ అన్మ్యారీడ్ బ్యాచులర్ ని కూడా స్టాగ్ అని చెప్పి పిలవచ్చు. ఇట్స్ సెకండరీ అండ్ టెర్షరీ మీనింగ్స్ లో వస్తుంది, కలోకియల్ టర్మ్ అది. సో స్టాగ్ అంటే ఇట్స్ యాక్చువల్లీ అ మేల్ డియర్, బట్ వన్స్ అగైన్ బ్యాచులర్ ని స్టాగ్ గాను రిప్రజెంట్ చేస్తారు. స్టాగ్స్ నాట్ అలౌడ్ అంటే ఇట్స్ లైక్ అ గ్రూప్ ఆఫ్ మెన్ హు ఆర్ నాట్ మ్యారీడ్, అన్మ్యారీడ్ మెన్, లైక్ అ గ్రూప్ ఆఫ్ మెన్ ఇస్ ఆల్సో కాల్డ్ as a stag. And bachelor's party, very common word used nowadays. Bachelor's party, which is nothing but stag's party, that is okay. Stag is nothing but group of men and it వస్తుంది. Alright, so stag is a సో ప్రైమరీ మీనింగ్ చూసినట్లయితే స్ట్రాగ్ ఇస్ అ మేల్ వన్ అండ్ మగ జింక్ అవుతుంది. సో మేల్ డియర్ ఇట్ ఇస్. సో ఫీమేల్ ఇట్స్ కాల్డ్ అస్ డో. ఫీమేల్ వన్ ఇట్స్ కాల్డ్ అస్ డో. సో మేల్ అండ్ ఫీమేల్. ఆల్ రైట్. సో దిస్ ఇస్ హౌ ఇట్ వర్క్స్. సో ఇలాంటి వర్డ్స్ అనేది మీరు చాలా నేర్చుకోవాల్సి ఉంటుంది. ఈ వర్డ్స్ని బేస్ చేసుకొని మీకు రిలేషన్షిప్స్ అనేది అండ్ క్వశ్చన్స్ అనేది ఫామ్ అవుతుంది. సో నేను మీకు ఇప్పుడు కొన్ని క్వశ్చన్స్ మనం ప్రాక్టీస్కి చూస్తాం. ఆ క్వశ్చన్స్ ఏంటంటే లెట్స్ స్టార్ట్ విత్ ద ఫస్ట్ క్వశ్చన్. క్వశ్చన్ నెంబర్ 1. Question number 1, let's start with ఓకే. సో ఎంతసేపు రిలేషన్షిప్స్ చూసాం కదా, ఇప్పుడు కొన్ని ఎగ్జాంపుల్స్ చూద్దాం ఎలా వర్క్ అవుతుందని చెప్పి. సో బుల్లెట్ పాత్, అవునా? క్వశ్చన్ ఒకసారి చూడండి. బుల్లెట్ పాత్ ప్రొజెక్టైల్ క్వశ్చన్ మార్క్. సో ఇట్స్ అ ర్యాండమ్ ఎగ్జాంపుల్. ఓకే. సో బుల్లెట్ అనేది పాత్కి బుల్లెట్కి ఏంటి, ప్రొజెక్టైల్కి ఇస్తూ క్వశ్చన్ మార్క్ అనేది ఏంటి అని మనం చెక్ చేయాలి. సో ఇట్ ఈస్ సో సింపుల్. ఇఫ్ ద బుల్లెట్ ఇస్ బీయింగ్ ఫైర్డ్, లెట్స్ ఒక బుల్లెట్ ఫైర్ అయినప్పుడు, ట్రై టు అండర్స్టాండ్, ఒక బుల్లెట్ ఫైర్ అయినప్పుడు డెఫినెట్లీ ఇట్ ఫాలోస్ పర్టికులర్ పాత్. ఆల్రైట్. సో దీనికి ఒక పాత్ అంటాం. ఆల్రైట్. అట్ ద సేమ్ టైమ్ ఒక ప్రొజెక్టైల్ ఇస్ నథింగ్ బట్ అ కైండ్ ఆఫ్ మిసైల్. ఇది మిసైల్ అనేది లాంచ్ చేసినప్పుడు, రిమెంబర్ ఒక మిసైల్ అనేది లాంచ్ చేసినప్పుడు ఏమవుతుందంటే ఒక పర్టికులర్ పాత్ని అది ఇట్లా ఫాలో అవుతుంది. రైట్. ఒక మిసైల్ అనేది ఫైర్ అయినప్పుడు, మిసైల్ ఇస్ నథింగ్ బట్ ప్రొజెక్టైల్ అంటాం. దాని యొక్క పాత్ మీరు చూసినట్లయితే అది ఇలా ఒక పారాబోలిక్ షేప్ని తీసుకుంటుంది. దిస్ ఇస్ హౌ ఇట్ గోస్. సో ఇది పారాబోలిక్ షేప్ అనేది, దిస్ ఇస్ హౌ వీ కాల్ ఇట్. బట్ దర్ ఇస్ అ స్పెసిఫిక్ నేమ్ ఫర్ దట్ పారాబోలిక్ పాత్. ఇట్ ఇస్ నథింగ్ బట్ trajectory. Okay, remember this, trajectory. Projectile hyphen, it is trajectory. Trajectory in the sense, okay, a parabolic path ne manam trajectory ani తీసుకుంటాం. Remember this. Now next question. So next question, let's see another example. ఇంకోటి చూస్తాం. So ignore notice. So a example చూడండి. Ignore notice. Okay, ignore and then notice. Next, cordial. So ignore notice cordial question mark. What's going to be the answer? So first thing, let's understand what is the difference between ignore and notice. Alright, what is the relationship between ignore and notice? It is so simple. Ignore ante enti, pattichukokunda povodam. Notice ante danni pattinchukovodam, telusukovodam. Am I right? So this is nothing but antonym. Antonym ante it's an opposite. Am I right? So ignore యొక్క opposite ఏంటంటే notice. So cordial. సో కార్డియల్కి ఇక్కడ ఏంటి, సేమ్ థింగ్, యాంటనిమ్ అప్లై చేయాలి. అంటే ఆపోజిట్ అనేది మీరు చెక్ చేయాల్సుకోవాల్సి ఉంది. సో ఫస్ట్ థింగ్, వెన్ ఎవర్ యూ సీ ద క్వశ్చన్స్, ఆ రిలేషన్షిప్ని మనం చూసినట్లయితే మనం ఎగ్జాక్ట్గా ఏది అని చెప్పి ఫైండ్ అవుట్ చేయొచ్చు. సో ఇగ్నోర్ నోటిస్ కార్డియల్ అంటే ఏంటి. సో ఫస్ట్ థింగ్, ఇది మీకు సాల్వ్ చేయాలి అంటే కార్డియల్ అనే ఏంటి అనేది మీకు తెలియాలి. కార్డియల్ అంటే సో సింపుల్, మీరు వెడ్డింగ్ ఇన్విటేషన్స్లో మీరు చూడొచ్చు, రిక్వెస్ట్ వి కార్డియలీ ఇన్వైట్ యూ, ఇన్ ద సెన్స్ లైక్ హంబ్లీ. ఆల్ రైట్. సో మనం రిక్వెస్ట్ చేసి పిలిచేటప్పుడు వీ యూజ్ సర్టెన్ వర్డ్స్ కాల్డ్ కార్డియలీ. మీరు ఏ వెడ్డింగ్ ఇన్విటేషన్స్ చూసినా వీ కార్డియలీ ఇన్వైట్ యూ అనే వర్డ్ ఉంటుంది. సో దానికి ఆపోజిట్ ఏంటి? ఆల్ రైట్, కార్డియలీ యాంటనిమ్ మీన్స్ ఇట్స్ ఆపోజిట్. సో ఇగ్నోర్ ఆపోజిట్ నోటీస్. సో కార్డియల్కి ఆపోజిట్ ఏంటి? ఇట్ ఈస్ నథింగ్ బట్ హాస్టైల్. హాస్టైల్ అంటే మీకు తెలుసు, యూజువల్గా హోస్టైల్స్ అంటే ఏంటంటే, ఫర్ ఎగ్జాంపుల్ మీకు ఫ్లైట్ హైజాగ్ అయింది, అప్పుడు లోపల కూర్చునే ప్యాసింజర్స్ని హోస్టైల్స్ అంటారు. అంటే లైక్ బానిసత్వం లాగా మిమ్మల్ని కూర్చోబెట్టి టార్చర్ చేయడాన్ని, ఒక ప్లేస్లో మిమ్మల్ని తగులుకొని మీరు బానిసత్వం వహించడం దాన్ని ఏమంటారు అంటే హాస్టైల్ అంటారు. సో కార్డియల్ అంటే రిక్వైల్, హంబుల్ అనేది దానికి ఆపోజిట్ అంటే హాస్టైల్, అంటే టార్చర్ పెట్టి మిమ్మల్ని సరిగ్గా ట్రీట్ చేయకపోవడాన్ని హాస్టైల్ అంటారు. లెట్స్ సీ ద నెక్స్ట్ క్వశ్చన్. ఇఫ్ యూ సీ ద నెక్స్ట్ క్వశ్చన్, ఇట్స్ ఆల్ అబౌట్ బెస్ట్ వర్స్ట్. Best, worst, sink, question mark. Best, worst, sink, question mark. So best, worst, sink, question mark. It is so simple. Once again, it is easy. See here, బెస్ట్ వర్స్ట్ ఏంటి అన్స్ అగైన్ యాంటోనిమ్ కింద వస్తుంది. సో బెస్ట్ వర్స్ట్ అనేది మీరు చూసినట్లయితే ఇవి రెండు ఆపోజిట్స్ అవునా. బెస్ట్ వర్స్ట్ దీని రిలేషన్షిప్ ఏముంది ఆపోజిట్. సో సింక్ అంటే మునిగిపోవడం, దీనికి ఆపోజిట్ ఏమవుతుంది ఇట్ ఈస్ గోయింగ్ టు బి ఫ్లోట్. ఇట్ ఈస్ గోయింగ్ టు బి ఫ్లోట్. దెన్ నెక్స్ట్ మీరు చూడండి సాలిసిట్. సాలిసిట్ రిక్వెస్ట్. Solicit request. Then presume question mark. I repeat, solicit request, screen ఒకసారి చూడండి. Solicit request and then presume what is that? So it is so simple. Solicit request అంటే it is a meaning here. ఇట్స్ అ మీనింగ్. సినోనిమ్ అంటాం కదా ఇంగ్లీష్లో మనం, సినోనిమ్ అంటాం. అంటే సాలిసిట్ యొక్క మీనింగ్ ఏంటంటే రిక్వెస్ట్. సాలిసిట్ అన్న రిక్వెస్ట్ అన్న రెండు ఒకటే. ఆల్రైట్. సో ప్రిజ్యూమ్ అనేది ఏంటి అంటే ఇట్స్ నథింగ్ బట్ దీని ప్రిజ్యూమ్ యొక్క మీనింగ్ మీరు చెక్ చేయాలి. ప్రిజ్యూమ్ యొక్క మీనింగ్ ఇస్ నథింగ్ బట్ అజ్యూమ్. ఆల్రైట్. అజంప్షన్, ఇమాజినేషన్ చేసుకుని అనుకుంటాం కదా, లెట్స్ అజ్యూమ్ అని మ్యాథమెటిక్స్లో మనం చెప్తాం. సో ప్రిజ్యూమ్ అన్న అజ్యూమ్ అన్న ఒకటే. ఆల్రైట్. నా సో హియర్ ద రిలేషన్షిప్ ఇస్ ఆల్ అబౌట్ మీనింగ్ అంటే సినోనిమ్. సో సాలిసిట్ రిక్వెస్ట్ కి రిలేషన్షిప్ అంటే సినోనిమ్ అంటే దీని యొక్క మీనింగ్ ఏది అంటే ప్రిజ్యూమ్ యొక్క మీనింగ్ ఏంటి అనేది మీరు చూసినట్లయితే అజ్యూమ్. ఓకే. సో లెట్స్ సీ వన్ మోర్ క్వశ్చన్. సో లెట్స్ సీ వన్ మోర్ క్వశ్చన్. ఇప్పుడు మీరు చూసినట్లయితే సి లైన్, స్క్వేర్, లైన్, స్క్వేర్, arc, question mark, line, square, arc, question mark. So for this type of questions I'm going to give you options which is ring, please make a note, which is ring, and second one is sphere, and third one is circle, and fourth one is the D is ball. I repeat the question, just have a look at it. Line, colon, square, proportion, arc, question mark. Am I right? So what are the options here? Ring, sphere, circle, and then what is that? Ball. Okay. Now what is this? How we are going to solve this particular question? Now ఒకసారి మీ స్క్రీన్ ని చూసినట్టయితే see line square అనేది ఏంటి అని మీరు చూడండి. line square అంటే it is so simple. లైన్ స్క్వేర్ అంటే లైన్ ని బేస్ చేసుకొని స్క్వేర్ అనేది ఫామ్ అవుతుంది. అంటే స్క్వేర్ లో ఏముంటుంది మీరు చూసినట్లయితే ఇట్స్ కంపోజ్డ్ ఆఫ్ 4 lines. Am I right? So let's say if this is square, this is one line and this is two line, second line, this is the third line and this is the fourth line. So line is nothing but square has 4 straight lines. 4 straight lines forms a square. Now form a square. Now arc forms what? Ring or sphere or circle or ball. It is so simple. We know that arc forms a circle. For example, semicircle lo idi enti, it's an arc అని చెప్పి అంటాం కదా. So multiple arcs, multiple semicircles forms a complete circle. So it is so simple. It is a circle. Now let's see the last question. Calendar. All right. So we have discussed the calendars topic as well last day. So let's talk about calendars. Okay. So let's see another example. Calendar. Calendar, dates, proportion. Calendar, dates, proportion, dictionary, question mark. Calendar, calendar colon dates, proportion, dictionary, question mark. So calendar dates అంటే ఏంటంటే see calendars లో మీకు ఏముంటుంది? calendars లో dates ఉంటుంది. Am I right? Now dictionary లో ఏముంటుంది? I'm going to give you the options. Words, vocabulary, words, vocabulary, language, and D it is going to be book. Alright, so simple. Calendar dates అయితే dictionary ఏమవుతుంది? So it is so simple. So calendar లో ఏముంటుంది? Dates ఉంటుంది. So dictionary లో ఏముంటుంది? Obviously words ఉంటుంది. Alright, it's not vocabulary, it's all about the words and its meanings ఉంటుంది. Alright, so this is how it works. So మీరు ఇలాంటి క్వశ్చన్స్ ని సాల్వ్ చేయాలి, అనాలజీ క్వశ్చన్ సాల్వ్ చేసుకోవాలంటే యూ నీడ్ టు అండర్స్టాండ్ ద రిలేషన్షిప్. సో ఇక్కడ ఏంటంటే ప్రెజెన్స్ క్యాలెండర్ ఇస్ కంపోజ్డ్ ఆఫ్ వాట్? క్యాలెండర్ ఇస్ కంపోజ్డ్ ఆఫ్ డేట్స్. మొత్తం డేట్స్ ని కంపోజ్ చేసే క్యాలెండర్ ఉంటుంది, వర్డ్స్ ని కంపోజ్ చేసే డిక్షనరీ ఉంటుంది. సో ఇట్స్ ఆల్ అబౌట్ ద అండర్స్టాండింగ్ ద రిలేషన్షిప్ బిట్వీన్ ఏ అండ్ బి. సో నేను మీకు ఏం చెప్పాను, దీని ఏ, ఇది బి అండ్ ఇది సిగా మీరు కన్సిడర్ చేసుకోవాలి. సో ఏ బి రిలేషన్షిప్ ఫైండ్ అవుట్ చేసి ఇదే రిలేషన్షిప్ ని సికి అప్లై చేస్తే యుల్ గెట్ ద ఆన్సర్ డి అవుట్ ఆఫ్ దిస్ 4 ఆప్షన్స్. ఆల్రైట్, సో ఐ హోప్ యూ అండర్స్టాండ్, బట్ ఇట్ నీడ్స్ అ లాట్స్ ఆఫ్ ప్రాక్టీస్. ఇట్స్ లైక్ you cannot learn within a day. It's all about your practice. Try to practice as much as you can and try to learn the new words. Start reading the dictionary, start reading the newspapers. You'll get to know lots of new words, vocabulary. Try to understand the meaning, pronunciation, everything. It will definitely help you to solve the questions. If you have any doubts or questions on this particular topic, just please post in the comment section so that I'll help you out which are the books, which are the websites you need to follow to understand this. Thank you so much.
Good morning. I welcome you all for this morning's session for ESE Foundation course. Now, we had been doing these foundation courses for graduates since last 2 to 3 weeks. We have finished the portion for aptitude. Now, from today onwards, I'm going to talk about the verbal ability. But before we speak about verbal ability, it's very important for you to understand the communication aspect itself. So, today and tomorrow, I'm going to talk about the communication aspect just to give you the foundation for it before we head on to the vocabulary part, where you will understand certain elements which will help you answer questions in terms of verbal ability. Now, when we talk about verbal ability, it's imperative, it's important that you understand the foundation in terms of vocabulary. Now, when we speak about vocabulary, it's one of the 4 fundamental pillars of communication. Now, when I say fundamental pillars of communication, I am referring to the oral communication. Now, the question would be, what is oral communication? Is it verbal or non-verbal communication? So, we have to take few steps back to understand the foundation. That's why in next few sessions, I'm going to talk about the foundation, the fundamentals of communication skills. Then I will move on to the verbal ability part. So, we often tell each other, or we make this observation and comment that the communication skill is very important if you want to succeed in life. Now, what do we exactly mean by communication skill? So, communication skills is, or rather communication. So, how would you define that? So, whenever 2 individuals are getting into a conversation, there are 2 people talking, it could be face-to-face communication, it could be a written communication. What exactly happening is there is an exchange of information, there is a transmission of data. What you see here is that 2 individuals, there is transmission of data happening, and the transmission of information happening and exchange of data. All right. Now, if we go further, now we need to understand what is a communication cycle, and I have mentioned this as a myth. What do we mean by myth? Myth is something that you think it is right, but actually it's not. The reason you think it's right because this is how you have been trained and this is how you have been taught. So, when we talk about communication cycle, we have learned in our school that there is a sender and there is a message, or there is an information, there is a message, and there is a sender who's sending this information, right? Now, there has to be a receiver. Now, once the receiver receives the message, he sends a feedback. Now, think about this aspect. Is the feedback always necessary? So, if we look at an example of a billboard or a hoarding or a newspaper, or if we have a news for that matter, if we are watching news, we are receiving an information, right? But we are not sending any information back, which means this feedback is always not necessary. But in our school, we were taught that this feedback is essential. The feedback, if it's missing, then the cycle is not complete. Now, this is wrong. There is no such thing that in case there is no feedback, the cycle is incomplete. It doesn't really hold water. Now, what do I mean by that? I showed you some examples, like the hoarding. Say, for example, you're walking by the road and there is a hoarding which says sale, 50% sale or 70% sale in Big Bazaar. Either you go and buy or you don't buy, but you have received the information, correct? If you're reading something in a newspaper, you have received the information, you are watching news, you see the newsreader say something and you receive the information, but you are not sending any message back, you are not sending any feedback, but still the communication is happening, you are aware of it. That's why we say that the feedback is not necessary, and hence that's a myth. Now we need to know what are the essentials of effective communication. We always use the word the communication is not effective, the communication is not good. There are certain essentials which is very, very key for an effective communication. Now there are 6 essentials of effective communication. These are assertiveness, authenticity, open-mindedness, empathy, clarity, and listening skills. Now let's understand one by one what do we mean by this. Assertiveness basically means your ability to say no to a person or decline something without offending a person. Say for example, if somebody comes and asks me for some money, I can either say no, I will not give it to you, or I say fine, I will give it to you. Now this is an essential aspect of a human behavior. In order to understand that, we need to look at 3 important elements. Let me quickly make a note of this here so that you understand what do I mean by this. So 3 important elements. I'll first type it, then I will zoom it so that you can see it clearly. Okay, so it is aggressive, submissive, assertive. Now what do I mean by aggressive? Aggressive basically means where you are showing force, you are showing aggression, you are being harsh, or that is basically called aggressive. For example, if somebody is asking for 100 rupees and I say sorry, I'm not going to give it to you, I'm not using the word sorry and I'm being very violent in terms of my body language, or it could be in terms of the words that I'm using. I'm being harsh, I'm being rude. Now that's an aggressive behavior. Submissive means the moment the person is asking, I'm taking money out and giving to that person. I'm not even contesting, I'm not even protesting, which means whatever the other person asks, I submit myself to that person. I don't exercise any kind of restraint. Assertive basically means your ability to say no to a person without harming that person, without making that person feel bad. Okay. Now, when we talk about effective communication, it's very important that our communication is assertive in the sense we use words, we use a language, we use vocabulary that is considered more polite. At the same time, you stand your ground. You don't really submit yourself, and you still stand your ground. Say for example, when the moment the person is asking for money and I say that I'm sorry, I just have 100 rupees and I have saved this money for my lunch. If I give it to you, I will have to go hungry. So that's why I request you not to ask for money. Now I'm explaining the situation and then I'm saying no to that person. When we talk about aggressive behavior, I don't give any explanation whatsoever. I simply say no. When I say submissive behavior, I don't look into what my issues are or my limitations or problems are. I immediately accept what the other person is saying. So that's a submissive behavior. Now, essentials of effective communication, like I said, is assertiveness, because it allows you to make your point without hurting the other person's feelings. That's why it's an essential. The second point is authenticity. Authenticity basically means whatever you say, you build an element of trust, the other person believes in you. Now, when we talk about authenticity, we basically mean when you are speaking to a person, whatever the person says, you you end up finding a lot of truth in it, you believe in it, and it helps you build trust. You must have come across a lot of people that you cannot trust because whatever they say is actually not true. What happens in a situation like that is the element of trust recedes, it falls. Now that I'm saying that it's an essential of effective communication, whatever you are saying has to hold water, has to mean the truth. Otherwise, you will lose the trust from the other person, and hence that's an essential aspect of effective communication. The third point is open-mindedness. Now, what do we mean by open-mindedness? Let me show you an